Welcome everyone to NextMed Health. We're coming to you live here from the Click Studio in the wonderful Crown Hall and the Innovation Hall, where we're amongst the presence of a lot of the greatest technologies. I'm here with my colleague and nurse extraordinaire, Shauna Butler.
And your co-host for this whole week. Hi, I'm Shauna Butler, and I am so glad to welcome you to NextMed Health. And for those of you who are joining us remotely, this show's really for you to make sure that you're following along. We want to make sure that you're set up for each one of the days, each one of the sessions to know what's coming up. And actually, as we're NextMed, what's now, near, and next.
And I love that because quite oftentimes we think about the future of healthcare only things that are, things that aren't going to necessarily impact us on a regular or daily basis. Now, near, and next is really about the relevance of how it's going to impact us in our current environment. So I'm really excited about the sessions ahead. Shauna, you've been working on this agenda for quite some time, in this program for quite some time. Can you tell us a little bit about how you've curated the speakers and the categories and topics that we're going to hear about?
I am. I'm really excited to talk about the program. But before we do that, I want to make sure our audience knows who we are, because we're asking them to trust us with all this information. So, all right, a little bit of an introduction.
Well, I'm Dr. G, Dr. Gautam Gulati. I'm a physician who's been on the innovation side of healthcare for a couple of decades, and I've seen many different angles of innovation from small companies to large companies. I've even built companies myself. So this event and the iterations of NextMed Health have truly had a personal impact on me over the course of my innovation career. In fact, I've probably met most or many of my collaborators, my peers, my colleagues. We've consumed a bunch of ideas together at these events that have been hosted here for over the past over a decade now. It has.
It's been a while, and your story is not unique. One of our favorite data points is how many people, when they've been to in our previous lives, pre-pandemic, in another era, we were known as exponential medicine. And so much of the time that we spent, we were really helping people to understand how to think exponentially. How do you use these tools and these technologies and these platforms to solve a problem for 1 billion people in the same period of time with the same amount of effort? And I think what the pandemic demonstrated is that we can do hard things. We can do them fast, we can do them safely, we can do them even on budget, sometimes even under budget. So as we've all changed and the world's changed, we felt like we needed to change as well. Because at this moment in time, when we talk about the future, what's the future look like, we can't wait. We need these things now. NextMed is really looking at what's now, near, and next.
Yes, and you brought up COVID, and I think the pandemic, interestingly enough, has pretty much brought about 10 years worth of innovation in the span of 2 years. Mm-hmm. So we have a lot of catching up to do.
We do. And it's interesting, I think all of us are having this sense of time just feels like weird, I guess is a good way to put it. And one of the things too that I'm really looking forward to doing this with you is, you and I both are storytellers. So just a little bit about me, Shauna Butler, I'm a nurse economist. I've spent most of my career really trying to understand how nurses drive clinical and economic value, particularly when we think about, we want more health, we don't want more health care. We want to be healthier. We want to be healthier communities, healthier environments, healthier individuals. And that's really a role that nurses play quite a bit of. And so a lot of the work that I've been doing has been not only putting together this program, but on a pretty regular basis, hosting and producing the See You Now podcast, which is looking at all the problems that show up in society, how they come through healthcare store, and specifically how nurses are leading teams to address and solve those challenges. And I know you've been doing a lot of story work.
I have, but before I talk about some of the story work that I'm doing, I think you brought up this notion of how nurses are really on the front line and really understanding some of the challenges that we're seeing in the healthcare environment. What I love about NextMed Health, it really brings in the perspectives of all stakeholders in healthcare, right? So physicians, nurses, the business folks, the scientists, the research, the patients, we all have a seat at the table here, and that's what drives innovation, is if we can all be collaborative together and moving that forward.
Well, I was just going to say, so part of what we're thinking about with NextMed Health and part of the programming is that these challenges that we experience through healthcare's door, they're not something that healthcare alone can address or solve, because they have to do with our housing, they have to do with our policies, they have to do with the climate, they have to do with data, they have to do with privacy. And so a lot of those tools or those particular challenges, they're not housed solely or even specifically within our healthcare systems or our healthcare domains. And so it's really important that we start thinking about the different technologies, the different partners, the different sectors that are going to be really important. So as we think about this programming and what people are going to experience over the next 4 days, is thinking first of all at a system level. And so today we're going to be opening up, just really thinking about what are those grand challenges, what are the technologies, and who are the people, what are the groups that are thinking about them in new and novel ways, new and novel partnerships, and starting out at that system level to understand that most of our challenges are structural. So we've got people who are working on the ground with a very specific pain point or a very specific technology or a condition or a diagnosis. But they oftentimes run into roadblocks because they're system level barriers. They're things that we could do better, or we're still working off of a system that was dealing with non-digital, with very analog technologies. So in order for so much of this promise to come forward, we really have to think at a system level. So specifically,
are we truly going to see the fax machine go away now?
Yes. Well, I'm on a mission to solve that. I hope everybody else is on a mission because, oh my goodness, faxes, yeah, it's true.
It's still there. I mean, from a security and privacy standpoint, institutions still use them, right, unfortunately.
Yeah.
But
So yes, we won't be talking specifically about how we're going, but I guess in a thread, there's a way.
But you're absolutely right in terms of the system thinking, because we can all innovate on sort of a micro level in terms of our microcosm of environment, but at the end of the day, healthcare is a system. It has to sort of plug and play with everything else, and a lot of that oftentimes requires some sort of compromise to some degree.
So what I want our viewers to be paying attention to is, first of all, please join us on the live stream, nextmedhealth.live. No, wait, nextmed.health/live.
There you go.
And when you go there, you'll be able to watch the live stream, be able to share it, but that's also where you can go and look at the program. So a little bit on the programming today. Daniel Kraft is going to open up. He will be talking as fast as ever because we have a whole lot of ground to cover.
If you haven't seen his talk, I highly recommend you watch the opening because it goes at lightning speed with probably about 150 slides, but it is the most impactful and powerful view into the future of healthcare.
So then we've invited Stacy Chang. So Stacy Chang is a design thinker. He's an incredible career and portfolio of work, but when you think about working at the system level, for many years he ran the healthcare practice from IDEO, with IDEO, and then he moved into another academic space where he was the Design Institute for Health at UT Austin, at the beginning places of when we were launching the newest medical school, the Dell Medical School at UT Austin. And from there, he's moved on to so many other projects. But at the core of all of this work, he's been thinking about really large systems in many parts of the world and seeing the commonalities of how do you actually design a system that designs for health, not just the care or for illness. And so he's got a really provocative idea about what needs to happen to think about provoking and supporting and incubating systemic innovation. So I don't want to take too much away, but every time I ever hear Stacy talk, I have a huge new insight, a huge new pathway, and a very big paradigm shift. So that's going to be opening up where we start.
I'm really fascinated to hear what Stacy has to say. Well, first of all, he's a brilliant and an amazing individual. But healthcare, when we think of systems thinking, we can't necessarily apply things from other industries because it's one of the only industries in healthcare that actually has a third-party payer system. And so we design for systems thinking in healthcare or system innovation. Oftentimes the incentives aren't aligned. So I'm really curious to hear what Stacy has to say.
And because he brings a perspective from, there's not a place on the planet, a country on the planet, health system on the planet that he hasn't been a part of, studying. So his perspective is priceless. And then we're going to go into, of course, the big moment right now is AI, ChatGPT, Web 3.0, Metaverse. So we've got this incredible session that we've got folks who are coming in from Mayo Clinic. You know Alfred Whitehead.
I do, yes.
You spend a lot of time with the Click team.
Yeah, he's literally a rocket scientist. I mean, that is his background.
Yeah, he is.
Absolutely brilliant.
And we're also going to be hearing how AI is transforming the surgical experience. And then we have this other really fun surprise. If you thought surgery, if you didn't understand the raw nature of surgery, you are going to find out today. So you do not want to miss this world premiere of a very, I don't want to give too much of it away, but just be tuned to rock out and think about how we're going to rock out in the OR.
You've definitely intrigued me.
All right, then we're going to have another section, genomics. So we have a couple of folks here who have really been thinking deeply about genomics, not only how they transform, how we deliver care on an individual level, but how as a nation. So we've got two folks here who from the UK, from Genomics England, Baroness Nicola Blackwood and Chris Wigley, who's, I think his title is that he's the Executive Director, CEO of Genomics England. So they're going to be talking about how they are using genomics on a system-wide basis. And because in the UK they have a national health system, the NHS, they have a really interesting play and some interesting things. That's
the 100,000 genome product?
Yeah, and they can do some things with genomics at a population level that very few countries can. So we need to learn and hear what they're doing. Then we're going to hear from our other friends from the Netherlands. So Lucien Engelen is here with his group of Dutchies, which we're always so glad to have them here.
It's always a fun crew.
Oh my gosh, do the Dutch know how to have fun?
Next time, if you're not here, you should be here because you'll experience it in person. Be here.
So he's going to share a little bit about, what I love about Lucien's point of view is he does a really good job of looking at demographic forces, technology trends, and business trends, and really synthesizing them together to really point us to where the trends, where the demographic trends and where the technologies are pushing us to, and how there's almost this really natural convergence of how they work together. So we've got some interesting, he always brings some interesting perspectives. And then we're going to be talking about precision well-being. Jamie Metzel, who's with the Atlantic Council, he's going to be talking, every time Jamie comes to speak, he always has a perspective at the policy level of how all of these technologies, how they meet us to where we are, and then what are the policies that are going to facilitate better uses, more equitable uses, making sure that we don't lose the humanity. So again, they always surprise me. I have a general idea like what they're going to talk about, but you don't want to miss those things. So anyway, and then people are going to be coming into the innovation lab. We also our closing keynote will be from Leroy Hood, who has been a pioneer. Yeah, he has been a pioneer in all the different thinking about systems level biology. So again, this is somebody who has crafted a whole new area of thought leadership, a whole new area of science, and talk about an icon, a legend. He
really is. Yeah. He's absolutely brilliant. I'm excited to see what he has to say. You know, you brought up, I mean, I don't even know which one I would choose in terms of my...
Well, the thing is you don't have to, because it's all
going to be here.
So be able to join.
What are you most excited about personally?
Well, what I'm most excited about is that the show is going to get ready to start in just a few minutes. And the other thing that I'm really excited about is that I get to have you here as a co-host. And you know what, it's a special day, and I actually have something for you, because...
that is, you're too kind. Thank you.
Thank you for having a birthday, because a lot of people don't get to have them. And having birthdays are really important, and I don't think we want to go by without being grateful for the years and lives that we have. And that is one of the things that's very different about NextMed and NextMed Health is we always start with the why. So these technologies are super cool. They're super, super interesting. But at the end of the day, why do we do this? It's because people's lives matter. The people who are receiving care, the people who are seeking care, the people who are delivering care. And we're back here, and you can hear all the buzz in the Innovation Lab, and it's so exciting to hear all of that, because for so long, we weren't able to gather. And we have not lost sight of that. We've all changed, and we're all moving forward. We're all incorporating this. We will be living with COVID-19. It is just a part of of society.
I mean, I love that you brought that element up, because at the end of the day, we're humans, and we need the interaction, and I think it's important. Technology is fantastic, and I think it's always good to sort of reflect back and understand that even back to the whole story element, right? Patient care, healthcare is just about stories, right? What we're ultimately trying to do is change the narrative of the individual so that we can give them the best life possible. And the tools that we have available and the technologies that we're going to talk about are essentially going to get us there. And that's the ultimate goal. It comes down to changing the narrative and the stories of individuals to giving them better lives.
So what I'm excited about is that we're here, we get to learn together, we get to grow together, we're going to address these problems together, because that is the only way we're going to get ourselves out of this, is we are all in this together. And with that, however, even though we're together,
you need to get up on the stage. That's right.
So,
well, thank you so much.
See you guys later, and I will see you guys on stage. And happy birthday.
Thank you so much. Well, I guess I need to make a wish. So I am going to blow this out before it catches anything on fire. Thank you to the NextMed Health team and Click and everyone for helping me join me in celebrating my birthday. So we have a couple more minutes before we go live on the main stage. As Shauna pointed out, lots of great programming ahead of us. I'm excited. I don't even know which ones to pick, but for me personally, I think, of course, all the buzz around artificial intelligence and generative AI, to hear some of the latest developments. I know we're sort of just starting out in that space, but really trying to understand and project forward, like it's here now, but what is that going to mean in the near and the next future for our healthcare? Because I do think it's going to have significant implications, not just in healthcare, but across the board in a variety of industries. I'm also really fascinated by what we're going to hear about the science of longevity. Maybe it's just a factor of my age and my birthday just coming through, but how do we live longer and live healthier? Essentially extend our lifespan, but also extend our health span. And the science recently, if you've been tracking over the past couple of months, has really been mind-blowing in terms of our understanding of both genomics as well as our epigenetics, and how we can alter the sort of software code of our bodies to perhaps create a longer, healthier life. So I'm really excited about longevity and how that can impact us as a population, but also me personally, as I'm sure many of you might be interested in that as well. And then lastly, the care at home experience. I think that's often an overlooked area. We're going to have some conversations about it. A little bit of a shameless plug. I'm speaking about a care at home experience for my venture called the Well Home on Wednesday morning at 10:15, 10:20. So if you're still watching, you can check me out there. But I think oftentimes I like to say healthcare is a story over time, not a point in time. And so as such, we oftentimes ignore as an institution our healthcare, which happens on an everyday basis, and most of that time is in our homes or outside of the healthcare system. So those are the three big topics for me that I'm really fascinated about. But as we sort of gear up for the main stage and for the kickoff, definitely check out Daniel Kraft's opening. You'll be absolutely mesmerized and taken away by his sort of setting the stage for what's going to come ahead and what he has to say. But a couple of housekeeping things. We want to make this conversational and interactive as possible. So this is not just myself and Shauna sitting here talking to you. We're going to come back later on during the breaks, and perhaps even at the end of the day. We're going to be looking on Twitter and seeing what kind of conversations. If you want to ask us questions or you want us to bring somebody into conversation here to have a seat and ask questions, just bring it up on Twitter. We'll sort of be tracking where we can. The handle is @NextMedHealth. That is @NextMedHealth. And also use the hashtag NextMedHealth. So hashtag NextMedHealth. We'll be tracking. We'll be looking at some of your tweets as they come throughout the day. Perhaps we'll raise a couple of questions here. So keep this as interactive and as conversation as possible. The link that I believe Shauna had mentioned before, nextmed.health/live. So if there's others that you think should be joining, please send them an email with that link. It is perfectly free to watch and sign up. We know that it's oftentimes difficult to sometimes come on site and be here in person. So I think it's a great resource to be able to live stream this. And we will try to do our best in reporting out what we see here in Innovation Hall, the side conversations that were happening, the buzz that's happening. You obviously don't get to experience some of the fun that happens at nighttime, but again, we'll try to give you some interesting recaps as they develop. But again, I think this is a great resource for those who are around the world, and we do have an audience that's watching from a number of different countries around the world. So thank you for being here. Thank you for watching. We are about to gear up here for the main stage, of which you're going to hear Daniel Kraft, and then followed by Stacy Chang, who's going to set up systems thinking, as Shauna talked about, and then really followed by a number of the technologies that we've seen come into the marketplace over the past couple of years, really, since we haven't really been in person. But again, COVID and the pandemic has accelerated a lot of our innovation. I think I'm truly excited for this time period. I think never before have we really been at a juncture where not only have we learned from the mistakes of the past and a lot of the investments that have come into the space of healthcare, but we're starting to see the real world applications. And in the process, of course, when you look at paradigm shifts, some things fall away to the wayside and some things thrive and scale perfectly well. But healthcare, as you know, is a very complicated system, a very complicated industry. We have lots of new players coming into the space, from household names like Amazon and Apple and CVS, all trying to make their mark. And we also have a number of young new startups, of which many are here in this innovation hall, really getting a touch and feel of some of the available innovations that are going to be available to us. A lot of great VR tools and AR tools, incredible scanning technology that I've seen around here, some genomics and testing. I think there's some interesting MRI tools that are in here, but really the whole gamut is present here in the Innovation Hall. And we'll come back to you and try to do our best in terms of what we're seeing on the floor as we interact ourselves. So again, I encourage you to stay active, interactive, make this conversational. I'll be checking after this as we go on main stage some of your tweets, and enjoy. Really, this is time to take notes, sit back, and understand where the now, near, and next future of healthcare is going. So I look forward to joining with you.
Our program is about to begin. Please take your seats and silence your mobile devices. Ladies and gentlemen, please take your seats. Our program will begin shortly.
Welcome, everybody, to our first NextMed Health. Very glad you're here. Woo! President Biden landed, but he's a little bit late to join us, so sorry about that. You guys are here from all over the globe. Really grateful you're here. Huge welcome. It's amazing to have this amazing community gather here to imagine the future, to reimagine the future, to collaborate, converge, and conspire to build a better future of healthcare and medicine for all of us around the planet. And just as a little bit of framing, you know, this is actually a convergence of a continuum. Back in 2011, I helped co-found a program initially called FutureMed with an intrepid crew. I think we have some original ones from FutureMed back here. Amazing. Who came together at Singularity University, and it was sort of a unique experience where we kind of broke open the silos from across different fields as opposed to the usual sort of siloed meetings we went to. And it opened up a lot of new relationships, a lot of new innovation, which you'll be hearing about, because some of our original participants then are now NextMed faculty. And 10 years ago, exactly, we had our very first, what was then called FutureMed, here at Hotel Del Corno. So it's been a decade, just to give you a little framing. And a lot of things have obviously happened. And I'm really grateful that we can continue this journey from where we've sort of been, from FutureMed to exponential medicine to now NextMed Health, and sort of take this into the next generation. So thanks for being part of the tribe. And also welcome to everybody who's also joining us virtually. It's part of, I think, a whole continuum of collaboration and new thought leadership and relationships that's really going to take us forward into this future. So, NextMed Health. How did we get here, and what's going to be happening next? We have an amazing set of faculty and programming you're going to hear about. But I think when I think about NextMed Health, it's like what's now, what's near, what's next. At this sort of convergence of what are the big problems, what are the new breakthrough technologies that are here and are coming, and the big challenges that we can all sort of address together with new mindsets and new energy. And so it's a real opportunity to kind of go from where we are now, still in our sort of sick care era, to a new future of what's next, hopefully for all of us in more accessible and equitable ways around the planet. So as we go to that next, it takes a huge team. We have an amazing cohort of production team and faculty and collaborators. And one of my favorite collaborators on my right hand for this entire journey for many years now is the amazing Shauna Butler. So I want to bring Shauna Butler out.
Hey.
I think she picked the color scheme, right? You know?
Am I on brand or what?
I'm a blue guy, but, you know, we can change, right? So
I don't know, can we?
We can.
Yeah. So, yes, we can. I love that. I love that. So, first of all, Daniel just talked about who's actually here in the audience, because there's an awful lot. I mean, I didn't get to see the show of hands. Who's been here in the past with us?
All right, the tribe.
I love that. Okay, so who's first new? Because pay attention. All right, so the hands that went up first, I want you to meet the hands that just went up last. And we have so many people who are joining us online. That's fabulous. And then actually when we think about, this takes a lot of production to make work. And so we've got these amazing folks who actually asked to come back and be a part of the production. So it takes a lot of folks to make this happen. And we're just really grateful that you're here. So, but the other part is, why are we here?
Well, we're all here, I think, to make a difference, to get out of our old mindsets and into this new era of what's next.
I think you hit on the right word, era, because who among you have have changed. I know I certainly have. It feels like we're in a different era. And what we had been doing with exponential medicine is we spent a lot of time helping people to think exponentially. And what we saw during the pandemic is we know how to think and behave exponentially, to pivot fast when we need to develop new ways of doing things using technologies that we just pulled off of the shelf. And so one of the things that we found is that it's not just what's happening in the future. We need to be focused on what's now, near, and next. And so that's really a lot of why we're here, is we can't wait. You know, there's a lot of, we saw in the pandemic how it really revealed we're able to use the technology, but that how many times we said it's already here, it's just not evenly distributed.
We went somewhat from incremental to exponential, and sometimes people label me as a futurist. I say, no, I'm more of a nowist. Like, a lot of these things are here now, and they're not evenly distributed.
Yep.
And it's our opportunity to connect those dots, and in some cases, bring the future a bit faster.
Yeah. So that's who's here. It's why we're here. What are we going to do while we're here? So we have an amazing program. And I mean, you know, we say amazing, that word gets overused a lot, but we're starting to think about really big systems. We talk about that at the highest level. And then over the next couple of days, starting today, not only are we going to look at this at a system level, we're going to be looking at very specific technologies. We're going to be looking at very specific challenges within the entire continuum of care. We're going to be thinking about very specific conditions, very specific ways we reveal and surveil and track our data and convert that into insights that become actionable and part of our care. What are you really excited about for today? Because we have so much going on, but for today.
I'm excited for you guys to open up your minds and meet each other. We'll have a break in the Innovation Lab, we'll have an evening party. A lot of the magic is just the people who meet here. And that's what often excites me the most. And a lot of things have come out of that. New companies, new partnerships, new patents.
New friendships.
New friendships. And one of our goals for NextMed Health is not to be a once-a-year amazing convergence here at the amazing Hotel del Coronado, but to have a bit of a blended, virtual, hybrid type of community that can expand around the globe and really catalyze things.
So one of the things that we're going to ask you to do, a couple of them, first of all, is you need to meet each other. Don't sit next to people that you already know. I know that we all want to get back together, so yes, spend some time with friends, rekindle that. But be intentional about going out of your way to introduce yourself, to make new friends, to talk about what are the things that keeps you interesting, what keeps you interested. Some really incredible folks that are here doing remarkable work. I like to refer to this as like Disneyland for clever optimists. These problems are hard, and you guys really take a, you dive deep in to say, give me that technology, let me take it to the problems that I'm seeing, how do we make this work? So that's a big part of what you guys need to do, is spend time listening, absorbing, interacting with these ideas, interacting with each other. Spend a lot of time listening to these companies in the innovation lab, seeing some of the things the problems that they're working on and solving. And then the other part is that as we, you can tell we have a lot packed in. So one of the things we really need you to do is, like, when you hear that music, get on in here.
Awesome. Be on time. Thank you. And so, convergence, we have a bunch of sort of C's we came up with: connection, collaboration. Some people call this the Burning Man of medical conferences at a beach. I don't know. Some of you have been to Burning Man. Some have come with me. And we'll have Paul Stamets here to extend that perception later. So it's a real opportunity, again, to get out of your usual mindset. So try and turn off your phones and be super present.
But before, I was just going to say, there's something really magical about the Dell being here. There's a history here. We're kind of sequestered from the rest. It's not easy to, like, just drive into San Diego. And why would you? We've got this incredible beach. And so part of it is that while we are in this gorgeous setting, make sure that you take advantage of that. What I love about being here at the beach, first of all, I'm at my best self when I'm around tidal water. And there is something about the rhythms of the sunset and the tides that really connect us to who we are. Because we've talked a lot, we'll talk about data, technology, all sorts of system challenges, political determinants of health. We're going to talk about all of that. But the major reason that we're here, and why all of us do this, is because we care. Is because there are people out there who really need us to be reminded of why we're here, what our stories are. No data without stories, no stories without data. And so a big piece of while you're here is being reminded of our own humanity. How do we develop these technologies and do it in a way that humanizes us, that it doesn't take away our humanity. So if the shades were up, I would invite you to look outside and make sure that you take a look at that really, really gorgeous coastline. And actually, you know what? Magic, like I said. So why don't you just take just a moment, because you don't want to miss this. It's part of the magic that's here. Yeah.
And tomorrow morning, you can do a meditation with Swami at the beach, or go for a run, or learn how to juggle, or do some art. So we want to take full advantage of our amazing Hotel Del location.
Isn't that gorgeous? Yeah. We keep the curtains down so that we have a better experience of the visuals, but I don't want this to get lost on us.
Okay.
This is
All right.
really
That's enough of that. All right, close the shades. All right. So we have a live stream going on, so please share that with the world.
Yep.
Our idea is to sort of democratize knowledge and cross-fertilization, so nextmed.health/live, lowercase l, and make sure that others can share in this experience now and going forward.
Okay, so with that, like I said, we have this amazing set of folks here. We have people joining us online. We have incredible faculty. We have rock star team of producers. And we also, in order to make all this happen, we need partners. We need their expertise. We
Amazing
need
folks
their
at Click.
Yeah, we need their creativity. We need their financial support, and that makes so much of this happen. So we want to make sure and call them out. Because we've called on them and called them in, and they have risen to that. So thank you so much to Deloitte and to Click and to Carillon and to CareQuest, our systemic health innovation partners. You'll get to meet and hear more about them. Fountain Life, you just won the
Rainbird.
Rainbird, sorry. But I say that from the standpoint of it is genuine. I want to make sure that they know how much we're loving on them. With that, I think it is time for you. So I would like you to buckle up, open up your ears. You will need to listen fast, because this guy does not talk slowly. With that, have fun.
All right. Thanks so much, Shauna. Okay, hopefully this is my other deck. So we can switch over there. I'm going to try and give you like the usual 20-minute convergence of a bit of what's now, near, and next, kind of a bit of a frame setting for what's going to come in the next 4 days. And, help us sort of think about where we're moving, right? Our era is now much more digital, somewhat more super connected, a little bit more intelligent. It's being more and more data-driven, and hopefully it can be more democratized around the planet. And it's enabling us to have new skill sets. I got up this morning, I was feeling inspired to do some sort of digital art. And of course, I didn't do that digital art by myself. I had a little bit of help. We've all been getting new help from platforms like DALL-E and ChatGPT. It's really quite incredible. We're going to be discussing the implications of GPT-3 and soon to be released, rumors that this week potentially, ChatGPT-4. So huge implications across health and medicine. I think it's almost a bit of a frame shift, almost like when the Gutenberg Bible came out, or when we first experienced the internet some 25 years ago. So I think a lot of things are going to be riding that edge, and it can even start writing talks for you from different ways. I'm sure you've all been playing with it, and there's going to be many, many applications that we'll be exploring. And I think we'll almost enter this new era of what I like to think of as almost generative health. We'll all have our own sort of health avatar that gives us the right AR experience, the right music, the right diet, in a way that is matched to our personality, age, culture, with the right nudges at times. So huge elements, I think, are going to come out of this generative forum. So watch that space. We'll be discussing a lot of it later today and over the next couple of days. So of course, health is the focus. I think more health than on the sick care side of the occasion. Health, of course, is wealth. And a lot of what we're going to be discussing is not about any one technology or buzzword, but how they kind of super converge and give us this opportunity to move from often the sort of siloed universe to this sort of new medi or metaverse into this new health age. And we've seen a lot of changes happen, even since the decade we started here at the Hotel Del. What used to fit on a desktop now fits on your FDA-cleared wearable device that can diagnose conditions or guide care. And if I look back, to when I was a Stanford medical student, most of these technology fields at this sort of convergence didn't even exist, whether it's computational biology or designer antibodies or AI meets radiology or CRISPR-based gene editing, or induced pluripotent stem cells. I mean, a lot of these have only been tools we've had for the last decade or so, and are now giving us this opportunity to really rethink and reimagine health and medicine, not just now, but into this next health age era. And so our goal, again, over the next few days, is to think about where are we now, what's coming in the near term, and what is that next 5 and 10-year perspective. So when we're back here in 2033, we can say we really played a role in accelerating next. And again, not just on the disease side, but thinking about precision wellness. We're going to have Leroy Hood as our keynote this evening, a real father figure and instigator of precision wellness and phenomics. And that helps us think not just about, living forever, that's a long time, but health span, the quality of life. We want to be 120, make it the new 60 or 70. And we've seen that sort of emerge over the last few years. This is a picture of my wife's grandmother holding my 8-year-old son's hand in Jerusalem last December. She turned 104, right? And she's amazing. She speaks 7 languages, 104. We're on her 100th birthday as well. And also thinks not just about the social determinants of health, but even the social determinants of health that have helped her live a pretty healthy 104 years. And we're going to see lots of changes in the health span space going forward we'll be discussing. But we're still in the now, right? We need to understand where we are, where we're going. If I go back and visit Stanford or MGH where I trained, we're still in the fax machine era. We're still getting paper forms. When I had a cardiac study done a year ago at Stanford, I got my results on a CD-ROM. I don't even own a CD-ROM player anymore. I'm not sure about you. Can I borrow yours? So we're still sometimes stuck in the old, not just mindsets, but the architecture of the past. We're still back to waiting rooms. Telemedicine has certainly emerged over the pandemic, but it's somewhat shifting back. We're still seeing lots of new data, but lots of old silos in how we organize our data or even organize our healthcare information. So we have a real opportunity to connect the dots into a new integrated biomedical, just-in-time health database that will be hopefully available to all around the planet. And as we go sort of forward into this age, we need to think about disruption, of course, and many of you are disruptors. We've seen all sorts of fields be disrupted over the last 10, 20 years from how we do our digital banking and entertainment and beyond. And of course, since we were last year, we've had pretty horrible disruptions from the COVID pandemic, which certainly isn't over, but in a sense was a bit of a catalyst, right? It reminded us that many fields have reached that 4th industrial age, but health and medicine is still often stuck in the 3rd or maybe the 2nd industrial age in some parts of the world, including here in the United States, where we spend more per capita but are way down on the list in terms of outcomes. So the optimist in me sort of looks at COVID as a bit of a chief transformation officer. It really helped spur things. What used to take 10 years often happened in 10 months or 10 weeks. And we need to take some of that energy going forward. And to remember some of these big seismic shifts, just like Sputnik set off the space age, COVID has sparked a bit of a new health age. And at NextMed Health, we want to be the instigators of keeping that health age moving and accelerating going forward. And that was the topic of a TED Talk I did a couple years ago. But it's a reminder that we can't lose that sense of urgency. There's all sorts of grand challenges, and it doesn't take a pandemic to catalyze them. So here we are back at the magical Hotel Del Coronado for NextMed Health. And again, it's been 10 years since we were here. We have some amazing faculty returning, including Dr. Tony Young bringing a bunch of his NHS clinician entrepreneurs. Are the NHS in the house yet? We have a few of them. Awesome. And I love this quote that he shared a few years back on this stage from John Maynard Keynes. The difficulty lies not in the new ideas, but in escaping from the old ones. And a lot of people here have the new ideas, but sometimes our colleagues outside of this room and outside of NextMed Health might be stuck in the old ways. So we have to think about not just the technology, but moving our mindsets forward. So, again, we've been here 10 years in our new iteration, and it's time to think about this next decade. And so as we go back 10 years, where we are and where we are next, again, we don't want to have a failure of imagination. There's one of my favorite quotes from Bill Gates. Those people tend to overestimate what they can do in 1 year, and underestimate what they can do in 10 years. The last 10 years were pretty amazing, but the next decade is going to be quite surprising and is only going to continue to accelerate. So where were we 10 years ago, right? Genomics wasn't new 10 years ago. It was about 10 years into genomic evolution, but I could meet a cousin through my 23andMe. Esther Dyson, we're the funders of that company, is on our faculty. 10 years ago, it was about a $10,000 genome. Now we're arguably at $100 or $200 US. That's going to give us all sorts of opportunities if we can connect the dots. We've had our genetic information for a while, but still getting our pharmacogenetics into the workflow of a clinician might be a problem. We're going to start understanding diseases at the genetic level and defining it not just as type 2 diabetes, but as one specific subset, and really having that part of the workflow of the clinician and of the patient. And it's not going to just be, of course, genome. We're going to be talking about the proteome, the exposome, the sociome, the microbiome, all the sort of elements that when you take them individually are okay, but when we mash them up into this often over buzzwordy digital twin era, will start to give us new insights that are data-driven and can be truly personalized. So I think we're entering this true era of the digital twin, which will enable us new ways to do precision wellness, optimization, early diagnostics, and much smarter personalized therapy for those who need it. So, of course, exponentials haven't gone away. I think you're all familiar with exponential technology. Moore's law is continuing, despite the fact that the physics are reaching their limit on transistors. Quantum computing is likely to be playing a huge role in everything from drug discovery to understanding our digital biomarkers over the next few years. So watch that space. And of course, our mobile devices continue to accelerate. My iPhone 14 is already antique. Rumor has it the Apple augmented reality glasses will be out this year. That'll have a ton of healthcare applications. They might soon dissolve into our contact lenses and give us augmented reality for a surgeon or for a patient or anybody doing a workout and wanting to visualize the world in new ways. And these often start a bit kludgy. You know, you don't want to be over hyping things, but they have tremendous opportunities to give us new ways of interacting with information. Digital coaching that match our age, culture, language, nudges that will make us work, not others. And of course, we're at the super age of augmented, virtual, and extended reality. 10 years ago at NASA Ames, we had the founding team from Google Glass. I still have my now broken Google Glass. And Raphael, you'll hear from Raphael Grossman, who then from that meeting become a huge instigator of taking AR, VR, and XR into the operating room and beyond. So tremendous opportunities now to take all these massive data sets and make them actionable insights at the point of care. And I think what this is going to enable for all of us, whether it's ChatGPT or beyond, to kind of go from what's equivalent of driver assist to clinician assist in many endeavors and upskill almost all of us around the planet to provide better self-care or better health care. So other tools, of course, that advanced. Virtual reality isn't just for putting grandma on a roller coaster. That's always fun. But we'll hear from Brendan Spiegel and others about the ability to use VR for therapy, whether it's for physical therapy, for treating pain. I spent 100 days straight doing VR workouts early in the pandemic, and on my Apple Watch, I could track that my resting heart rate went down by 10 points. The gyms were closed, but the VR wasn't. So new ways to get engaged. And we'll hear from our longtime faculty member, Shafi Ahmed, about medical education in the metaverse and enhancing surgical education and beyond. And of course, diagnostics. You know, where are we now? We're in the era now where we have gone 10 years ago from the very first diagnostic devices on a smartphone, IBG star for blood glucose, to now, wearable glucometers, and some that may be built into our Apple Watches and smart devices seamlessly. We've got Dave Albert here, who was back at our original Future Med 10 years ago, had the very first prototype of the AliveCar device. Now you see ads for it. You can buy it on Amazon. There's the 6-lead version, maybe other lead versions, and you have a credit card version. Now millions of EKGs done per day and scaling insights. So Dave, huge props to you. We'll hear about him in digital health sections tomorrow. Blood pressure, which used to be stuck on a cuff, now can be done seamlessly. I'm wearing a new device from a company in the Innovation Lab that can do 24/7 continuous blood pressure, and others that might soon do blood sugar. So what are we going to do with all that information? How do we make it useful? Do we need to wear anything? Invisibles are now here. Your camera can pick up vital signs. In many regards, we're all going to be doing an interesting demo with Bina.ai, where you're all going to start crowdsourcing our vitals. So watch that space. We're going to be doing some experiments with that here. And of course, the smartphone has evolved in many interesting ways, even over the last decade, to enable us to innovate, to use the microphone and speaker to pick up an ear infection, or basically to do a medical selfie, not just for vital signs, but to look at wound and a wound for helping a wound care nurse or patient. Or the idea of, instead of taking your urine to the lab, as one of our prior faculty from Healthy.io has demonstrated, now through the FDA, you can just dip your urine dipstick at home, take a picture with your smartphone camera, which has gotten exponentially better, and have your urinalysis anytime, anywhere, for screening for a UTI or preeclampsia or early signs of kidney disease. So huge things have advanced on this exponential. And something we've seen also in the now of the pandemic is using voice as a biomarker to pick up early signs of neurologic disease, mental health issues, or certainly the idea of cougholytics, sort of digital voice acoustic epidemiology, as it might be called. Is that a common cough? Is it croup? Is it a cold? Those will start to be picked up 24/7 as well. So what gets interesting with all of this, it can start to give us new insights into what drive disease, often which are somewhat based on our genetics, but often are based on our behaviors. And of course, it's only, think about it, 13, 14 years since the first Fitbit? I'm wearing like 5 different wearables right now. How many folks have a wearable on in here, right? But how many folks have ever shared that data with their clinician? Like 2% of you, right? So it's still pretty rare that we can take all our wearable and otherable data and make it really useful in the not just the wellness side and consumer side, but on the healthcare side. And I think we're going to see a huge shift in that regard, because these devices are getting quite miraculous. You can now wear a small patch that can be basically a 24/7 ultrasound. Our socks can pick up signs of early foot issues in a diabetic. Underwearables, Internet of Medical Things, in 10 pairs of underwear, you're always censored for tracking COPD or COVID. Ringables, I'm sure many of you have different versions. I've got 2 of rings that can track health information. And what gets interesting about these is not just for tracking sleep, which of course is an important element we're all better appreciative of, but can pick up things like signs of diagnosed pregnancy 6 days before home a pregnancy test. Or, as was demonstrated with UCSF, can predict a COVID booster titer just based on vitals from a consumer medical device. So interesting applications how we can take sometimes small data and glean basic insights about ourselves or at the public health level. And then the ability now to take what used to take an intensive care unit level of data and stream that from a low-cost, $1-a-day patch is going to have really interesting implications from our, hospital to home or hospital hospital movement, where care happens, enabled by data, but the insights are what's critical. And of course, other ways to measure information now, breathables are coming to market. And the question is, especially in the next decade, what are we going to do with all of this digital exhaust, our digitome? How do we make sense of it? How do we integrate it into our care? How do we leverage that into our most important drug? Food is medicine. We're going to be hearing from the CEO of Eat Real, the importance of food in pediatrics and beyond. How do we not just have these one-size-fits-all diets? We can measure input. We can start to measure output. All these new ways of measuring data at home. And it sounded like science fiction, but now there's these 7 companies building versions of this sorts of technology. Continuous glucose monitors. When we combine metabolome, genome, and other elements, we'll start to really hopefully move the needle on precision nutrition to help us keep well, but also manage disease going forward. And of course, we're going to learn, we have a whole section on the future of diagnostics, whether it's new ways to image your brain with AI-encoded information, all the way to, I recently last week had a full-body MRI from one of our NextMed Health partners, Pernuvo, who we'll be hearing from. Incredible abilities now to get a full-body MRI done very rapidly, and gives you a beautifully insightful report that you and your clinician can use. So new ways to interpret that as well. In the next decade, I think you're going to go to your corner CVS, Walgreens, Walmart, Boots, and get a full-body scan, maybe in 10 minutes, read by the AI radiologist, and hopefully democratize forms of diagnostics. Because these sort of imaging devices are getting cheaper. The Hyperfine device, it's portable, it's 20 times less expensive, it can bring care almost anywhere. We're going to hear from Mary Lou Jepson with Open Water, now bringing diagnostics to a wearable device. Big lay Mary Lou. So that's progressed. So whole new ways to think about where care happens. And so as a clinician or as a patient now, we can leverage our new, not just digital doctor's bag, but the community health worker from rural California to rural Rwanda can leverage these tools. It could be a smart ultrasound of EKG matching stethoscope. These were in our innovation lab 7 or 8 years ago. Now they're booming company, Echo Stethoscopes. Or maybe the era of the stethoscope is going to go away with this sort of now AI-empowered, low-cost consumer ultrasound devices, which again can go around the planet and bring care anywhere, almost by anybody. And we're going to have on our faculty the CEO of Alara Health taking sort of this technology into Africa and beyond. So tremendous opportunities to democratize diagnostics and care. The challenge, of course, these all generate lots of information, but how do we make it insightful? We're all aware of AI or augmented intelligence or intelligence augmentation. Of course, there was a lot of hype, and there is hype about it still today. So, just because IBM Watson wasn't a big success as we expected in the first 3 or 4 years, now 10 years later, we have dozens of FDA-cleared radiology and AI-based platforms, for example. So it's really starting to hit the road. So just a reminder, not just of Moore's Law, but of Amar's Law. We sometimes tend to overestimate the effect of a technology in the short run and underestimate in the long run. So part of our imagination here at NextMed Health is where might we be in the next decade, and how do we help that happen in smart, equitable, and accessible ways. And of course, there's amazing examples in radiology, in pathology, even your gastroenterology visit might be enhanced by AI. It's starting to be already. It's starting to democratize diagnostics again in all sorts of locations. And of course, the challenge is how do we mesh with this, the human component? We're not going to get rid of the need for human touch and eye contact. How do we sort of blend those modalities together to be sort of collaborative, not competitive? And a lot of that seems to be coming together in what's now not a new field, but this convergence of what's often called digital health or mobile health or connected health, the ability now to take these new forms of data and make them actionable at the interface, so they match the patient, the clinician, the caregiver, the health system, and the incentives and the payment models. And that's a big challenge to meet those challenges and to show that these digital health tools work. We have our friends from Node Health will be doing our workshop on Wednesday as well. So we need to cross-collaborate in this new digital age. And think about not just prescribing drugs and devices, but increasingly digital therapeutics, which are now a higher number of FDA and CE cleared examples, whether it's for smoking cessation or, of course, in mental health, which is a big unmet need exacerbated by the pandemic, or to treat kids with a now FDA cleared video game to treat ADHD with a game, not with a drug. The challenge is there's a lot of these technologies out there. We don't necessarily want a wearable for every condition or an app for every condition. I think we're going to see a lot of consolidation, a lot of more omni-channel elements as we go forward to integrate these into our care, not amongst thousands of scattered platforms. So part of the shift, now that we have some of these new tools and platforms, however, is to take ourselves from the quantified self era that many of us are who have some sort of wearable or otherable into the quantified health era. And again, to connect the dots between the data and what's actionable for you, your nutritionist, your workout coach, or your AI clinician. And we do now have new ways to measure, whether it's your voice as a biomarker or beyond, to diagnose diseases, hopefully at stage 0, not stage 4. And then therapy, we can just be much more tuned, whether it's a molecular-based drug or an immunotherapy or the right digital application. And we now have the ability now on our mobile devices to integrate that, and now at the press of a button to share it. We're in the sharing economy. Many folks aren't comfortable with this. Sometimes the HIPAA laws are a bit antiquated, but we have the opportunity to learn from each other. That ability like Project Baseline from Verily or the All of Us trial out of the NIH. Now hundreds of thousands of individuals sharing their genome, their medical data, their genetic and their digital health information to sort of build that roadmap. So we can have sort of what I like to call predictalytics, really understand a bit of our personal journey and learn from those around us to have a bit of maybe a FICO score for health, or that kind of check engine light for our personal body or for our community or for our patients. And one of the leaders in that instigation of check engine light for the body, Dr. Mike Snyder, the chair of Genetics, will be here giving a keynote speech tomorrow morning, doing some incredible work, not just with digital data, but now multi-omics and beyond, and even work that they published in the pandemic, showing your wearable device could predict a COVID infection 2 days before your COVID test could. So diagnostics in the next decade, I think, will bring us to this era of what's next, where the minority report will diagnose disease before you even know you have it, and maybe even start to fix it, whether it's in vivo gene therapy or other novel applications. So it's a challenge to make sense of all these new platforms. So I like to look at pain points. I encourage all of you to find a pain point and solve for it. One of those I found was to make sense of these. So I launched with colleagues, including Parisa Vatanka and others, Digital.Health a few months ago. It's a platform where you can now have a bit of a digital health formulary and search for everything from digital diagnostics to therapeutics. Use it as a discovery engine. Put your own solutions in there. It might be finding a device like CardioMobile and understanding its data and putting your own digital formulary and starting to prescribe it to your patients. Again, it's not enough to have the technology, but to integrate it into care going forward. All right, so we now have all these new forms of data sources. It's, again, a challenge to make sense of. Of course, AI is going to play a role, but we need to understand that data is just a component. This is a cartoon drawn by Dave Zabowski, who's back this time as well. What is it, Doc? Just as I thought, you're generating too much data. We're all data fiends, and data may be the new oil, but it's not enough. We need to, again, connect the dots and close the loops in the workflow. Workflow still seems to be the key step to get these technologies adapted. We know about all the issues of burnout sometimes from the technology and EMRs that often aren't physician-friendly. So we need to think about integrating and making care better and unleashing the human side of the equation. And a lot of that's going to be, crowdsourced. Just like we can build a map of Rome in a day from drivers using Google Maps or Waze, we're increasingly going to enable each of us to become not just an organ donor or blood donor, but a data donor, and to make sense of that information, and to engage each of our patients and ourselves with that information, not just the data, but the insights. And that is now the ability to almost join a clinical trial virtually. When I got COVID in early 2021, I joined a virtual trial for fluvoxamine. Signed up online, had the drugs delivered. We can all become engaged as data donors and learners, whether it's platforms like Quantified Citizen or platforms like Stuff That Work. Now thousands and millions of individuals sharing their conditions, what's working and what's not working, and collaborating to make that useful information. So last component here is, how is care shifting? Of course, telemedicine is not new, but now we're in an era where we're shifting from our old school version of intermittent episodic data that led to our sort of reactive mindset, waiting for the heart attack, waiting for the stroke to occur, waiting for the late stage cancer, entering an era that can be much more continuous, much more proactive, much more anytime, anywhere, bringing care and hopefully more accessible and democratized ways at lower costs with better outcomes. And I think that's part of our mission here at NextMed Health going forward. And to drive, from hospital to hospital and this new era of care anywhere to improve outcomes and experience. Of course, many of us experienced our own virtual visits as patients or as clinicians. That's going to shift quite dramatically over the next era. We have the founder of Ada Health here, the chatbot era, where you can ask smart questions. That's going to get better and better, where your avatar might show up, the one that matches you. I can turn up as a hologram now. This is at CES a few months ago. You can all enter the metaverse while you're here over the next few days. We have several examples of the metaverse. You can all have the opportunity to be turned into your own avatar in the Innovation Lab, so watch that space. That'll be a cool experience. And that begs the question, and when we can interact those ways, how do we teach the medical students, nurses, pharmacists of the future not just have good bedside manner, but good website manner or good metaverse manner as well? Okay, and lastly, we're not going to. We need to understand, of course, not just the digital determinants of health, but the social determinants of health. We've learned through the pandemic about the exacerbated disparities and how we can play a role in meeting those in new ways. We have our sort of Maslow's hierarchy of needs. Sometimes they're digitally based, and do people have access to information and battery life? And so now we need to think about this new era of where 50% of the planet are going to be connected through the 50% of non-connected folks will soon be online, so tremendous opportunities. So to kind of wrap up here, we've already talked about too much data. I'm already over time, which is a bad precedent. We don't want just data. We want to move that to actionable information insights and narrow the gap between something being published and learned to what's useful at the bedside or the website. So I think we are entering this new amazing health age, the one that I think this incredible NextMed health community is going to help accelerate. It's not about any one technology. It's not where we are today. It's where it's going to be near and next, and it's super convergence. And it's our role together to be thinking, again, not just about 2023, but 2023 and skating to where the puck is going to be, and to play a role, again, not being in our old now mindset, but moving to next, from intermittent, episodic, one-size-fits-all, provider-based sick care to a near future, a next future that's much more continuous, much more proactive, much more hybridized, much more crowdsourced in terms of knowledge, enhanced by AI and the big data element, and can be aligned with our incentives and our needs at the local level. So it's our opportunity to not take incremental steps, but exponential ones. Many of us are and have been building this new age of health and medicine. And again, it's not equally distributed. So it's our opportunity, our mission here over the next few days at NextMed Health to boldly, collaboratively build that future of health and medicine for all. So with that, welcome to NextMed Health. Thanks for being here. Let's get going. Woo.
Take a deep breath. I thought you might need a glass of water.
Sorry I was so slow.
All right, no, don't.
Oh.
I was going to say, first of all, that was great. Yeah, I was going to say it was really great.
Okay.
And you kept on time. But more importantly, you took us on this incredible journey of helping us to understand what it is that we're going to be doing over the next couple of days, this landscape of all the different possibilities. So well done. Go take a break. And
anyway, Shauna.
Yeah. Isn't that great? But seriously, when people tell me all the time, you need to tell them to slow down. I'm like, no. You're just going to have to listen a lot faster. So with that kind of big overview, we're going to start with thinking at the very large system level. How many of you have systems that all work for you? Exactly. So when you think about systems, what you really need is an engineer and somebody who designs, somebody who actually is not designing for healthcare, but designing for health. So our next faculty member has worked with pretty much every government, every health system on the planet, seeing what works and oftentimes what doesn't work. And so to help us understand where we need to think about system innovation, please welcome to the stage Stacy Chang.
Well, thank you. It's a delight to be back. To follow Daniel is always a bit of an interesting thing because I want to speak as fast as he does, but I've learned that only he can actually express in that speed and velocity. So, it's interesting. We all love a great hero story. And I'll tell you that story as soon as my slides come up. Here we go. We all love a great hero story. There we go. We love the inspired individual, the singular breakthrough, right? The rescue in a moment of need. And here at NextMed, we love to talk about the heroic breakthroughs, the science and the technology, the things that we all hope will change the trajectory of human health. I've been doing that work for a long time. And one of the interesting things is there's always this sort of insidious truth we don't really talk about. I spent a decade at IDEO working on the forefront of science and technology breakthroughs for health, turning those breakthroughs into market offerings. But we often didn't talk about this sort of uncomfortable truth, which is often the success of those interventions was as much about the systems that they were introduced into as they were about the breakthroughs themselves. And so I'm going to talk to you a little bit about how we shape the system so that those breakthroughs can have the impact that we want them to. let me illustrate with a historic example. Most of you will know of Alexander Fleming. He discovered accidentally penicillin in 1929. He published it, and no one took any notice. It was a decade before a series of collaborators figured out how to purify it, scale it for production, and even run the clinical trials necessary to generate the evidence necessary to compel the beginning of essentially modern antibiotics. At one point, the British Medical Journal said, it doesn't appear to be that useful in the early 40s. All of that, you think, would be sufficient to introduce what was one of the most critical and breakthroughs in modern medicine to the world, but it didn't. It required a war cabinet. The war cabinet in Britain managed to convince itself that scaling the production of penicillin could be a strategic advantage to the Allied troops in World War II, and that's what bent the curve. That was the inflection point. By D-Day in 1944, they had produced enough penicillin for the entire Allied troop force in Europe. It couldn't have happened, his breakthrough, without a cadre of collaborators and just the right set of contemporary circumstances to bring about that change. Think about it this way instead. Would Kermit have been anything without the Muppets, right? Would Zoom have really scaled the way it did prodigiously without the pandemic? Would Al Capone have been nearly as notorious without Prohibition? And genuinely, would the Yellow Submarine have made any sense without the advent of LSD? Probably not. I'm a little facetious about that, but really the point is this. The challenges we face in health and healthcare today really are of a systemic nature. The individual isolated opportunities really don't exist in the way that they might have several generations ago. They need a supporting cast and an ecosystem to really have the kind of impact that we hope they will. Breakthroughs survive and thrive at the complex intersection of discovery, of available technology, of a workforce, of ethics, of culture, of market dynamics, regulation, even political will. They're not, systems almost by definition are not subject to a single authority, and they are predictably irrational because they consist of humans. You can neither prescribe nor predict how systems work, and the only way to get them to work on your behalf is to shape them, to manipulate them, and sometimes to actually break them. Which leads me to this question. What do breakthroughs need from the system that are not under the control of the original innovator in order to see those breakthroughs scale to impact? Sometimes unintentionally, and certainly in hindsight over the course of the last 2 decades, I found myself working on complex system problems of this kind. I'd like to share some of the themes and principles that have emerged, but I'm also going to issue a challenge at large, because I think some of the system problems we face cannot be solved in the way we currently self-organize. So I'm going to start with a case study. About a decade ago, I was asked by Susan Desmond-Hellmann, who was the chancellor of UCSF at the time and eventually became the CEO of the Gates Foundation, and Francis Collin, who is the director of the NIH, to pull together a seminal gathering that would activate the future of precision medicine. For context, it had been a decade since the Human Genome Project had been completed. Personalized medicine had come and gone and floundered, really. And precision medicine had arisen with the risk that it was just a rebranding of what had come before. I'm not going to go through the details of the convening. There's actually a mini documentary on YouTube from which these images are taken if you're ever interested in the details of it. But what was notable was the outcome of that gathering. What emerged from that gathering were a dozen public proposals for much-needed capabilities to see precision medicine flourish, each of which would grant a first-mover competitive advantage to the enterprise who could pull it off. Within a year and a half, the participants from that gathering had launched Obama's White House Initiative on Precision Medicine, Illumina had spun off Helix, 23andMe had pivoted, and about a dozen universities launched their own precision medicine institutes. All of this was infrastructure development for the field. couched, concealed in terms of market opportunity, which they definitely took advantage of. Interestingly, it's also where I met Daniel Kraft for the first time, which if I do recall, he actually made the final stage as a champion of one of the initiatives. That leads to a first principle I want to share with you, which is this. Create a competitive ecosystem for your breakthrough. Because enabling others to succeed in collaboration with what you're doing or on the back of your success builds the infrastructure necessary to develop your solution at scale. Interestingly, it's also, in my experience, the most effective way to unleash huge amounts of capital that you can't muster on your own. The second story starts with two examples, and they're both from global health. One, very well documented. The second, an emergent one. Many of you will be familiar with M-Pesa, which is the mobile money transfer platform that was developed in Kenya starting about a decade ago. Vodafone and Safaricom collaborated to bring that about. But for those of you who are not familiar, let me give you a little bit of context. So a decade ago, half of Kenyans live beneath the international poverty line, which is about $1.25 a day. They had no access to financial services in spite of high demand. For example, a lot of urban workers would send remittances back to their rural families without access to financial transfer and money transfer services. They would usually send those remittances with humans, oftentimes strangers, and that's an obvious risk. When you're handing a bunch of cash to people, it may not actually make it there. Less than 20% of the population had access to financial services, and the platform itself was built on a really interesting human insight, that individuals were actually exchanging airtime minutes as a surrogate currency. And that makes sense when you understand that in Kenya at the time, there was no real landline infrastructure. Mobile telephony utilization was very, very high, and airtime was a universal commodity. It was individuals' connection to the world. And so they were using it and the exchange of it essentially as a currency. 4 years after Safaricom launched M-Pesa, it had 17 million subscribers. 6 years after it launched, it was doing 237 million transactions a year, fully representing, get this, 43% of Kenya's GDP was flowing through M-Pesa. I tell you that because it's a pretty remarkable story, and the primary effect of essentially banking the unbanked is remarkable. But it was the secondary effects that actually drove a lot of its scaling. It lifted a bunch of citizens out of poverty because it provided a small business model for the purchase, the exchange, the trade, and distribution of these mobile money. And in many cases, these small shop owners were women, and it extracted them from alternative work opportunities like the sex trade. Those secondary effects are really important because they actually enable solutions to other inherent needs in the communities. And those secondary effects build the platform for the primary thrust and the primary breakthrough. You may think this isn't actually a healthcare story, but it is. Because what is the first thing people do when they have excess revenue that they receive or earn? They spend it on healthcare services. The second example is a more emergent one. There's a company called Proximie that's using telepresence and augmented reality to allow surgical teams to collaborate over great distance. It's particularly useful, the CEO likes to say, there are 4.8 billion people in the world who have no access to surgical services, mostly in low and middle income countries. When they utilize this platform, they usually collaborate with centers of excellence in high-income countries, and it opens up access, skill, capability to regions that don't necessarily have it. It's capable of operating over 5G networks, which is incredibly useful for regions with limited wired infrastructure. But again, it's the secondary effects that actually are really, really interesting, and I think the story to be told here. It upskills the local medical workforce, something that the local regions in the low and middle income countries desperately need and desperately want. And for those upskilled workers, they become their own regional center of excellence, and they can draw patients and case and business from their surrounding area, turning that into a viable business model for themselves. So I share these two case studies because I want to share this principle, which is to embrace the secondary effects. the direct value proposition of your breakthrough may have huge impact, but also understanding the incentives of your partners and how they respond to it, supporting them and actually leveraging them helps to build the ecosystem you need for the primary breakthrough. The third example I'm going to give is this one. But let me give you some context first. So I've talked a little bit about systems as essentially non-deterministic, which is basically a fancy way to say that they're unpredictable and irrational. The only real way to change systems is to provoke them, to study the response, to adapt your approach, rinse, and repeat. I left IDEO frustrated by my inability to actually change systems. I worked in edges of the dysfunction in silos for individual industries and clients who had a business model for a very narrow thing, but definitely not addressing the system issue. And I left for academia. I joined the new medical school at UT Austin and ran something called the Design Institute for Health for 7 years. All the work I did there was actually on complex systems, and I'll share a couple examples. But one of the fundamental things we had to do was actually to understand the interactions in the system, because they are not prescribed, and actually they're usually poorly understood. So we'd map those to understand where the incentives drove what behaviors. One example from the 7 years I spent as an academic was work we did with, funded by the Gates Foundation and done with the Global Alliance for Vaccines and Immunizations, also known as Gavi. Their original premise was that if you could secure consistent funding for vaccine production, you could compel the pharmaceutical companies to make them. You didn't have a consistent supply, and then if you could get them into country through the cold chain and into the hands of community health workers, you can inoculate a huge population and have massive effect on the health of a country through vaccination of children primarily. Gavi, 20 years on, had become a very, very different organization, more involved in health system strengthening than it was actually in the procurement and the supply of vaccines, something they inherently understood but couldn't really act against. And so they were working on a new strategy, Strategy 5.0, and we helped them deploy that. We ended up mapping their processes, and the spaghetti diagram you see is the kind of interactions that they couldn't even tell you were actually happening between them and their global health partners and the network and the countries they were serving. Embedded in this were a lot of really interesting learnings. We learned about large-scale redundancies, misalignment between partners, missed opportunities. And we ended up deploying a lot of mechanisms over the course of a couple of years working with them. We helped them develop tools that allowed countries to self-analyze their needs. We built a differentiated strategy so that engagement with different types of countries fit the needs of the countries rather than a one-size-fits-all approach. We developed a coordinated approach to communicating more effectively with their partners, even new organizational mandates and decision-making structures. It helped Gavi understand the value it was actually creating, not just for itself, because it had its own needs and its own incentives and its own funders to respond to, but also the value that it was creating in the system, in the exchanges that it was not only participating in, but also invoking. It allowed it to look forward strategically so they could act with intent instead of actually just reacting with wild abandon. We often we talk about complex adaptive systems, and in Gavi's case, this was a shift from being a victim of a complex adaptive system and actually being an agent of change. That leads to this third principle, which is leverage the systemic value exchanges. Understanding the interactions where value is exchanged develops the means to provoke and revise those exchanges, and exercise influence on the system. It's doing it in a benevolent way ensures your success and the success of the system as well. So far I've talked about what it takes to build a system in response to a breakthrough, a point solution that needs a broader ecosystem to thrive. But many of the challenges we face systemically actually don't have point solutions as their starting point anymore. They actually just need systemic solutions. Think about it. Diabetes or our mental disorders won't be solved by an injection in a clinic. Universal healthcare issues of access and equity won't be solved by a single technological breakthrough. The three principles I shared with you become even more important in that context. Most of the problem, I think, is that we're self-organized. We're in silos, working on the things that define the boundaries of our sectors, and that drives divergent behavior. That's not actually collectively productive. I have a lot of respected colleagues who I've been talking with over the course of the last few years emerging out of this pandemic, and they're all frustrated by the boundary conditions within which they reside. And the lack of systemic impact at scale. I've come to call them, and I'm in one of those, an institutional refugee. Right? The brightest individuals have realized that they can't have the impact they want without a fundamental redesign of the system. So I'm going to share with you an emerging characterization that a colleague and I have been working on around systems and how we make change. It is definitely imperfect. And I suspect many of you will argue with the specifics of it, and I invite you to do so. I hope you will. Either in the breakout sessions that happen here at NextMed or at large. It will take all of us to make it better, and this is an invitation to that conversation. I'm going to start with this. There are a couple really critically important inputs into a system. One is the need. Name it. At an individual, community, regional, or national level, we can name them. The big ones are really hard to address. Those needs exist in a context. Think about the context as available infrastructure, the governance of a nation, its regulation, and really explicitly culture, because not all solutions are one size fits all. And finally, we have these solution sets, sometimes these breakthroughs, sometimes known solutions, sometimes meanderings of our mind that we think will solve for them. But those things sit in a soup, and actually one of the most critical things necessary at a system level is actually a diagnostic that actually understands the capabilities of each, and the needs of each, the context of each, and matchmakes them. Matching them is actually just the first step, because then you actually have to design and deploy, right? In a system, you only improve by operating, seeing where it fails, evolving, and trying again. So the design and deployment is actually a really critical thing. You cannot, from the stage, stand here, evaluate a solution, evaluate a need, tell you what the solution is, and it'll work exactly the way you had planned it to. None of us have ever seen that happen. That design and deployment leads to outputs, impact, health, ideally, but also return. And this is really critical. My academic friends accuse me of being a capitalist. My capitalist friends accuse me of being a socialist. I'm definitely all of those. But the return part matters, and the capitalist part of this matters because self-sustaining models have to support themselves. If they don't have value, they won't make a return, and they probably don't need to exist. Because it's a dynamic system, we need to evaluate and we need to continuously adapt. That's the closed feedback loop, right? That is often missing in the systems that we have built. I'm going to take a quick turn through a couple sectors. I guarantee this is a generalization and a stereotyping. It's not actually perfectly true, but it'll get you to a point at the end. If you look at the public sector, right, think about it as governance and policy making. They definitely understand needs. They sometimes prescribe solution categories, and they are definitely looking for impact. But man, I don't know too many public sector entities that are very good at context, definitely not design and deployment, and rarely at positive return. You look at the private sector, they're good at establishing need in a pretty narrow range, something they can build a product and build a value proposition for and actually make a return on. And impact is always subservient to return, because if the business doesn't exist, you can't make any impact, and that's true for social impact organizations and B Corps as well. Their solutions are usually pretty narrow, but they are inspiring in some ways, but also not an entire system play. If you look at the third sector, which is this loose assemblage of these random organizations, and I'm going to try to characterize a couple of them, they also have a role to play, but an incomplete one. You think about academia and think tanks, and we can argue about what sector they actually sit in, but they do a really good job of actually researching, explaining, and expressing the need in detail, suggesting solutions, but I've never been a part of an academic institution that knows how to implement. There are foundations, which is really an interesting place. Foundations, they fund a lot of solutions. They don't necessarily derive those solutions on their own. They are definitely looking at impact. And their adaptation is to see the kind of impact they're having and seeing if they should continue to fund it. But they are also missing a part of the system. And finally, nonprofits, who are oftentimes on the ground. They, more than anybody, understand this matching of need, context, and solution. They usually build one business model, and they're definitely interested in impact. Very few of them actually have return. Some of the justification for why they're a nonprofit. And then the last one are associations. If you think of them as advocacy groups, they aggregate need and context from their members, and they are advocating for impact, but they're not actually executors of the system. The point in running through that panoply of examples is to suggest that the system as a whole doesn't have a single coordinator, a single agent, someone overseeing the system. I've been studying this for a little while now, and my time is too short here to actually go through the dozen examples, I think, of institutions that are starting to bridge those gaps. But I wonder out loud whether, especially in the third sector, we're going to see institutions evolve into that role, or whether we need to build something entirely new. I'm going to close with this thought, which is these systems are actually a consequence of our own making. We didn't actually design them exactly this way, but we definitely built the incentives that shaped the response that collectively makes this system. And we're actually faced with a choice, kind of an existential one, actually, which is we can actually be victims of our own making in these systems that we've developed, or we can be progenitors of something very new. I hope you'll join me in being one of the latter. Thank you very much.
Awesome. Thanks, Stacy. So what would be the one scintillation of how to become the instigator of something new? If we're going to give a one takeaway, we have a workshop for you with you tomorrow. But.
Yes, we do. Yeah, I think the really most critical part about prompting change is tweaking the system in a way that it's not been provoked before and watching how it responds, and then utilizing that as then guidance for what you do next and again and again. But not to do that without intention, right? You got to walk down a primrose path, but you got to know where the North Star is so that that primrose path takes you somewhere.
All right, let's make that North Star. Thanks, Stacy.
Thank you.
All right. A little brain break here. This is not the video we wanted to play. That's okay. AI is easy. AV is hard. And speaking of AI being easy and not hard, we're going to go into a really interesting section now about all the ways that AI, machine learning, big data are reshaping the art of the possible in healthcare. And no one better to lead off this session than my friend, Dr. Suraj Kappa. He's a practicing cardiologist on faculty at Mayo Clinic, Chief Medical Officer of Triple Blind. For over a decade, he's been working at this interface of machine learning, big data, AI, and making it clinically actionable. And he's going to kick off this new component, this next session 2, where we're going to be diving into several different fast-moving technologies that are going to kind of create a bit of the sort of understanding and ability set to help create the future of health and medicine. So with that, Suraj Kappa. Thanks.
Thanks, Daniel. And thank you so much for having me here today to talk about AI, big data, and really what the opportunities are moving forward. So when we think about AI, we need to think about what is the paradigm for intelligence. Why is AI even able to exist? And the reasoning behind it is governed by basic principles that people as far back as Hume would think about philosophically about what intelligence really is. And the principal idea is that everything we think about and everything we know arises from physical parameters that can be expressed as symbols, from which expressions can be derived. Those expressions can be manipulated through processes and result in new expressions. And that is the foundational understanding of how intelligence forms. But the reality is that this physical symbol system cannot just be replicated in the human mind, but in computers as well. And as long as we're able to create such a symbol system, it'll become the necessary and sufficient means for creating general intelligent action. And this philosophical underpinning became the basis for why people thought, as far back as the 1800s, that the possibility of automatons and machine intelligence was feasible. So one of the major ideas that underlay a lot of this was work dating back to Hilbert and Gödel and others with the theory that can all of mathematical reasoning be formalized? And the Gödel incompleteness theorem suggested that, in fact, when we think about mathematics, there's a limitation to how many things can be expressed through mathematical principles and mathematical logic. However, people went on after that to show that all mathematical logic can be expressed in the form of symbols. So when you say the statement cannot be proved, you are able to express it in a mathematical way that can then be taught to a computer. And these ideas slowly led to the evolution of compute systems that were the underpinnings of AI as we are thinking of it today. This was built in 1950. And in 1950, this is called essentially a neural architecture built from 3,000 vacuum tubes and a B-42 bomber automatic pilot system. And it showed that it can actually take input and probabilistically alter that input through about 40 neurons in order to result in a changed output that actually was similar to how basic intelligence might work. And this eventually led to Turing thinking about the idea of computing machinery and intelligence, namely, can machines think? And after that, workshops in the 1950s in order to coin the idea of artificial intelligence. But it's interesting, because we think about all the news articles that are coming out today about ChatGPT, which you'll hear about later, and other innovations in AI. But in the 1958 New York Times, they had an article about how the Navy was on the cusp of building a computer that could think, see, understand, and completely replace soldiers and everything that humans were doing in the battlefield. And that was in 1958. So if we think about it, what we're really seeing a lot of is what is old is new again. And in fact, over those years from 1956 to 1974, there were multiple innovations. There was Sharky, which was one of the first robots that could understand the basis of its own processes. There were semantic nets, which led to ELIZA. And ELIZA was an interesting system that people would speak to and give inputs to, and would get outputs that they were actually having difficulty saying is different from speaking to a normal human. And then, in the late 60s at MIT, SHR-DLU was developed. And it showed that people can have a conversation with the computer, manipulating blocks in this block world, and asking the computer, oh, what's inside the box? What's supporting those objects? How many things are not inside the box? And they could ask any number of expressions and actually get an output. And you can actually think that this thing that was created in the late 60s is very similar to what we're seeing with ChatGPT today, when you actually think about it. So the question is, why is it now that AI is becoming so prevalent in terms of thinking it will actually have a change, an impact on how we think and how we do things, not just in healthcare, but in all matters of industry? The fact is, in the late 70s, what happened was the winter of AI. There was limited compute power that severely limited what people could actually do with these technologies. There was problems with intractability, which is the issue that increasingly complex frameworks required exponentially more power in compute systems to work on it. There's also the problem of common sense and Morovich's paradox. And this paradox is an interesting consideration about the fact that when we think about high-level reasoning, it actually doesn't require that much compute power compared to low-level reasoning. If we think about our unconscious attribution of what we do here today, my choice to breathe, that is actually very, very difficult to explain to a computer architecture because it's so complex. However, if I was to be asked to stand here and teach you how to do an integral, that would be much easier, even though in a human context we think of that as a much more complex approach requiring much higher reasoning. And what happened is, in the 1980s, 1981, the Japanese Ministry of Industrial Trade actually gave $850 million to the 5th generation computer project, which was a goal of investing heavily to starting to think about how machinery and computing architectures could be re-put together to resurrect the idea of natural language processing, computer vision, and all of these things that artificial intelligence had been promising since the 1950s. In parallel to that, Geoffrey Hinton and others developed new frameworks for connectivity between neurons through features such as backpropagation and other terminologies, which we won't go into today, but which were critical to the idea that we actually might be able to create computationally efficient AI systems. And the biggest aspect of this was the explosion, the exponential improvement in compute architectures. If we think about how these compute architectures have improved, the fact is every year is exponentially more than every previous year, such that the lines we're going on to get to the equivalency of a monkey or a mouse or a human is actually accelerating extraordinarily more than we would have anticipated. In the 1950s, we might have thought it would take until 2050 to get there. In the 1970s, we were thinking it might take until the 2030s to get there. And now in the 2020s, we think it might actually be feasible in this decade. And ultimately, part of this is the big data explosion. Part of us getting there is the fact that more and more data is digitized. And this is critical to allowing us to have access to data to train systems. And ultimately, when we think about how complex these networks are becoming, these machine-based AI systems are, if we compare a neural network from the 1980s to ones we look at today, the complexity approximates the level of areas and neurons that we go through ourselves when we go from an input to an output. And that is allowing systems to more and more approximate complex thinking. And really how far we've come. This is one of the smallest computers we can think of, the Raspberry Pi. And using the Raspberry Pi, people have operated systems that can detect people, umbrellas, and cars using an AI approach in real time as they walk down a busy New York City street. And if we compare this to the 3,000 vacuum tube system in 1950, it's extraordinary. So how does this apply to healthcare? Healthcare is one of the most needing areas of having people think about how do we democratize knowledge? How do we bring data together in a way that will actually allow real delivery of healthcare to the people who need it when they need it? The reality is, I work at the Mayo Clinic, and there I'm surrounded by physicians who are extremely experienced. If I drive for an hour and a half in any direction, there is not a single hospital that I can really go to for advanced care. And we think about that for a second. How do those family physicians provide adequate care, even because they don't have the knowledge base distilled exactly at their fingertips? The idea is that if we start bringing compute structures to support those clinicians that can intelligently augment what they're doing day to day, it can provide better care outcomes. This idea that a sort of machine intelligence combined with clinical intelligence can lead to an enhanced form of medical intelligence. And part of the problem is data in medicine is diverse, and it's abundant. And it's hard to bring together otherwise. If we just think about everything from the books we read, to the patients we see, to the experience that's needed, that's iterated over time, if we can bring that all together faster in computing architectures, it can allow people to augment what they do day to day. Because the reality is, at the provider level, costs are increasing. And they're increasing to a level that is not sustainable. And if you think about it, in the US, over the last several years was one of the first times in documented history of the US that lifespans have actually decreased year over year. And that's in spite of increasing healthcare costs. Why is that with extraordinary medicines and technologies that seem to make life better and easier to diagnose disease and everything else? Part of the problem is getting those technologies to the people who need them, evaluating the data that comes out of those technologies intelligently and accurately, so you actually give reasonable outputs. So the thinking is that AI will help this democratization of not just access, but accuracy. Some of the work that we did at Mayo involved looking at cardiologists. So for me, a chest X-rays and ECG. And when we were thinking about how AI can be applied to something as simple as ECG, you're going to be hearing from David Albert tomorrow about these devices that you can actually get electrocardiograms at the point of care. But even if you can get data at the point of care, you still need to interpret what's going on with that data. What does that data actually tell you? But not just that, but wouldn't it be nice if from that data, we can also understand more nuances of what's going on with you? Do you have a low heart function? Do you have potential risks of going into a dangerous abnormal rhythm? And if you're able to provide that data to not just show what's going on now, but to suggest maybe you should see a clinician, that can actually afford people a way of getting better preventive care. And work we did suggested that many of these disease states can be accurately predicted through something as simple as an ECG, but not just a 12-lead ECG, but even a single-lead ECG. And that becomes ever more critical when we think about that democratization of healthcare access. But there are challenges. There's a challenge of external validity and generalizability. Me sitting in Rochester, Minnesota, which is 95% non-Hispanic white population, how can I sit here and assume that the models I create are going to be applicable to that small rural population in Mississippi or to that urban population in Philadelphia? And we need to figure out how do we externally validate in a sufficient way such that we can ensure generalizability. Because the biggest thing is do no harm. And we don't want to make assumptions about algorithms we create that they are going to be relevant to everybody just because they were trained on 1,000 or 100,000 or 1,000,000 or even 1,000,000,000 people. The second thing is it's sometimes difficult to assess data input quality at scale. It's just the very nature of life. Bad data in, bad algorithms out. If your teacher doesn't teach you well in school, then you walk away not being very knowledgeable about what you're being taught. The same is true with artificial intelligence. The more poor the data, the more poor the algorithms that will result, such that a ton of work can go in, but doesn't actually come to anything at the end. There's also the black box issue. There's always the question in clinicians' minds of how comfortable do I feel trusting this computer that's telling me something? How do I explain what it's actually trying to tell me to do? It's now telling me to order this follow-up test. So should I actually order it? Because in my knowledge base, I would never have thought to based on the data that's in front of me. And does that increase costs? And finally, the loss of interpretability and the potential risk of dangerous outputs. Namely, just because this told me to do it, and now I'm doing it, does this put me down a slippery slope of creating some harm? Because the reality is, more testing is not always better testing. We know, for example, that CT scans that we do can result in what we call incidentalomas, incidental findings that have no physiologic importance or relevance, but treatment of which can result in harm. So what are the keys for successful AI in medicine? We need reliable, large data sets. And access and evolution of these is rapidly improving, especially with the advent of electronic health records and the focus on centralizing these data pools. Better arbitration of diagnosis or endpoints being kept minimal. And what does that mean? That means that we can't rely on people annotating every which way, every single data point, because you're going to require 10,000 more humans for every physician to just re-adjudicate what they do. You need to minimize bias. And there's a lot of work being done to understand how do we make these algorithms and evaluate these algorithms so we know that they don't have so much bias as to cause harm through misdiagnosis or misapplication. And in the US, there's actually a group called the Coalition for Healthcare AI, it's working with the FDA, CMS, and a group of academic institutions as well as industry to understand how do we create frameworks that will allow us to know when an algorithm is sufficient to be applied to a given population. And finally, we need to start thinking about how to create dynamic algorithms. Dynamic algorithms that can continuously update, continuously learn, continuously get feedback, because that's really how we work as physicians. That's why a lot of us will trust that clinician who's 30 years out of medical school rather than the one who's day one out of medical school, because they've been continuously exposed to more and more information, more and more patients. And ultimately, what we're trying to do is get beyond weak AI, which is a simulation of intelligence, to intelligence that can more closely replicate how we think of as physicians. The idea that sometimes we can think outside of the box and outside the framework of what we've just been taught and actually innovate beyond that. And with that, both my colleagues, Ramesh Raskar, is going to talk a little bit about the concept of decentralization and how we work with those processes. And Dr. Whitehead is also going to talk about ChatGPT-3, which is in the news currently, and the understanding of how we're going to approach that and apply that in our daily practice. But I appreciate the opportunity to talk to you all, and thank you.
Thanks, Raj. Thanks for that tour de force. So, question, if we're going to look 10 years out to what's next, what's the future of the cardiologist going to be? I've got my little echo device. I can now diagnose a murmur on you when I can never listen to heart sounds very well before. Just if you're going to pose 5, 10 years out, the implications for AI in clinical practice.
Yeah, so our goal in clinical practice, and especially for me as a clinician, the one thing I don't want is a patient who comes in and says, I have this vague issue or concern, I'm not sure what it is. I would rather see a patient who comes in and says, hey, here's what I have, treat me. Because the reality is so many healthcare dollars are spent on trying to find the diagnosis, to get from symptom to disease to treatment. The faster we get to disease and remove those interim aspects that are expensive when they're engaged to the healthcare system, the better we're going to get and faster we're going to get to treatment that's effective and avoids delays in care.
Great. Thanks, Raj. All right. So that's a taste of the art of the possible, pun intended. That's AI machine learning. I think it's hallucinating different forms of art taken from the MoMA. And I think it's just a taste of what's to come in this new age of generative health and generative AI. I think you've all, who's here tried GPT chat so far? Probably most of the room. If you haven't, you should go out and try it. It's moving quickly. And really lucky to have as our next faculty member, Alfred Whitehead. He's the EVP of Applied Sciences at Click Health, one of our major partners here at NextMed Health. And Alfred's going to take us on our journey of what's now near next in generative AI. Alfred.
Good afternoon. The US healthcare system is sick. We've had generations of improving life expectancy and improving health span. But if you look at the last 20 years leading up to COVID, we've had almost nothing out of it. If you look at that health-adjusted life expectancy curve there, we've gained 20 weeks in 20 years. And since 2014, we've been in decline. This graph is health spending in the US, per capita, adjusted for inflation. And you can see we're on this linear pathway. In that same period where we gained 20 weeks, we roughly doubled the amount per person we spent on healthcare after adjusting for inflation. So where's all the money going? You may have seen this famous graph from Himmelstein and Wohlhender that looked at census data on jobs. And they found that over 40 years, there are 3 times as many physicians, but 32 times as many healthcare administrators, and more than a 10-to-1 growth ratio there. And we know from time and motion studies, if you run the math on this, that physicians are now spending more time on record keeping than they are on clinical work. And so I'm not saying that record keeping is the only problem with the healthcare system or the only thing driving these, but it's a big fish to fry. And so maybe we can solve it using some AI. So many of us since November 30th with launch have tried ChatGPT out. And you can see how it does on clinical tasks. Here I am. I'm going to ask it to write a denial of coverage letter for a patient with chronic kidney disease. And it does a pretty passable job. And I only had to speed this video up a little bit for the talk. And this has already sort of been weaponized by a group who has something called DocsGPT at Doximity. So DocsGPT has a list of pre-built cases relevant to clinical practice. And you can go in, customize what you need. There you go, there's my letter. I can then select the insurer I want to fax it to and click the button to do a HIPAA-compliant fax to that insurance company. Fax, exactly. So let's back up a bit and think about what would happen if we scaled this up. What actually happened there in DocsGPT? Well, there was a doctor. They knew they needed something. So they wrote a prompt for an AI. Then the AI thought about it for a bit, and it wrote up some formal language. That formal language, the doctor tweaked it, maybe put in the patient's name. Then it got turned into an image, a picture of the words. And then that picture of the words got sent to probably a printer driver pretending to be a fax machine that then, pretended to have a phone line, probably using the direct protocol that connected to another fake fax machine over at the insurance company, which then has the image of those words. It runs optical character recognition on them so it can see what those characters were to get back that formal language. And then a human, or maybe an AI, reads that language and says, this is what the doctor wanted, and goes and types it into a database so that somebody else can process it. So I would submit to you that only the doctor and the database are actually doing anything of value for the health system. If you look below, all of this stuff is waste. And not only is it waste, it's old tech on top of old tech. It's like we took apart a jet engine, and inside was a car engine. And inside the car engine was a bicycle. And then inside of that, the horse was riding the bike. Like, this is a crazy way to build systems. And this is part of the reason why the healthcare system is sick. We have this bureaucratic plaque in the arteries of the system. Or, if you prefer the language of software development, we have technical debt that we need to pay off. And one of my concerns is if we just naively apply generative AI like ChatGPT to the health system, we're going to be making interest-only payments on that debt and growing the principal and just kicking the can further down. So, is generative AI a dead end in medicine? I'm going to say yes and save Daniel 10 minutes on the schedule. At least in this way. The lowest hanging fruit is a bit rotten. It doubles down on the past, and it perpetuates the mistakes we've made before. So I think there is a future for generative AI in medicine. But I want to unpack a little bit about how it works so we can understand how to use it correctly. And Suraj mentioned a program called ELIZA, which was one of the first chatbots in the 1960s. And so that's been around forever. ChatGPT is just another chatbot. What's so special about it? Well, I would submit it's the convergence of 4 innovations in one package. You have a process called attention, some variation in how it responds, some pre-training that means it knows what to talk about, and then an overall architecture that wraps it together. Attention is this really nerdy term. It comes from this paper from 2017 in Google. And I'm not going to explain how it works because, frankly, it's really complicated. But what it is it's a way to handle sequences of data. So when you have a sentence, you have a sequence of words. And the meaning of the words depends not just on the word itself, but its position in the sentence and the context of other words. And what attention does is a much, much better job than previous generations at getting this correct, so that it can actually understand meaning. And this is very important for language tasks because with language, context is king. This is a graph from a paper here where you're seeing which words the AI looked at to understand what the pronoun it meant. If you just have it by itself, it doesn't mean anything. To understand the rest of this, I'm going to use this hyper-simplified model of how ChatGPT works. And I'm going to break it out into components, but I want you to know the reality is these components are really tightly interleaved, and you can't nicely separate them like this in real life. But the basic task that all these models do is you give it some input, some words, and it tries to guess a statistically likely set of words that follows. So how does it do that? Well, first, it starts with your prompt. It breaks it up into things called tokens. Tokens aren't exactly words, but think of them as words. They're the computer's idea of words. Then there's this thing called the encoder. And what the encoder does is it turns those tokens, that English, and it says, it's this concept in this high-dimensional vector space. Now, what the heck does that mean? So basically, it turns your concept into something that is encoded and it can do mathematics with. So if you have the concept for queen, subtract woman, add man, you'll get king. And so this is how it understands the relationships between words and concepts. And if you search around king to see sort of what is like it, if it's been trained in English, you'll probably find prince and duke because of Prince Philip, the Duke of Edinburgh, who was the Queen's husband, and a lot of ink has been spilled about him. This search-ish process is actually kind of what search engines do now. It tries to figure out the concept of your search, and it looks around for results and then gives you a list of them. With a chatbot, you just want to give one result. You don't want to give a list of possible options. So which result do you pick? Do you always pick the top one? Well, you can if you want to. This is, again, from OpenAI. This is the internals of GPT. And it has this parameter called temperature, which is the amount of variation, the amount of randomness in that search. And if you set it to 0, you get a really boring textbooky answer. But if you crank it up and ask the same question, then we suddenly get chronic kidney disease is like a broken car. It gives you an analogy instead of just a definition. Because now it's broadened its search. It's doing things at a little more variance. After the computer looks at this, it decides, okay, this is what I want to see next, based on this search process. I'll feed it to a decoder, turns it back into words. Those words get shuffled around so that it makes reasonable English, which is another trick of attention. All of this works because the entire system has been pre-trained on the English language. And this is a big revolution for machine learning. Before, it was like you had a baby that knew nothing, and you had to teach it everything in order to do anything. Now you have these foundational models that have gone to basic school. They understand the English language, the relationship between words, how the concepts touch upon each other. And this means this is really going to speed up the machine learning operations cycle. If you've ever done this, this is just gasoline on it. It's going to go faster, there's going to be less time labeling, and you're going to have a faster turnaround of your process. So this fundamental architecture is kind of what a general AI looks like. And we call this sequence to sequence. A sequence goes in, a statistically likely sequence that follows comes out. And ChatGPT is what we call a text-to-text model, because text goes in, text comes out. So what can you do with text? Well, you can take something simple and you can expand on it. So here I am asking it for aftercare instructions for a surgery. I gave it a few pointers, but it's filling in all the common sense stuff by itself. Potentially saves quite a bit of effort. You can ask it to summarize. Here I'm going to ask it to summarize and tell me what the record retention requirements are from FDA's Part 820 quality system regulation. And it does a very passable job of reading that regulation, understanding what it means, and telling me. You can use it to improve language as an editor. One thing these AIs are amazing at is style transfer. You can say, in the style of, and so here's chronic kidney disease in the style of Shakespeare versus Flava Flav, depending on how you want to see it. You could change languages, explain it in French, and it gave me back this very passable French, and which, by the way, is quite remarkable for a model that was, in theory, trained exclusively on English. But text-to-text, that's really just the tip of the iceberg. When you dig in, you can actually do any sequence to any other sequence, provided there's a causal relationship between the two of them. So let's look at text to image. So this is, on the left, I asked Midjourney, give me a woman undergoing kidney dialysis. And it drew these 4 pictures for me from its imagination. That top right image there, that's not a photograph. That's just how the AI Stable Diffusion responded when I said mullet. And then I said mullet in the style of a car, and it gave me a car that's all fun in the back and all business in the front, which was pretty remarkable. Understood the mulletness of a mullet. You can think about, image to image. Here's a painting. I went into DALL-E, which is another OpenAI project, and I cut out this area in the bottom, and I said, hey, it's a painting on the wall that includes a border collie. And it drew this. It put in the right kind of dog at the right scale with the right lighting in the right style, and it fits in with the painting. So that's quite impressive. This may not be as impressive to some of you as it is to me, but this is code to code. So here I am, I'm writing some code, and every now and then you'll see some gray text pop up. That is the AI from GitHub's Copilot suggesting what comes next. And this is like pair programming with another person. It just goes so much faster. GitHub's internal research says it about doubles the output of their programmers. You can do text to objects. This one's called Pointy. I said make a purple snowman. There you go. There's a point cloud of a purple snowman. You could feed this to a 3D printer. You could take it into a character creator software, and away you go. You can even use this for chemistry. So this is a little bit of an older technology, but it's still a generative AI called Megasyn, and it tries to predict the bioactivity of molecules and optimize for drug discovery. And this one's particularly interesting and famous because the authors and the creators of it did an experiment. Usually the model rewards activity and penalizes toxicity. And they decided to flip the bit, reward toxicity and reward bioactivity. And they let it run for 6 hours, and it generated about 40,000 molecules, one of which was VX nerve gas, several other known chemical warfare agents, and about 1,000 molecules that it believes would be more deadly than VX gas. So this should give us a moment of pause. This stuff works. It's very powerful, and anything powerful needs good ethical controls around it. So where does all this go in the future? First of all, we have to automate record keeping. We can't have physicians spending all their time writing records. This is super important. That chart I drew, doctor database. Just put one little AI in there to take the doctor's speech and put it in the database. We don't need to go through all this stuff. We need to automate ritualized communications. Right now, you have the call center where you call in, you get put on hold, you get frustrated, you hang up, you call back later. We could replace this with a conversational system to make the interface to any complicated system just plain language for people. We need to do personalization at scale. Have every patient or every physician come in with all of their needs understood and baked into their journey, their comorbidities for their aftercare instructions, their staffing schedule for how their assignments work. All of this can be done. If you're a researcher, this is a very powerful tool. This works by finding connections between ideas. So it'll find connections that no one has seen before or just connections you haven't seen before. And either way, very helpful. It democratizes creation. I have literally no artistic skill, but I can make that with Midjourney to illustrate my idea. If you're not a coder, it can help you write running code. This is going to be the programming interface of the future. You just talk to the computer. We'll get rid of the programmer. Describe what you need, and it'll show up. Making interactive virtual reality is a really exciting place both for gaming and also for therapy. Imagine exposure therapy where you describe your trauma and it creates the correct environment for you to re-experience it safely. But I think the really powerful things that will come are going to be future sequences. Imagine a CT scan sequence or an ultrasound that gets turned into instructions for a 3D printed implant automatically. Imagine, signals coming from various leads within the cardiovascular system turning into a customized corrective signal that gets sent back out to the different parts of the heart in real time, instead of just a shock. Imagine taking the start of a genome, saying, hey, I want these genes, and doing that text continuation thing I just showed, but with genomes, and having it fill out the rest of the organism. And by the way, the databases for this are already being built. GISAID now has 15 million COVID-19 sequences in a single database. So the training data for this is starting to be created today. Imagine, having a chemical saying, hey, I need to manufacture this. Could you please create an organism that excretes it so I can put it in my bioreactor? You can see these technologies really can be game changers. And I think the biggest one we have is the one we haven't thought about yet. There's going to be something. So I want to talk a little bit about limitations as well. This is a very powerful approach, but it doesn't do everything. It's kind of like search on steroids. It's predicting statistically likely continuations of whatever you give it. And how does it decide what's statistically likely? Well, there's no such thing as a free lunch. All of these ideas that it has comes from either the input or the pre-training. And it has all the same sort of biases and problems search has. It's been trained on scrapes of the web. So it tends to tilt towards the weight of the discussion instead of the weight of the evidence. It doesn't know how to evaluate these statements. It's going to pick up all the same human biases, mistakes, and misinformation that real humans do out on the internet. And we have to be careful about disinformation. Wikipedia, for example, is a key training source. Are there going to be attacks against Wikipedia to put in false ideas to try to poison the next generation of AIs? Are people going to use these AIs to try to perpetuate ideas into future training? The war for truth is going to get a little messy. The other thing I will say is, this sort of comprehension of the concepts plus the variation looks like cognition. To you and I, who are used to evaluating intelligence by language, looks pretty good. But it's faking it, right? This is not cognition. What you're seeing next is the statistically likely next set of words. It's not reasoning. It's not creating brand new ideas. It has no ethics or morality, although some of the developers have put a layer of that on top to try to prevent things from going wrong. And it's not a root source of innovation. There's no genuinely new ideas coming out of it. It's just a tool for linking concepts, and a really good one. So I want you to think back to the two sort of disasters we have to avoid. We don't want to create chemical weapons, and we don't want to continue perpetuating the nonsense that's already in our healthcare system. So I would say to everyone here in this room, this future we're talking about, the exponential future we all want, it's not inevitable. We have to consciously create it. So I think what we need is a Hippocratic oath for health tech. First, do no harm, and second, pay down that technical debt. The people here are all innovators. As you go out and apply them wisely. Think beyond the obvious, try to clear some plaque out of those arteries in the health system, and leave it a bit better than you found it. And with that, I'll say thank you. And if you want to try anything out, we have a page of examples.
Thank you, Ralph. That was an amazing overview and the taste of what's here and what's coming. Rumor has it ChatGPT-4 is coming out in the next week or two. I was at a meeting last week with the head of research and AI from Microsoft and their Prometheus platform, and its power is pretty trippy. Right now, it can pass about 65% of the boards, and they can do 95%.
Yep.
So if we're going to go to what's next, 5 or 10 years out, just let's say for healthcare education, what implications would you have for this NextMed audience?
I think it would be incredible what we can do. I mean, in terms of health education, we're going to have to rethink how we do examinations. I think you may see the return of the oral exam, where you actually talk to the student and have them present. But in terms of the actual education, imagine creating a virtual patient, an avatar that's going to react to what happens in the clinical setting in a realistic way, whether it's your bedside manner or your medical technique. Right. And I think that would be a big benefit for medical ed.
And for each of us to engage with our own health data continuously, we'll have our own ChatGPT-5 sourcing and answering questions without having to go to the clinician. So.
Yeah. Well, maybe someday.
Exciting times. Thanks, Alfred.
Thank you.
So honestly, we could spend probably the entire 4 days here looking at AI, machine learning, big data. But to kind of wrap up this sort of key session is my friend and colleague Ramesh Raskar, who's the associate director of the MIT Media Lab, professor at MIT, an incredible convergent spot of innovation at MIT and beyond, who's going to talk to us about decentralized health, medicine, and data, going from the shallow web to the deep web, and the art of what's coming next. Ramesh, you're up. Thanks, Ramesh. All right.
So when you hear Web3, what comes to your mind? Cryptocurrencies, NFTs, DeFi, a lot of hype, and a lot of scammy stuff. But today we're going to talk about how Web3 can be actually used in health in some really unique ways. And what do we need to get there via decentralization? So my cousin Maria, who's in rural Texas, recently had COVID, has chest pain, her family has history of lung cancer, and she's just not getting good advice from her doctors of what to do next. She's very worried. On her behalf, can I bid $1,000 on the global hive and bring the best answer? I mean, when you flew in here, you might have used Expedia or some airline search engine. It was easy enough to just type and get the best possible options for you to get here to San Diego. Can we do something similar in healthcare? And one would argue that if you have a God's eye view into everything that's going on, look at all the health data, bring this millions of petabytes of data together, train the best machine learning model for it of patients who might have conditions similar to Maria, and then take those $1,000 and reward people who actually contributed the data, whose data was actually used. Many people might contribute, but the data was used, and eventually create a very nice interface for Maria to see if she wants a treatment that's more aggressive, less aggressive, whether she needs to travel for it or not. So it seems like the solution is almost always here, but we cannot find it. And of course, the reality to achieve this God's eye view is that the data is highly siloed because of privacy and regulation. What does it mean to even train the best AI model? Can we really spend billions of dollars setting up infrastructure to look at millions of petabytes of data? How can we reward the people? How do I figure out whose data was eventually used? And what does it mean to create a highly interpretable, highly reliable interface and information? So we heard about ChatGPT, and this sounds like ChatGPT, right? The challenge is that as amazing as ChatGPT is, it's only the tip of the iceberg. It can only look at the surface web, the information that's already captured and available online. It's got the past data, the Wikipedia, all the research papers, textbooks, news articles, and so on. But if we really have to solve the next generation of health problems, we have to start looking at the deep web. These are data that we may or may not have, may have to go and capture in more clinical trials. It may be electronic health records. It could be your CT scans, MRI scans. These may be trade secrets that are with pharma companies or large hospitals. And then we have information about pricing, the pricing dynamics. That's almost real time. So we need a highly decentralized approach if you want to create an AI at the scale of ChatGPT going forward. So how are we going to get there to attack this deep web? Now, if I want to help Maria and we don't know what her condition is, the way it works today is researchers will, write funding proposals, aggregate data, find patterns, publish that research. It will generate 2 new protocols. Eventually, this will become a state-of-the-art, guidance, and then we'll start interfacing with doctors, hospitals, and those patients. So the funding, the AI, and the health UX is a very slow process, could take years. And this slow, inefficient coordination among the organization, it's what's literally killing people. So can we bring Web3 to our rescue? So again, this is not about fintech. This is really taking the decentralization and ideas in Web3 to the data and AI economy. So we all heard about Web3 as Web 1 was read-only, Web 2 was read and write, and Web 3 is decentralization. So Web 1 was kind of, CNN and Yahoo, information dissemination. Web 2 was, coordination among individuals, so Facebook and Uber. And Web 3 is about P2P cooperation. Probably the best example is Bitcoin, where you don't have a CEO, you don't have a central office. This is great in terms of how data is being connected. But the data is not just about transactions. It's not just about website from which we're downloading the data. The data can also be about what's in this deep web. And so as we're looking at connectivity of data, what also matters is the intelligence. And if you believe in singularity, it may be here in the next 5 to 10 years, we also just want to start thinking about what kind of intelligence is going to emerge because of this connectivity between data elements. I think that's where we reach at the top right, where we have Web3 and decentralization of AI that will allow us to do this self-orchestration. So I'm going to talk about 3 potential concepts in decentralization. One is how the funding and science could change with techniques like decentralized science, how the AI itself is going to transform with decentralized AI, And the health UX, electronic health records, whatever mechanisms you have of interfacing between entities, how's that going to change with protocols like NOSH, which is Noster for Health. So let's start with decentralized science. Now, if you think about all these mechanisms, and I'm a professor, in this space, and this is what we have to go through. Funding, the governance, the reputation, the lineage. We have to keep track of all of these things in science, but there is a massive transformation happening in science space. So patient groups are crowdsourcing, desire to have new drugs and new treatments, new protocols. There are decentralized organizations for governance, problems like identity and verifiability of researchers and their research work is also being transformed by adding metadata and verifiable credentials. And of course, the researchers themselves are being incentivized through tokenomics. So I want to thank Omar L., who's here in the audience, for putting this whole together. He's one of the experts in decentralized science. And he also runs this platform called Weavechain. So there are companies, to take an example, like Reputable, that are focusing on using wearables for sleep data. And if you want to kind of take that research and incentivize individuals to start sharing their wearables data, we need different ways so that users can try these protocols, share the data, earn the rewards, and so on. And we can create this economy where the research and data is verifiable. At the same time, the economy, the friction is reduced through Web3-like mechanisms. So take a look at Weavechain. Let's look at the second problem of how do we take AI to decentralized AI. Now, we can use many building blocks of existing Web3 infrastructure. Isn't that amazing? Like the things that have been built for Ethereum and Bitcoin and decentralized finance actually can be used to achieve this. So there are 4 main operations when we run these decentralized fintech activities: aggregation, mining, rewarding, and some kind of a interface. And that's solved through pseudo-anonymity, ledger technologies, and so on. Now, we need to upgrade each of these pillars for decentralized AI, where it's not just pseudo-anonymity, but true anonymity with privacy technology. Instead of just ledger technology, like you might know blockchain, we have to go to verifiable activities in terms of data and research. And instead of just incentives, which is speculation or gas money, we have to upgrade that to full-fledged data markets and exchanges. I hope you're not using FTX anymore. We have to create new types of exchanges that really allow all of us to interact. So let's take out the first pillar out of those 4. Now, pseudo-anonymity that you see in cryptocurrencies has to be upgraded to privacy tech. Now, there's always a trade-off between privacy on the horizontal axis and the utility on the vertical axis. So if you use Google Maps, we willingly give away our GPS location to Google, and in return, we get fantastic utility. We can all see where's the traffic and how we should navigate. But if you look at the bottom right, when it comes to health data, we worry about privacy and regulation, so the data remains siloed. That means the utility overall of that data remains very low. So this is a classic trade-off, this privacy-utility trade-off. And our hope is that technologies like decentralized AI, distributed private AI, will allow us to be in the top right. And there's some amazing research that's going on. So let's look at what's that space. So again, utility versus privacy. You may have heard about technologies like anonymization, k-anonymity, and confidentiality. None of that is privacy. So GDPR, CCPA is on the bottom left. Okay, that's not really privacy. The technologies that others have used is like obfuscation by adding noise or doing full-fledged encryption with technologies like homomorphic encryption. The problem is, as you go to the right, as I said before, there's a trade-off. The utility of the data goes down. Instead of training full-fledged machine learning models, you can only do maybe some inference and some statistics. Now, our goal is to kind of collect wisdom from this millions of petabytes of data without exchanging raw patient data, right? Not centralize all of that in a single place. So 2 technologies have emerged over the last 5 years that are very fascinating. The first one is called federated learning, invented by Google. And the second one is called split learning, which is invented by our group at MIT. And these two ideas are somewhat similar with this notion of extracting wisdom without sharing raw data. And so for Maria, if I have to kind of submit her chest X-rays to get some, idea of is this kind of a new type of a pneumonia or it's just a long COVID-related pneumonia, we want a global algorithm. So we might have, 100 hospitals. Each of them have their own X-rays. Let's say they have 1,000 each. I would like to take this 100,000 chest X-rays and train the best machine learning algorithm. But these 100 hospitals don't want to do that because of regulation, because of trade secrets, and so on. So what can we do to create this global AI from these different 100 hospitals? And this is where the notion of collective intelligence comes in. What I would do in the real world is I would just get 100 medical interns and send them to these 100 hospitals. And if the first hospital has more diabetics, the second hospital has more children, the third hospital has more elderly, fourth hospital has more smokers, my interns would go to these 100 hospitals, and they would come back. And if I bring them back to my conference room, and if I show them this new X-ray of Maria, at least one of those 100 interns will say, oh yeah, I know what that means. And we have trained at these 100 different places, and I have this collective intelligence of 100 interns. And the beauty of that is these 100 interns kept complete privacy. They didn't have to bring the physical data from those 100 hospitals. They just brought the wisdom with them. Now, can I apply the same idea purely in software? Right? How can I bring the wisdom without asking the hospitals to give me each of their 1,000 X-rays? So the idea behind federated learning is exactly that. We ask every hospital to take their 1,000 X-rays and create a local machine learning model, a local AI. And we have this 100 such small local AIs, but they're very imprecise because the AI that works on smokers will not work very well on non-smokers. And the work that works on children may not work on the elderly, and so on. But that's fine. Each of those 100 hospitals have their own local models. And in simple words, we're just going to take an average of those 100 models in a central location. So we brought the machine learning models to the center, but did not bring in each of the 1,000 X-rays. That's the basic idea behind federated learning. And the idea behind split learning is also very similar, which is instead of relying on bringing these models, we can just ask each of this intern which machine as well. So using one of these two techniques, we can create collective intelligence. And this is what's required to create that global AI. So let's look at the second pillar, which is the ledger technology. And when it comes to cryptocurrencies using blockchain, you see things that's written on the left, like hashing and proof of work and consensus among nodes, and how do you publish that block. So I need to verify that the machine learning was trained on actually those X-rays that the hospital claims, verify that the AI they're sending me is actually the one that I can use. I need a mechanism to select the best of them, because there are 100, I need to choose either the best or a combination. And I need to be able to respond to that query when I show Maria's X-ray to see how I should get response from it. Now, what's the incentive for those X-rays? Which one should I pay for and which one I should not pay for? So as the buyer, on behalf of Maria, I'm going to talk to the sellers, which are all the hospitals, and they're not going to send me the actual X-rays, the 1,000 X-rays they have. But I'm going to send them a puzzle to solve, and then going to send me answer to that puzzle. And this is a methodology called nonlinear correlation. And by taking those samples, those results, right? And based on that, I also have a way to split my $1,000 among these 100 hospitals. By the way, all of this happening in the background using bots. No documents are involved. No legals are involved, and so on. So we need these mechanisms where I can estimate the dollar value of the data that's invisible. And finally, we need an exchange, very much like Expedia, where I can discover where these hospitals are, because they're not going to raise their hands. There are thousands and thousands of different hospitals. I need to visualize how data is coming from them, and also need some kind of a decision support system when it's all pieced together. So we need these 4 pillars to create a decentralized AI. Now, that seems like a lot of coordination, societal orchestration that's going on, and payments are being made, and data is being learned from, and so on. Now, who's a big fan of here, Luna and Terra and so on, right? I mean, all this dream of algorithmic orchestration, including what we are seeing this week, can fall apart very quickly because of unintended consequences. So there are a lot of risks in how this is going to play out. And we need kind of low-stakes scenarios where some of the systems will be deployed first to see how this could play out. And bad actors can introduce adversarial data. They could introduce, wrong X-rays. They can mislabel those X-rays as, pneumonia or not, and so on. And this would have been fine to learn about bias and noise when we look at the data. But when the data is invisible, how can we validate that information? Finally, let's look at health UX. Right? And if you're a fan of Epic and Cerner and so on, I think we have some amazing UX out there, right? You'll all agree. But it's going to be very different. Why can't we build an interface with our health system, for Maria, that feels more like email, that feels more like using Amazon e-commerce or Uber? And that's where ideas of decentralized interfaces comes in. So Jack Dorsey, for example, is promoting Nostr, which is a decentralized version of Twitter. And Nostr is really taking off. By the way, Nostr comes from Nostradamus. Now, there is a similar protocol that's coming up that focuses on health UX using EHR. And this is Nosh, which is Nostr for health. And these decentralized interfaces will work very much like a secure email. So, Maria is in Texas, but in her own county, there are almost 3,000 people with the same exact name, Maria Garcia. And this creates a massive friction in electronic health records because, you can't just type her name and date of birth to make sure you're reaching the right person. So identity and locating records, patient matching, tracking her consent are extremely complex. So this is where Nosh comes in, and this is a protocol being built by PathCheck Foundation, by Pamplona and Dodge. And here we have HL7, VPN relays, WHO smart guidance, and verifiable credentials that can solve many of these problems. So check out their page for a study group that's building these protocols. So next time we worry about how we're going to provide this solution for my cousin Maria, we have all these opportunities that are emerging. Decentralized science, decentralized AI, and Nosh. So how many of you think in 10 years, more than 50% of science would be done with this decentralized science protocol? Okay, few of you are convinced. How many of you think we will be able to really tap into a next version of ChatGPT that can look at this deep web information that's barely visible, but has to be tapped through these protocols? Wow, quite a few, more than half of you. And what about getting rid of this old-fashioned health interfaces to make them completely decentralized? All right, pretty good, pretty good. So we can really build this Web3 for decentralized health. And if you're interested in this, we have a center at MIT on decentralized society and Web3, thinking well beyond fintech for Web3. Thank you.
Thank you, Nish. So, amazing overview. Quick question. I don't think many people think the user interfaces on EMRs are wonderful. Epic fail. The question would be, what misaligned incentives are there for this types of technology, decentralization, to enter our EMRs where there's big forces at play to keep the status quo?
Yeah, I mean, we know that the reason why we don't see as much progress in health compared to other areas, which are not as regulated, like supply chain or e-commerce and so on, is because of regulations that don't keep up with innovation. Concrete example, when we start looking at split learning and federated learning, health systems still don't realize that by sharing models, you're not actually sharing raw data. And so on. So I think the regulations are going to be a major concern. And that's why I think the innovations are going to happen on the edges. My guess is that first you'll start seeing this in public health, in fast-moving threats like COVID. And then over time, it might go to care and drug discovery and so on.
Awesome. Great. Thanks, Ramesh.
Thank you.
All right, last talk before a break, and you're about to have your minds further blown. Raphael Grossman is a practicing surgeon who was one of our early participants when it was back in the FutureMed days, who was inspired and saw early technology and has taken it to action across the operating room or beyond. So I'm really glad to have back with us Dr. Raphael Grossman on AR, VR, and collaborative XR and beyond. Raphael.
Thank you, Dan. Well, hello. It's really a pleasure to be here again, and thank you, Dan, and everyone for making this happen. So I'm a surgeon. This explains the outfit. I feel more comfortable, but also we're in California, so I got Birkenstocks, and I dumped the suit and all of that. But I'm a full-time surgeon, and I'm also sort of a geek of sorts. I love technology and how technology can really empower us. For me, it all started about 2012, 2013, because of this guy that you see on screen, Daniel Kraft at FutureMed, and Lucien Englin, a good friend, that took this picture. This is the first crowd, and that's where I met Babak Parviz. Babak Parviz was the inventor of Google Glass. Google Glass was, as you probably all know, almost like the first smart glass or smart sort of AR device. And when I saw what the glass could do, I said, you know, we really have to use this in health.
What defines
I want you to hear this.
Possibility? A bright light in an endless space. For more than 3 decades, my job has been centered around certainty. The certainty of hope, of saving or improving the lives of those who trust me through surgery. Once you chase the ability to strive for certainty, the mind becomes restless. And that is the seed of possibility. Welcome to the world of extended reality. Through XR, we can understand the glory of our past, the pulse of our present, and the potential of our future. However, there's a greater possibility that XR presents. It can give us the ability to revolutionize the fabric of humanity, medicine, and education through technology. You can harness the potential and efficiency of your practice by enhancing your world through augmented reality. You can become a better learner through virtual reality by opening the doors to innovative simulations and resources, or interact with a hybrid world through mixed reality where the possibilities are endless. There's never been a better day than today to change our world for the better. My goal is to bridge the gaps in healthcare and education by instilling humanity and technology into the lives I touch. Join me in building a new world of possibility and certainty through passion, vision, and collaboration.
Thanks. I just wanted to bring that to you because to me it's about that, about collaborating. Extended realities, VR, AR, mixed reality is something that has been talked about a lot about, and it's something that we in healthcare have been barely starting to use just a few years ago. For me, as a clinician, the possibilities of collaborating in another sort of dimension, this XR dimension, are real. Google Glass, when I did the first operation with Google Glass shortly after FutureMed in 2013, all I wanted was to connect a group of students to me through the live streaming. And you know, many people have done that later, afterwards. I did it with a couple of students. My dear friend Shafi did it with thousands of students not too long after that. And it was just about showing our perspective, about having a digital assistant of sorts in our face, in our head, connected to us. The history of this has been lengthy. VR has been around for a long time. We have had places like MIT, where the first AR device was sort of concocted, and it was so heavy it had to be suspended from the ceiling. We all remember the famous Google Cardboard, right? That brought almost a virtual reality into a daily, easy, accessible reality. The devices have gone from a very, very slow progression, from very complex to very sophisticated and expensive to very inexpensive nowadays. So we all, extended reality is something that we understand. Just a quick review: augmented reality, you are creating a digital world over the real world. You have mixed reality where that digital world interacts with the physical, and then we have virtual reality where you're completely in a computer-generated environment, right? And you are living sort of a different reality of sorts. And we all have seen simulators in the past, right? No one can fly a plane before they actually are in a simulator for many, many hours. We all have seen how virtual reality can almost change the mind. And if you have done an experience, you see how basically you are transported to a different dimension. You know you are on the ground, but you can't really step out of the actual area because you think you're going to fall. So all of that, in a way, has tremendous power in order for the experience to become real and become significant. We all have seen what HoloLens had done, years ago with the first edition of HoloLens. We have seen what things like medical holodeck have done, where you actually have a cadaver in virtual reality, and you are dissecting a cadaver, and you are learning anatomy like it was never done before. And you can have a multi-user sort of experience with no geographic boundaries. All of this is very, very powerful. If we bring mixed reality into the picture, you see what GigXR is doing, where they have digital patients, actors that are in your physical reality, and it doesn't matter in the world where you are, you can bring that patient to your living room and learn about that patient, learn medicine, learn how to examine, learn how to diagnose in extended reality. So the power of this is real today. We talk about, the potential of things, but now the potential has been realized. In nursing education, we have already, in a way, revolutionized many nursing schools by bringing virtual reality to the curriculum. Bundle Arrays is a platform that allows virtual reality training at a distance, multi-user, and you can have any sort of activities that the nurses need to learn in order to professionally advance, but all in virtual reality. So there are platforms like Fundamental VR. I'm one of their advisors, by the way, an unpaid advisor, but I just see that what they're doing with nursing education, with the shortage of nurses that we have today globally, and trying to enhance the way the nurses train by bringing virtual reality capabilities to that curriculum. I think that is all only fascinating. I think that if you have a new grad, or you have a medical student, or you have a technician or nurse, and they need to learn a procedure, they can master that procedure in virtual reality. They can master that procedure before they actually go to the human. If you think about, for example, robotic surgery, and you see how many times you have to fly people all over the world to train the local people to do a robotic system setup. This is a video that Fundamental Reality did for the Versus, the CMR system. And again, all you need is connectivity, and you need a headset in order to master the setup, which is one of the key features of doing a robotic-assisted surgery. As a surgeon, we all know the traditional tools, but now the tools have been somewhat replaced by these other tools that bring us to where we are today, and get us really excited and curious about the future. So we are in the now. So what's about the near and the next in extended realities? Well, I personally think that the list is very, very extensive. But, having multi-user capabilities, being able to collaborate in XR, what is being called the metaverse, that is the key, where you're not just alone learning, but you're collaborating and interacting with other humans, all without the boundaries of geography, where you have an exponential growth of the technology, where the technology is being adapted to mobile devices. We all know about AR-Kit and AR-Core, where everyone in their pocket, they have an AR device in their pocket. So that is something that is been progressing very fast, and it will continue to progress up to the point where we might not even have phones in our pockets any longer. One thing that is very, very exciting to me is the sensory integration, the form factor, the haptic ability within VR. That is something that is, for me, a game changer. And not just the haptics, but all other senses can be integrated into VR. I'll show you later where you can integrate basically the olfactory system into a virtual experience, enhancing and augmenting that experience. The costs have been decreasing significantly, and now we are, in a way, democratizing the access to these technologies in a way that we couldn't do it before. So a platform needs to be multimodal, multiplayer. A platform needs to be scalable, needs to be accredited, needs to be validated for the outcomes that it produces. It needs to have data insight, enabling effective knowledge and skills monitoring. It needs to be AI-powered. We heard a lot about AI and how it can potentiate what we do, and it has to be cost-effective. Cost-effective is very, very important. You saw the graphic of the cost, and that we cannot continue to spend money that way without significant results. So this platform that Fundamental VR has been focusing on has the power of the haptic connectivity, and I think that brings it ahead of some other incredible other technologies out there. You have also VR, you have a Precision OS, you have Orama VR, but I think that the haptics integration is very, very important, and we have been proving that that is something that it really, really makes a difference. So I was going to bring the haptics glove, and I didn't have the chance to do it, the new generation here on stage, but again, having the ability to feel what you are seeing in virtual reality really, really changes the game. This is a company from the Netherlands called Sense Glove. They have their new platform called the Nova glove, and it's really phenomenal. It's just a glove that allows you to feel, in a way, what you are touching. Brings that sensory of touch, the haptic sensorial input to the actual experience and making it more real. So, in a way, I think that we are living in a time that has never been like this before. We, in everyday life, but especially in healthcare and in healthcare education, we have come to places that we couldn't imagine. Who would have imagined that you can smell VR, that you can cook a pizza or learn the steps to make a pizza in VR, and then you can smell the aroma of mushrooms or tomatoes or whatnot. And this should have sound, I think. But I think it's important in healthcare. Skip Rizzo in California have taken advantage of this platform or similar platform to bring soldiers that have PTSD into the battlefield with the smell of burnt powder or burnt rubber. I think that has really, really a strong potential in order to improve the experience and make it more real. In the operating room, we talked about education, we talked about diagnostics, but in the operating room, we have technologies like Apocular. Apocular is, in a way, changing the way we do surgery, because you can bring all the data from imagery that you sometimes need for surgery, and you can manipulate that data in real time in 3D, and you can, in a way, change the outcome of the surgery by improving how you interact with that digital data. You have RSQ, that is also a fantastic platform which brings any sort of endoscopic or digital input into that VR or into the XR, experience. So this is the real today. This is the now. I think that we need to keep in mind that these technologies are really developing so fast and so quickly that it's really hard to keep up with them. Many of the surgeries that you see here are surgeries that are not being done even in the United States. So it's becoming really a global phenomenon in a way.
way. You can have the real time, the real physical surgery data, but also you have XR data that is sort of superimposed and enhancing that activity that the surgeon is doing in real time. At the end, improving the flow of the surgery, having a more human-centered experience, and having better outcomes at the end, which is really what counts. I'm finishing a master's at Cedars-Sinai, Health Delivery Sciences, and my capstone is on using that extended reality in order to bring the EMR to the bedside. So why are we not using XR in order to interact with the EMR on the point of care, on the patient side? We all complain about EMR, and it's really a terrible shame that the way we interact with the EMR today involves taking the physicians, the nurses, the clinicians towards a path on burnout. I think that we need to bring that experience to be really appropriate to the 21st century. There are repositories of data that are unbelievable. You have the Blausen experience, for example. Blausen has an incredible amount of very high physiologically and anatomically correct images that are basically available to bring into the ER, to the VR world. If you link those images to the EMR, I think that the experience could be really phenomenal. If you bring that AI algorithm component, something like a ChatGPT, you bring that possibility to the experience, and then you make that experience really much more fluent and really something that really makes a difference. It's a collaboration. It's becoming still a better human, not isolating ourselves with technology, but actually reaching out to others with technology. Having technology be a bridge to what we do. Shafi will talk to you guys later about what Emedis is doing and creating a metaverse, creating really a space where you can digitally be connected, improving the workflow of receiving care. This is something that, again, is not a possibility. This is something that is here today. I think that we need to reimagine how we connect, for example. This is something that we did about 4 years ago, bringing avatars into a physical space and all connected from different parts of the world. You can actually basically interact with another clinician, learning or teaching, democratizing, in a way, learning, democratizing expertise. If you think about platforms like Proto, where I tried this at AWE where I spoke, and you can have a simple device bring you speaking in real time, seeing what you need to see, and also having your whole self, in a way, presenting to other person. Imagine the potential of this for home care, for example, to have a person discussing with you what the plan of care is. We are in an age of really excitement, an age that is bringing technologies that were unthinkable before to be a reality, where you have possibly smart glasses that will go in your eye. You have a contact lens that will really allow you to enter that XR space. I'm a fan of science fiction, and you all know about the blue pill, right, and the red pill. And if you choose that red pill, possibly I'll teach you how far the rabbit hole goes. So I encourage you all, and I know you are because you are here, but take the red pill, because we need to embrace these technologies in order to make healthcare more humane and more accessible to the rest of the world. Thank you very much.
You forgot something. So you trained as a see one, do one, teach one surgeon,
yes,
as did I. So the 10,000 hours to get, what's going to happen? Who can be a surgeon in the future with these new types of technologies?
Well, I really think that technology is enabling access and enabling also the flow of knowledge. And I think that a technology like the Magic Leap 2, I was going to bring it on stage, and I thought it was going to be really clunky with my microphone. But I think that this technology technologies can really bring education to anywhere at any time. And you can, like that pilot on the simulator, you can bring expertise, improve performance in a cost-effective way to anywhere in the world. And again, democratizing teaching and learning. I think that that's sort of the key.
100%.
We were inspired by the fact that you were wearing your scrubs, and it's so important because medicine, surgery, healthcare, it's a team sport. So, question for you, and I really loved how you were talking about training and specifically nurses, how they're training. Question for you, do you ever use music in the OR?
Absolutely. Music,
and tell me, does that help?
Well, yeah, it helps. It helps chill. And I usually don't have my own playlist like many surgeons do. I actually let, and that's the way to, whatever the nurses want, whatever the nurses want. So
smart man.
The playlist,
smart surgeon. Smart surgeon.
Go faster.
Yeah. How many of you ever use music and find that it helps you in your performance? Well, you are not alone, and there's actually data and evidence and research to support this. So we have been working on a fun collaboration with our friends at Click, who found some research. Actually, they didn't find it. I mean, it's really taken off. There was some group of folks that were looking at surgical performance and wondering, does music actually improve performance in terms of accuracy, precision, team cohesion? And the answer is yes. So question is, how do you bring that to life? Well, count on Click to be able to do that. So if we can cue this
Well,
video,
actually, it's not any music.
Well, don't spoil it. Don't spoil it. Yes, it's not just any music, and it's not just any genre. There's a very specific type of music. So if we can cue the video and run this and get ready to rock on.
There are 313 million surgeries every year, but only 1.2 million surgeons. And surgical complications are the third leading cause of death worldwide. So how can we help surgical teams stay efficient, energized, and in the zone when lives are on the line? NextMed Health presents Life-Saving Radio, the world's first album and AI radio station clinically designed to improve surgical performance and help surgeons save lives. We started by rewriting the songs of AC/DC, the band clinically shown to amplify surgical precision. Then customize the OR audio experience to maximize its surgical effect.
Hey everybody, it's Dr. Von der Wright, and we're about to play Highway to Heal for the first time in my OR, so let's go.
Good morning, Dr. Von der Wright. I'm your AI DJ, AI Angus, here to help your surgical team stay as sharp as a scalpel with a custom surgery soundtrack shown to amplify efficiency. And you're operating to the title track off Highway to Heal.
Shown that music can affect performance. What we want in surgery is to be extremely accurate and precise and be in the zone.
I love how Life-Saving Radio can help our teams achieve flow state to reach peak surgical performance, ultimately improving patient outcomes.
It's a perfect example of the super convergence of big data meets AI meets personalization, starting off in the operating room.
We are so excited about Life-Saving Radio and what it's going to do for surgical performance.
Scrub in and rock out to Life-Saving Radio. Up and roll.
And here you have it. It's no longer Highway to Hell, it is Highway to Heal. And so from this research, actually what we found is this music, the amplitude, the pacing from AC/DC is actually what is helping to improve surgical performance. So what you heard there is not Highway to Hell, it is actually Highway to Heal. Click worked with their incredible creative team, and they've come up with this new album where they've taken 11 of AC/DC's tunes. They have rewritten all the lyrics that looks at surgical conditions, surgical procedures that they're going to do, and they have created this album. And in addition to that, Life-Saving AI Radio, because the whole concept of how do we use AI to customize the surgical performance, to bring teams together, and to actually not only improve the performance and the accuracy and the precision, but the patient outcome. That's the ultimate piece. So you actually got to experience this in your OR.
Yeah,
Thoughts?
It's brilliant. I'm not much of a music guy, to tell you the truth. And, I listened to all this music in English when I even didn't know English. So I focused on the rhythm, but not in the lyrics. But then, with time, and especially I was trying to understand the lyrics, and I really couldn't. But when you read the lyrics, and they're all, oh, that's not the original lyric. That's actually a medically oriented.
Yeah, you sold me all night long.
It's unbelievable.
Sold me all night long.
It's unbelievable. I think that it's a great a movement, and I think that having it on a vinyl sort of record, it's actually very interesting.
Well, I don't know that anybody has record players in the OR, but we all are using our playlists. So that's really the beauty of DJ Angus, is bringing all of this to life. We had a couple of shots here of what that's going to be looking like. So while you are here at NextMed, we are going to be introducing you to all sorts of new tunes that you're going to be able to rock out, scrub in, rock out,
karaoke,
and improve.
Sing along.
Karaoke, the disco, and tomorrow. So you see, we've got the next yet to be NextMed scrubs, but these are also going to be the highway to heel scrubs, because tomorrow, starting early in the morning, you get to go customize, and you'll get to have whatever we've got 4 options of logos for NextMed, but on the back you're going to have the highway to heel rock tour. So we will have all of that listed, and you can go out there and go get those printed. So anyway, we are super excited. You are going to learn a whole new set of lyrics to rock out to. So we want you to go have a break, but before you do, we need you back here. What time are we going to have?
30 minutes?
Not 30 minutes. We need you back here at 4. So, so you're 30 minutes, but before you do...
We have an assignment. While you're on your break...
We got to cue the music.
We're going to cue the music, see the lyrics, but you have an opportunity to meet 3 people you don't know. Go visit the Innovation Lab and come back, rock out, be back here in 25 minutes, promptly. Thank you.
Thank you all.
All right, we're back.
Guess what we're going to be doing?
Yeah.
Yeah, we said we needed to get to know each other, so we're going to put these down over here.
Here, catch.
Yeah.
That's for practice later. Okay.
Oh, sorry, that was a terrible toss. Terrible. But Esther, of course, Esther can get it. That's right. So, yeah, when we talk about having karaoke night and getting to do all that stuff, I think you should be rehearsing. All right.
Okay, welcome back, everybody. How did you guys enjoy the Innovation Lab so far? Pretty amazing. We've got like 60+ startups there, and what's been interesting over the last 10 years is see some of them go from baby startups to going public, matching up with big and small corps here and really making interesting impact. So don't underestimate the power of the baby seed stage company. We'll be having what's called the MEDI Awards, Medical Entrepreneurship and Disruption. So 20 of them will be competing to give a pitch here on the main stage on Wednesday night. So go and meet them. There's also a lot of interactive things. You can all have your own human avatar made, and that could be your personal avatar for entering the Mediverse, not the metaverse.
You can work out.
There'll be a VR workouts in the morning. So lots of things to explore. Remember, the breakfast opens there at 7 in the morning. So
we'll go through all that later.
Get that later. Yeah, later. Okay. So if I get my slide deck up, we're going into our next sort of intro to technology set with some amazing faculty and elements to cover. We just covered a lot around AI, big data, Web3, and all that sort of converging on another field that's definitely moving more than exponentially. That's the field of genomics and genetics. And we're now 20+ years into the genomics revolution. How many people have been sequenced? Just curious. Probably a little early adopters. Who here can do anything with their genome? Far fewer. There's some, but we're going to learn the art of the possible for today and what's next. So this is what's now near next, Technologies on the Exponential, Part 2, and we're going into a session on genomics. And I can't be more honored and thrilled to have these two amazing faculty join us. Number one is Baroness Nicola Blackwood. She's the chair of Genomics England, also a member of the House of Lords. So coming from across the pond, and her colleague Chris Wigley, the CEO of Genomics England. And together they're doing some phenomenal work and really leading the charge in what's cutting edge with sequencing, making that useful, integrating it with the NHS, and I think we'll have a big catalyzing effect for all of us around the planet. So with that, Baroness Nicola Blackwood and Chris Wigley from Genomics England. Woo! Come on out.
You go first.
Yeah.
Hi there. Hope everyone's doing well. As Daniel said, I'm Chris, and this is obviously Nicola. So we're going to start with a very quick Genomics 101. I know we have distinguished genomicists in the audience, but just to make sure that we're all on the same page. So when we talk about the genome, we're talking about our DNA. There's a copy of it in every cell in our body. 3.2 billion base pairs of letters in this wonderful double helix arrangement. And what we're doing is looking at tiny differences, tiny glitches in that DNA to try and understand what's going on with a given patient in a given context, or to try and understand at the level of science or new diagnostic development or new therapeutic development how those changes in the DNA play out in other ways through our body. So to bring that to life with a real story, this is Jessica on the left, who was 4 years old when she crossed paths with Genomics England, suffering from those symptoms that you can see, a series of developmental challenges, and we sequenced Jessica's genome. People talk about, oh, you know, we share 99% of our DNA with a banana, or, you know, all of 99.5% of everyone's DNA is the same, and so on. When there are 3.2 billion letters or base pairs in the genome, even those tiny percentages add up to huge amounts of difference. So 6.5 million variants in Jessica's genome from the sort of reference genome. One of the first questions we ask is, how unusual are those? So, you know, 2/3 of a million were rare. Okay, we're still hunting. Of those, we can look up in all these different knowledge bases and say, okay, just over 2,500 of those are linked to some kind of change in a protein, you know, DNA to RNA to protein. Which ones of those are de novo? So we not only sequence Jessica, but we sequence both of her parents so that we can understand which ones are novel for her. And then one was a gene that was linked in our own knowledge base to link to her specific condition, which is the deletion of the SLC2A1 gene. And in this case, the treatment was both very effective and also non-pharmaceutical, change in her diet, which is fantastic. So when we're talking about DNA, we're talking about using DNA to try and change these kinds of human stories. And in fact, the origin of Genomics England starts with a human story that Nicola is going to tell us.
So Genomics England began with the 100,000 Genomes project, and it actually started with Prime Minister David Cameron right back in the 2012 London Olympics. He brought together scientists and clinicians from around the world and said to them, you know, what is the next big thing that we should be doing? And they told him that now was the time for a transformation in bringing genomics into healthcare. The technology was starting to be there, but also the UK was the right place to be there to do this, because we not only had some of the scientific capabilities, but we also had the NHS, a single integrated healthcare system. And this captured his imagination because he had a personal experience of how devastating living with rare disease could be. His son had a very rare form of epilepsy and sadly died while he was in office. And so he did something visionary, and he committed to the UK sequencing 100,000 rare disease and cancer NHS patients. And this was a phenomenal population health study. It involved 97,000 patients and family members, 13 genomic medicine centres, which were set up across 98 NHS trusts involved in recruiting thousands of NHS staff and researchers, and enormous amounts of data. And this has led to already some extraordinary outcomes from that study. Recruitment finished in December 2019. If you can go on to the next slide, please, there, Chris. And we're still looking at what the outcomes have been, but a landmark study that was published in the New England Journal of Medicine found that 25% of rare disease patients had a diagnosis for the first time. 14% found variants in regions that wouldn't have been found by other diagnostic methods, and that there really is a clinical reason to be using whole genome studies in clinical care. You can go on to the next slide, please. The reason for setting up this 100,000 genome study was not just for research, as impressive as that was. It was to integrate healthcare, integrate genomics into healthcare. And so Chris is now going to talk to you a little bit about how we integrated that, that study into a platform that could deliver for patients.
Sure. And so I've been told before that this slide is a bit hypnotic. So if anyone sort of finds themselves, you know, having strange feelings, then that might be why. As Nicola says, the 100,000 Genomes Project was in effect a massive proof of concept study, where the concept we were trying to prove was, is whole genome sequencing useful in the clinic? And so we continue to try and bring together the worlds of research and the world of healthcare, as this diagram kind of shows. So if we think about the work in healthcare, we start with a patient who maybe has a series of challenges, symptoms like Jessica's, sees a doctor, take some blood, sequence it, generate all the data. We then run that through our bioinformatics pipelines. We run it through genome analysis routines, and we find the results. We publish those back to the NHS. They validate those and pass them back to the doctor, who can then treat the patient in the best way. And that kind of closes the loop on the healthcare side. We're currently doing about 5,000 patients and families a month through that, just to give some sense of scale. And it wasn't long ago, for those who are involved in genomics, that doing 5,000 genomes at all ever was a big deal. That's now kind of the monthly flow through that service. We can then de-identify all of that data and make it available to researchers working on either fundamental science, novel diagnostics, novel therapeutics, and critically, we can pass the insights from those research efforts back into live healthcare, whether that's at the level of an individual or at the level of a new treatment or a new approach. If we think about what that looks like across the whole of the UK ecosystem, we're working with all of these kinds of partners and many more. And I loved the talk earlier about systems thinking, because the way that we're trying to transform lives and healthcare in the UK is very much a systems challenge. It's not something that we at Genomics England can do in ourselves. We have this very close partnership with the NHS and everyone else that you can see on this page. So it really is a team sport. When we look at how this plays out in healthcare now. The NHS has, in some form or another, been doing genetics since its inception a long time ago, looking at sort of chromosomes under microscopes and so on, all the way through to gene panels, SNP tests. We're now doing whole genome sequencing in live clinical care, large panels for cancer and so on. But the bits in green here, we're already sort of piloting, exploring the clinical validity of, and trying to bring into the clinic. So there's this constant flow of science turning into innovation, turning into engineering, turning into kind of clinical care that we try to keep kind of moving forwards. But I think as well as the science, I've put this slide in just to make the point about healthcare transformation is also about really mundane things, like you have 250 large hospitals in the UK, well, just in England. And we're trying to, for instance, create new pathways for cancer treatment where the tissue gets frozen so that we can get a better quality genome out of it. And then you have to try and figure out, okay, where does the freezer go in this hospital that's already full of stuff? And so a lot of the labs that we work with still have things on the door like photocopier room. And actually a lot of it is just really about sort of the shoe leather of changing the way that these healthcare systems operate on the ground at national scale. The way that we're seeding those changes, though, is very much coming from the insights that come to us through our research communities, and Nicola will say a bit more about that now.
So Chris has described there in that infinity loop on the left-hand side that one of our founding missions is to create one of the best data environments for research and to create a sustainable clinical return for our participants through diagnostics and therapeutics, a clinical return for the NHS. Every healthcare system is experiencing huge productivity challenges, and we can reduce the diagnostic odyssey. A rare disease patient has about 67 appointments over 75 months. We can reduce that. We can target cutting down the time to find the right therapeutic for cancer patients, and we want to return for UK PLC more clinical trials, more R&D investment. But we have made first and foremost a commitment to our participants that research will happen in a safe and secure environment, and we've created a research environment on a cloud-based system which happens at a top level. We describe it a little like an aquarium, which is why that icon is there. When you go to an aquarium, it is polite etiquette to look at the fish. You can study the fish. You can make friends with the fish. But it is not polite to reach inside the aquarium, pull out a piranha, and take it home. You will not be invited back. So you can study our data. You can take away the outcomes of your study, but you cannot take our data away. Onto the next slide, please. And so we understand that genomic data is very valuable, but it is only really valuable when joined with other modalities. And so we're working very hard to enrich the quality of our data. And the UK is a really good place to do this with great other national data sets. And in particular, a recent partnership we've formed is with the National Pathology Imaging Cooperative. And they are going to be scanning and digitizing the data from the 100,000 genomes cancer patients. That's about 15,000 patients who have 20 cancers across 84 hospitals. By the end of that, we'll have 250,000 very high definition images. It will be the largest data set of its kind, and joined together with the other work we're doing in transcriptomics, proteomics, and other areas. This is why it is so exciting to be doing research in our data set, and why we have over 600 research projects, over 1,800 researchers from academia and from the commercial environment. And some of the outcomes from this data are extraordinary. On to the next slide, please. For example, we recently had reported at our research summit in the summer from Dr. Jack Bartlett, who's a consultant pediatric hematologist at GOSH, and he was telling us that running a study on clinical impact of whole genome sequencing on his patients, he discovered that in over 80% of cases, it improved the standard of care. In over 24% of patients, it changed the care pathway, and in 14% of patients, it actually changed the diagnostic. You can also see there a picture of baby Oliver. Baby Oliver was born with an over 6 centimeter tumor on his leg, and the standard pathology and molecular tests were inconclusive, and so normally he would be put onto a pathway for chemo and surgery. However, he had a doctor who was familiar with Genomics England. The whole genome sequencing test found that his tumor was benign, and so he was saved that intervention, which is extraordinary. One of the other things that we do is we have strategic partnerships with major farmers, 8 out of 10 farmers, and one of our farmer partners, through that strategic partnership, has found over 9 novel variants associated with the disease which they're studying. One of those has now passed into wet lab discovery for a specific disease indication. The lead investigator in that study has said that this has completely transformed his understanding of the role of genomics and genetics in drug discovery. But what is particularly high quality about the way in which research can be involved in discovery is that we not only have the data and increasing quality, but we also have some of the lead scientists across the global leading scientists who can work with you to drive that discovery forward, and we have some of those on this slide here.
Thanks, Nicola. And so in the terms of NextMed, the stuff we've just been talking about is basically now, right? Now we're doing 5,000 patients a month through whole genome sequencing in rare disease and cancer. Now they're getting diagnosed and improved on standard of care, as Nicola said. Now we have thousands of researchers accessing these data sets, and now we have genomic data linked to clinical data, linked to imaging data, linked to transcriptomic and proteomic data. All of those things are happening today. When we look ahead, we're really focused on how can we use these kind of insights and the infrastructure that we've built to try and capture some of these concepts around predictive health, personalized health, precision health. And one of the ways that we're doing that is with a major newborn sequencing program. Some of you may be familiar with Robert Green's work in Harvard around BabySeq. This is kind of conceptually similar to that, but on a population scale. So we have the funding to sequence 100,000 newborn babies, and to do that really with 3 aims. The first aim is to pick up any of around 250 conditions at birth that are driven by the genetics, that are treatable, and that affect children under 5. So we're not looking at risk of cancer in later life. We're not looking at risk of cardiovascular disease in later life. We're looking at diseases that hit kids and diseases that are treatable. So if a baby is sequenced, they have one of those 250 conditions, they get straight onto the right treatment pathway in the NHS. So that's kind of aim 1, is screening for those conditions. Aim 2 is, if you're a baby that has a genetically driven disease that affects young children, but for which there is no cure, you're not going to get onto those pathways because there's nothing we can do at the moment, but we want to use this as a real accelerator for therapeutic innovation, particularly for platform-based therapeutic development for kind of small n and n of 1 drugs that we can use to effectively add more conditions to that list that can be treated at birth. And the third aim is the one that's kind of visually represented here on the slide, is this concept of the lifelong relationship with the genome. What does it mean for you as a kid who presents in intensive care to have your genome on file? How can that accelerate getting you the right treatment, the right therapeutic at the right time? Into teenage years, what does that mean in terms of mental health, hereditary diabetes, obesity? Into middle age, cancer, cardiovascular disease. Into later years, neurodegenerative disease. So this will be the first cohort of humans born with their genome on file. And so one of the questions we're going to be exploring over the next basically 100 years is, what does that mean, and how can this relationship with the genome help us all to live the sort of healthiest, best lives that we can lead? For me, it's particularly useful, because when our paymasters at Treasury ask me for their KPIs, they say, come and ask me in 100 years and we'll know whether this has succeeded or not. But joking aside, we think that the potential here to really transform lives at scale and to demonstrate the concept that these technologies can really help people over the course of their lives is truly extraordinary. But at the heart of all of that is sort of back to people. Nicola, maybe just a sort of closing thought on how we think about doing that, because tons of risks involved.
So we obviously operate right at the edge of genomic integration into healthcare, but also innovation with the newborn screening program. And the only reason that we have maintained trust, not only from patients and the public, but also from successive prime ministers and treasuries, is because we have integrated deep into the heart of the program that we run our participants, not just through the design of our programs, but actually into the structure of Genomics England. We have what's called a participants panel. It's 25 patients who were involved in the 100,000 genome program, but also now the ongoing programs, which have been a COVID program and also the Genomics Medicine Service. And through that, they hold the board to account for the way in which we run our system. And it is through that that we know that everything that we do is being scrutinized by those who have the most at stake. And that way, we have the greatest advocates at the heart of what we do, and we know that we will deliver for those who need it most.
Thank you very much.
Awesome. So I love how you have patients included. How do you get clinicians included, this whole idea of workflow, to integrate all this into the day-to-day life of a primary care doctor? Any quick example?
Yeah. So very quick example is we have hired a bunch of amazing UX people, user experience people, from places like Google Health and other places. And we've embedded them with the clinical teams that are delivering this care so that we can try and bring these insights as seamlessly as humanly possible into those systems. Back to the examples earlier about fax machines and so on. That's not easy, but it's something that lies at the heart of how we interface with the healthcare system.
We also hire actual clinicians who can talk to other clinicians and demonstrate the value of the program. So when I talked about Dr. Jack Bartlett's study, he can go and advocate and talk about how this has completely transformed the work that he's doing on the ground. And I always think that those who are living the experience are your best advocates.
Absolutely. Well, we'll be back in 100 years for the update. Thank you so much.
Thanks.
All right. So from reading your DNA, we're going to move next to the world of synthetic biology and writing your DNA. And no one better than my friend and compatriot Andrew Hessel, who's the chairman of Genome Project Write, also the author of a great book, The Genesis Machine, Our Quest to Rewrite Life in the Age of Synthetic Biology. Another area that's moving very, very quickly with tremendous implications for the now, near, next of health and biomedicine. Over to Andrew Hessel.
Hi, everyone. How you doing? Great. I just want to say it's so good to be back. It's, big shout out to Daniel and Shauna, because they're just bringing such an amazing energy to this meeting. Anyway, yeah, I know. Thank you. So I'm going to talk to you today building on what you just heard. I absolutely love genomics. This is about rewriting life, but the way to understand me is really I'm just a giant bio nerd. I love this technology. I love what we're going to do with it, and we're still in the earliest days. I was very fortunate through our lockdowns to use my time productively with the futurist Amy Webb to write a book on this technology called The Genesis Machine. I encourage you to check it out, because I know at leaving this meeting you're going to remember 2% of everything you've heard over the next few days. So what is synthetic biology? It really is this intersection of life science, writ large, all biology, with computation and automation. We're starting to see the convergence of these circles. It's been going on for a long time. Another way to look at it is it's biology digitized, and the very sweet spot in the center is synthetic biology. I look at biology through the lens of my previous career in computing, and I started to notice that really the the architectures of the cell and the cell phone really were actually pretty similar. It's components put together into circuits, more complex circuits. Ultimately, you get a computing device. Those computing devices can be networked. It's very similar, except we understand everything about the cell phone. We understand everything about the computing networks. We built it all. Whereas with biology, it evolved. There are no notes, no records, and we've had to reverse engineer it to understand it. It's a much more complicated job. But today, you can actually talk to most people about biology through this lens of computing. The analogy isn't perfect, but these are just time lapses of cells. On the left, bacteria. On the right, the human cells. They're really, you can think of them as 3D printers, multi-material, making thousands of different compounds all at once. And the cool thing is, they're the 3D printers that 3D printers want to grow up to become. They can make more 3D printers. Now, the program that runs all this is the genome. I studied bacteria. The E. coli genome is shown below. That's basically like you squashed it like a bug and looked at it. It's not that much information, only about 4.5 megabits of information, which is pretty much just one photo on your phone. The human genome, as you just heard, 3.2 billion bits, a little more complex, a lot more complex, but it's also tightly packed. It's like twisting an elastic band up and up and up, and you get a really, really dense chromosome. When I first saw the picture of the E. coli genome, though, I saw this because my first computer used this as the memory device. And I realized I got to study this stuff. I got to understand the machinery. I got to understand the code. And that's really shaped most of my career. Here's the short version. Because cells are a universal machine, all the low-level machinery in a cell is conserved from bacteria all the way to you and me. If you can read DNA, you can pretty much understand anything biological. That's cool. And you just heard about some of the amazing progress in doing this for health and disease. We've also been really making fast progress on being able to read this code. You've seen this slide before. It's outpacing Moore's Law. It's kind of flatlined, between $100 and $1,000 over the last little while to read a full human genome. But that's a better genome, fully analyzed, than you could ever get at the beginning. And it's not going to stop. The number of sequences that have been produced over the last 20 years has exploded because as the genome gets cheaper and the technology gets better to actually sequence, the databases just explode. There are trillions and trillions of bases in these databases now, and since inception, GenBank has doubled every 24 months, kind of like a super version of Moore's Law. Of course, this has powered a diagnostic revolution all the way down to the consumer. It's changing the way we look for cancer now because the best microscope for cancer is actually the sequence, and continuing. And of course, you just heard about the 100,000 Genomes Project. And let's face it, eventually we're just going to sequence every person and every organism we can get our hands on because this technology is still advancing so quickly. It's just all this information is flooding into our data banks. We used it to track the COVID virus as it spread around the world, and it mutated, pretty cool, in real time. And we're even using it to dig up cold cases 30, 40 years ago that literally they haven't been able to solve. Now they can run that DNA evidence again, look at the information from you and me and from those home test kits and start to really identify suspects even decades later. And you can crowdsource this now. If you're interested in solving a crime, it's kind of like Kickstarter for cold cases. And of course, we've gone to really cold cases with Svante Pääbo's work in sequencing Neanderthal and ancient genomes. Literally millions of years old, we can start to understand the evolution of humans. It's even coming to your local home association because now this service will go and collect bits of dog poop and identify which dog in your condo association has been pooping on your lawn. Kind of silly. And of course, we're learning how to interpret this information faster and faster using machine learning and other algorithms. DeepMind's work a couple of years ago to analyze every single protein was one of the holy grails of bioinformatics. Absolutely amazing. But what I want to really talk to you about is flipping the coin from reading and analysis now to writing. This is where the rubber hits the road. Because if you can write DNA, you can engineer anything biological. It all works on the same machinery. Over the years, we've seen a number of companies and research groups advance the technology of writing DNA. These are essentially 3D printers for the DNA molecule, available as a service or a standalone unit on a desk. Unfortunately, they're still, their capabilities are relatively limited today, but like computers and anything else digital, they're advancing over time. This makes genetic engineering easier, as easy as typing in some ways. This is powering a number of different applications, starting with short DNA sequences to longer. Everything from protein engineering, which is a few thousand bits of code, to metabolic engineering with companies like Ginkgo that went public 18 or 24 months ago, which is doing metabolic engineering, stringing together multiple pathways, essentially circuits, to something like the Genome Project Right, which is bringing together scientists to think about how do we make these technologies cheaper so we can write the complete genome of organisms and boot them up. What type of applications can you develop with this technology? Pretty much anything that life touches. Medicines, agriculture, foods being a big one these days, energy, biofuels, etc., even components for batteries, new materials. Many cars today have plant-based leather instead of vegan leathers, to the environment, being able to degrade plastics, for example, and heal some of the damage that older technologies, chemical technologies, has really put on the environment over the years. The application space is large and growing very, very quickly. So what's near term? Well, one of the things that I've been watching over time is the cost of sequencing has been dropping, and the value of the information we can get out of that sequence is growing. Here are just a few of the examples. This is basically a positive feedback loop economically, and in the next few years, I fully expect some group is going to figure out how to take this data, amortize it over a few years, and offer genomes for free for people. We're the only creatures that have economics behind our genomes, but I've called this the Google of genomics, and we're building up a head of steam for that pretty quickly. When it comes to writing DNA, we've been kind of flatlined around 10 million bits of code. That's kind of the largest genomes the string of letters we've ever been able to assemble. But once we can break into the megabase range routinely at low cost, or the gigabase range routinely, more and more of biology becomes programmable. Right now, we're also seeing AI tools be used to design proteins. We've reverse engineered their structure, but now they're getting creative. And this is really fascinating, because imagine having an enzyme that, for example, can catalyze carbon into graphene or maybe diamond, something nature didn't do, but we may find valuable. Labs are becoming automated. I like this because now you can program the lab, send your programmed DNA over to it, and really be able to run experiments without having to have the complicated kitchens of a traditional laboratory. And this is really exciting. This has just come out in the last year. This is a company called Roswell Biotechnologies, located not too far from here. In about January of last year, they released what's called the first molecular electronic chip. And this is the actual intersection of carbon and silicon. To this chip, the first chip had 16,000 elements. You can think of them as transistors, to which you can attach a single biomolecule. It could be a nucleic acid, it could be a protein, and now you get real-time sensing of that molecule and how it's engaging. Really exciting technology for sensing. And middle of last year, they also published a paper, part of Craig Venter's 20-year summary of synthetic biology, where they basically gave a sneak preview of a chip that can synthesize and assemble DNA. This is really exciting. It's like an entire lab on chip for writing DNA. And it's not just these low-level molecules. You can actually grow cells on chips. This is a company called Cortical Labs. They started growing neurons on chips. You get real-time sensing of the neurons, and they were able to train it to have it play Pong. In the same way that DeepMind, when it was founded, started training their AI systems to play games, they realized these neurons can actually be trained to play games as well. Pretty cool stuff. They called it dish brain. So we're in this golden age of protein engineering now, which is going to have incredible ramifications for human health and medicine. We're starting to do things like engineer viruses, vectors, and virus-like particles, and that's because these agents are really USB sticks for cells. It's teaching us how to reprogram cells, drop in a new program, for example, to kill a cancer cell or add a new function, replace a gene. Lots of activity in this area right now. I really believe that this is going to be some of the technologies that truly allow us to advance to treat cancer in an individualized way and make real progress on that. In fact, this foundation, the Jamie Leandro Foundation, is the first group that I've come across that has built an end-to-end pipeline to make bespoke cancer vaccines for a patient. And I'm really excited about this pipeline that they've built because I think it'll work for other programmable medicines. And eventually, I'd love to see a computerized model of a cell very similar to Google Earth, because right now we don't have that common foundation for scientists to work on. Where does this go next? I have to be quick because there's not much time. Craig Venter in 2010 booted up the first cellular genome. He copied a genome, put in some watermarks and some quotes. When we can start to synthesize mega-base DNA, it becomes basically child's play to boot up microbes. That's the biggest change in microbiology that we'll see this century. I'm already looking, can you NFT a genome and its derivatives? This could create an entirely new digital bioeconomy. We're starting to see a whole new generation, very young, come into the field. And one thing about biohackers is that they have incredible freedom to operate, self-experiment, and play. And of course, students, the iGEM program has trained almost 100,000 students in this technology over the last 20 years. It's definitely going to require a bigger investment in biosecurity because we know that any system you can program will get hacked. We're also starting to see things like de-extinction, being able to recover old genomes, boot them back up. The dodo was recently announced a couple of weeks ago, and when we get Kentucky Fried Dodo, I'm pretty sure the field of bioengineering will have tons of money. We're going after big ideas like, can we stop aging? Or maybe make us immortal by putting our cells into tubes and keeping them stored for 1,000 years and booting up a twin. And what I really like is the intersection of these technologies with space, because space is going to teach us how to live in very closed systems and help us develop next generation circular systems for sustainability. I really love this stuff. And of course, we're going to turn these technologies on ourselves just like we did with IVF in the 1970s. Here you can see a sperm being injected into an egg. This is conception in IVF. It's porn for cell biology. Where will this go? We don't know yet because there's only been a small amount of engineering done on these embryos, most of it in research. Of course, we know the Chinese scientists booted up a few babies, spent 3 years in jail for doing that. The gene editing meeting just went on in the UK last week, and the consensus is we're just not ready for this yet, and understandably so. But I've got a couple of kids that were made in the lab. This is my daughter Rosalind, my son Darwin, and I can tell you he was the most advanced kid before the Chinese babies. Conceived in a lab, genome was profiled pre-implantation, loves elevators and trains and is doing well. But maybe this is what our bedrooms will look like in the next 20 or 30 years, where you just grow your baby beside at home. My colleague Amy Webb is brilliant at doing this type of forecasting. She just spoke at South by Southwest. This is her timeline. You can get the full report at futuretodayinstitute.com. It's a wonderful overview of bioengineering. And of course, the book will summarize a lot of this too. Don't be afraid of this technology. We're going to be smart and use it properly, but definitely, definitely invest in better biosecurity. Thank you so much.
Thank you, Andrew. Quick question. We have kids about the same age.
Yes.
They like Legos, I'm sure. Are your kids already learning SynBio? And is this going to be the programming future, a language of the future?
Yes, absolutely. In fact, it's one of the easiest programming languages to learn because it's universal. So if you can learn how to program a bacterium, you can start to think about programming something much more complex. Your next pet.
Awesome.
Thank you so much.
All right. Cheers. All right. So we can read DNA, we can see, we're already writing DNA, lots of implications, including the ethical side. If you haven't watched the movie Gattaca, get a reboot on that. And now we're going to sort of pivot to an area that's highly associated, but one that's sometimes underappreciated but accelerating. And really lucky to have Daisy Robinson with us. I met her when she was a PhD student at Harvard. She's made the leap from biotech, from the lab to biotech to address areas with an unmet need, particularly that in women's health. And she's going to share some of the big picture and some of the exciting work she's doing at Oviva Therapeutics. Daisy.
Hello, everybody. It is such an honor and a pleasure to be here sharing the work that we have underway at Oviva. I'm here to talk about new frontiers in women's health. And I'm partly excited to be on this stage because I think we've seen a lot of really exciting technologies coming, a lot of exciting information coming, but one area where I feel like we're only just starting to see innovation is in women's health. And that's in large part because there's been a huge historical disparity in the research that's been done around female physiology. It wasn't until 2016 that the NIH, which is the largest funding body in the world for biomedical research, required the inclusion of female animals in biomedical research. And of course, I think many of us here know that it was the early 90s when female humans were required to be included in clinical trials. And as such, most of the diagnostic pathology that the diagnostics that we have in place, the pathological understanding of diseases, has all been understood on a male baseline, which has really left women behind when it comes to the care that we receive, but also how we think about our health and well-being. It's not just a research problem, it's also a funding problem, which I'm not really going to talk a whole lot about, but I think it's, we know that research and science and innovation goes hand in hand with the funding that it receives. And I'm really thrilled. One of the reasons I left academia and went into biotech is because there's more money here right now to elevate this work and to do this work. And I'm excited to tell you how we're doing that now. So I'm particularly interested in the ovaries. When we think about men versus women, they're one of the key organs that differentiate between us. And what's interesting about them is they actually age at about 2.5 times the rate of the rest of the body. What you can see in this graph is the functional output of different organs in the body, and you can see female fertility, which is one of the main functions of the ovary, really declines at what is now midlife, whereas the rest of the organs continue and more gradually decline later in life. And this puts women at a distinct disadvantage, not only because their ovaries decline and they decline in fertility, but there's a whole system that's supported by your ovaries. Every aspect of your health and well-being is intimately linked with our ovarian health. And that's one thing that I want to leave you with today, is the importance of ovarian health for our overall health and well-being. Now, assuming most of you aren't reproductive endocrinologists or experts in ovarian biology, I'll give you a brief primer just so you can understand the lay of the land, what we're talking about here. That egg-shaped organ on the left-hand side, that's the ovary. And directly adjacent to it is a schematic of what's called the ovarian reserve, or the number of eggs that a woman has at any given point in her body. That's comprised of structures called the follicle, which are depicted in orange, and inside every follicle is a single egg. And once a woman hits her reproductive years, she loses about 1,000 of these every month. They enter that maturation cycle you see on the screen, ultimately leading to one dominant ovulatory follicle that releases an egg that may or may not get fertilized. So 1,000 eggs per month are getting lost, while one may or may not get fertilized. And this is a huge degree of attrition that just happens with regularity throughout our lives. So interestingly, when we look at this graphically of how many eggs a woman has at any given point in time, this peaks in utero at 20 weeks gestation for a female fetus before declining to 1 million at birth and reaching 300,000 by the time we actually hit puberty. And what I'm particularly interested in is that graph, the line between puberty and menopause, because we know we have that steady decline of 1,000 eggs per month, but if we intervene on that and flatten that curve, we can actually fundamentally change the way that the ovaries decline and that women age. So with that, I took that idea and started Oviva Therapeutics. It was really this idea that came out of the fact that as a scientist in the field of aging, I never heard anybody talk about ovaries, and yet they're significantly and intimately linked with our health and well-being. We started Oviva with this idea that we wanted to address the unmet need in women's health, but really focus on this hypothesis that that decline in ovarian reserve is a core driver of the decline in ovarian function. And if we can intervene there, we can improve health span in women. And this is interesting and important because we know that the hormonal changes that occur with ovarian decline accelerate aging in the rest of a woman's body by roughly 6%. Those are data from Steve Horvath's lab at UCLA. And of course, we also have a lot of data around the different incidences of disease with this change that happen for women at midlife and very dramatically. There's significant increased risks of cardiovascular health, declines in neurocognitive health, problems with sleep, immune dysfunction, sexual dysfunction. Obviously, osteoporosis becomes an issue. And all of these things happen in a very dramatic, short period of time that really disrupt not only quality of life, but longevity as well. We know women who go through menopause later tend to live longer. Also, women who go through menopause earlier tend to have shorter lifespans. And when you take young ovaries and put them into older animals, this actually extends their lifespan between 6 and 11%. So there's something there with the youth and function of the ovaries and the overall health, well-being, and longevity of the animal that those ovaries are in. Some of you may have seen this paper that came out last month. I just thought I'd throw it in here because I think naked mole rats are really cool. They're one of the main animals studied for longevity because they have exceptionally long longevity. And it was found that they also have what's called eternal fertility. So they have a lot of their oogenesis postnatally, so after they've already been born. And there's lots to be learned from organisms like this that we can then use to inform innovation and engineering to make our lives better, to improve our health span, and perhaps also to improve our longevity. So the way that we aim to do this is using a naturally occurring hormone called the anti-Müllerian hormone. I'm showing on screen a schematic of the different reproductive hormones that are at play when we think about folliculogenesis and reproductive endocrine system. AMH, you see on the left-hand side, is produced by the early maturing follicles. And there's been no therapeutic development to date around this because it's an incredibly complex molecule that I won't get into detail about, but I'd be happy to chat about at the break with anybody. There have been many pharmaceutical companies that have tried because it's really interesting. It's the first intervention you can make on the ovarian reserve. It regulates how often and how many eggs are activating out of that ovarian reserve to enter that maturation pathway. So you think about FSH and LH and the other reproductive hormones and estrogen and progesterone and things that we use commonly in birth control pills and fertility medication. There's been a lot of development there, but we really haven't touched AMH. And this is that earliest intervention point that if we could do something there, not only could we have innovative contraceptives, but we could potentially regulate the pace at which we deplete our ovarian reserve. Now, what we're doing at Oviva is using this in a proof of concept trial to assist women who are poor responders to in vitro fertilization. That might feel a little bit counterintuitive because ultimately we want to slow the release of eggs. But what happens is when you treat with this recombinant version of AMH, you actually pause the ovarian reserve and synchronize the follicles that are ready to then activate out and mature. So that when you do the standard stimulation protocol via IVF, you have a greater than usual cohort of follicles and eggs that are able to be matured, stimulated, and ultimately harvested. Now, preclinically, we have a lot of evidence around how successful this can be using a pre-treatment or a neoadjuvant treatment to IVF in rodents. In this particular experiment, which is published, the paper citation is there, and again, I'd be happy to send around after. You get 3.4x improvement in the number of eggs harvested from rodents undergoing an IVF cycle. Now, this is much more interesting for women who have diminished ovarian reserve or premature ovarian insufficiency or have some sort of issue with their fertility. And in trying to recapitulate that, we used rodent models of that as well, and we found that you could actually double the number of ovulated eggs that you can capture with this method, importantly with no negative impact on viability. And actually, there are independent groups that have replicated this result, showing that there is an increase in quality in their hands, which we wouldn't put on our label, but I think it's important to think about when we're doing anything with reproductive health, how is that actually impacting the eggs themselves. So we're at neutral or positive, which I think is really exciting. And I think of this really as a part of the path on the stepping stone to what's coming. When you're doing anything with ovarian function, it's intimately linked not only to fertility, but also to menopause. I wouldn't claim that we're a fertility company any more than I would claim we're a menopause company. We're really looking to extend the function of the ovary to support the health span of women and give them agency later in their life, much like we got agency when we had the birth control pill. We get to choose when and how we have children, for the most part. And those rights are at risk now, and I think what we're looking to develop is another toolkit or armatorium that allows us to have agency over that phase of our life when we, instead of inevitably going into menopause, might be able to choose when or how we do so. And in having this vision, right now we're at the early phase of this, which is validating. There's so much data that we don't know. There's so much basic biology that we don't know. And it's really difficult to learn a lot of this information because rodents, of course, are not humans. They have a 5 to 7 day estrus cycle, whereas women have a 28 to 35 day cycle. So a lot of this is validation in primates and organisms that more closely mirror human biology. And then, of course, going into women with this proof of concept to show that we actually can modulate the ovarian reserve in the way that we think we do, and that it's safe and it's effective. And then building upon that, going into more chronic indications where we can show over time that not only is this mechanism consistent and conserved, which is what we believe to be true, but that it's also safe. And ultimately, at the end of this road, again, giving women a choice as they go through their lives of when and how to have that physiologic change happen, or at least make it more gradual, instead of it being an inevitability that we all just have to face at some time and we don't really know when, and there's about a 10-year period of strange nonlinear symptoms that really change things, and doctors aren't even well trained to deal with that. So ultimately, what we're trying to do is learn more, raise awareness about it so people can understand their physiology better, uncover some of these unanswered questions, again, so we can understand our physiology better, train doctors better so they know how to interface with patients, but ultimately give women choice at a time when I think our choices have been more at risk than they've been any time in the last few decades. So with that, you can learn more on our website, and I'd love to talk more about it. My email's on there, and I'll be around for the next couple days. So thank you so much for listening, and enjoy the rest of the sessions.
Thanks, Daisy. Amazing work. So if you're going to go to look at the next, women's health is sort of bubbling up now as a field.
Yes.
I don't remember having much in the way of education aside from an OB-GYN rotation in medical school. So where do you see what's needed from this community to help catalyze this going forward?
Yeah, I think you bring up a good point, which I think education is such a huge piece of it. I'm sure everyone in this room, you vaguely remember sex ed or health or learning about puberty in grade school, but there's no other touch point in our lives where we learn about fertility or where we learn about menopause. So I think just the education and awareness is a huge, huge piece of it. But I think, as you said, this is a topic that's bubbling up. There's a lot of funding coming in. There's a lot of innovation. There's some other really cool companies that are starting to crop up in this space, both digital health and cell biology. Gamito is another very cool one that's doing reprogramming to recapitulate ovarian physiology, I think, from like an implant perspective. So what I imagine in the next 10 plus years is that we're going to learn a lot more just about our basic health so that women have the tools, and also from the precision medicine standpoint, we have the biomarkers to better understand what's happening in our bodies, because reproductive health for women is one of the most robust multivariate signatures of our health and well-being. When your cycle is off, there's a lot more going off in your body. So I think it's going to be data and information and education and awareness.
Great. Watch the space. Thanks, Daisy. So we're trying to connect the dots between all these different fields, and I think one of my friends and colleagues who's really connecting the dots is Maria Filipova, who leads an amazing organization as the Chief Innovation Officer for CareQuest International, one of our NextMed partners. We're very grateful for having in the mix, who's going to talk to us about how she's connecting the dots in this emerging field of systemic health. A longtime friend, colleague, and NextMed faculty. Maria.
Thank you.
Hi, everyone, and thank you, Daniel. It's great to be back amongst NextMed friends. I love coming back to the NextMed community. This is a special place for me. Since my first talk here about 5 years ago, when I came into this community with an immense sense of appreciation and gratitude. I had just gone through my own personal patient experience where I was dealing with a 6-pound kidney tumor, which I fondly named Bertha. I look around the room and I see a lot of familiar, friendly faces who were with me in that part of my life, who helped me stay positive and stay curious and find solutions where others were seeing obstacles. And here I am today, still connecting dots and looking for solutions across silos and across disciplines, with the same appreciation and fueled by the same patient experience to bring your attention to another silo, often overlooked yet so critically important for both patient outcomes, healthy communities, and the bottom line. Show of hands, how many of you think about their dentist when I ask you to think about your healthcare team? The dentists in the audience should not raise their hand right now. But not many, and neither did I up until a year ago. And that's where I really realized that oral health is, in fact, overall health. That's right. The oral health is not contained to that one visit in the dentist office. It permeates every aspect of our overall health in our lives. Literature shows, and the data shows, that oral health is connected to our brain health, to our bone health, lung health, heart health. The data is clear. 1 in 4 Americans die every year from cardiovascular disease like hypertension, stroke. We also know that periodontal disease, or gum disease, is the 6th most prevalent non-communicable disease in the world. Severe periodontal disease is connected to higher risk of cardiovascular disease, developing high blood pressure, and making your arteries thicker and narrower, which leads to all kinds of cardiovascular complications. Untreated oral health issues or poor oral hygiene coupled with severe periodontal disease are leading to higher risk of developing dementia and cognitive decline. We see also in literature that 30% of adults in the US over the age of 65 have lost all of their teeth due to various healthcare issues. You can only imagine what that does for that patient's ability to communicate, ability to get the right nutrients they need, ability to be a productive and meaningful member in their community. We know that a higher prevalence of tooth decay and periodontal disease could lead to higher risk of developing chronic obstructive pulmonary disease. And a recent study in Israel saw that with over 500 patients who were positive for COVID, those who also had untreated periodontal disease were 3.5 times more likely to need intensive care units and 4.5 times more likely to need a ventilator. The data goes on and on. We know preterm labor increases with untreated cavities and periodontal disease. We also know that oral health is connected to patients' likelihood to develop diabetes. Oral health is overall health. Treating oral health issues, however, is not only the right thing to do clinically, but it makes sense economically as well. Oral health, untreated oral health issues have been connected to loss of millions of dollars in productivity, lost hours in the school. 1/3 of every child loses a day in school due to oral pain. And more importantly, what we see here is that over $500 million in Medicare spending is connected to visits to the emergency room that are connected to dental health issues. And for the clinicians in the audience, you know that when you have a patient that presents to the ED with a dental pain or dental issue, there are two things you could likely do for them. Give them painkillers or antibiotics. Neither of those two treats the underlying issue. Oral health is also a health equity issue. We know that Black adults are more likely to have an unmet dental need, yet they're less likely to have a routine dental visit in the last year. We know that patients from the Latino community are more likely to report having difficulty doing their job because of poor oral health. That number skyrockets when we talk about people living in poverty. Untreating oral health or delivering oral health care, like most of the other parts of our healthcare system, is expensive. The cost of dental care outpaces the growth in medical care costs, and by 2025, it's projected to reach $185 billion. Let that sink in for a moment. 4% of total medical spending. And yet, when we think about investment in innovation, measured by venture capital spending or venture capital investment in oral health companies, that is merely 1 to 1.5%. We did the math. In 2020, less than $1 billion of VC funding went into oral health companies. 2021, it was a bit over $1 billion. Again, what we're seeing is that dramatic need for innovation, creativity, and problem solving, yet we're really falling short in, at least by this parameter, to encourage that. So with that level of funding or underfunding of innovation, there's no surprise that the last large-scale innovation that had a truly transformative impact on patients and communities was 77 years ago. In 1945, when fluoride was invented and added to the drinking water in Michigan. Did not require AR, VR, AI, or quantum computing. It really required a lot of stakeholders to come together and make it possible to act on the clinical knowledge that for the states where there were higher prevalence of fluoride in the drinking water, there was lower prevalence in tooth decay. And what we have seen since then in the last couple of decades is that over 60% of American households have access to fluorinated water, and over 30 to 40% in Canada. Not much has changed since then. And I'll give you my favorite example on that. Toothbrushes. The first toothbrush came up in the 1400s in China when they took boar hairs and slapped them on a handle. In the 1800s in the UK, an entrepreneur, William Edis, came up with a commercial toothbrush. We improved on it in the US in a couple of years after to get us to this prototype of an electric toothbrush. No toothbrush that old should look as similar to what we're using today. And when you look at the patient experience, no patient experience decades old should still inflict anxiety and pain and confusion as it did back then. Not only has our patient experience not changed dramatically, but the overall outcomes have not changed that much either. The total prevalence of tooth decay, severe periodontal disease, or loss of natural teeth globally has not changed since the 90s, hovering around 40%. So something needs to change. And we all need to be part of it. privileged to lead a team of change agents and inspired dot connectors as part of my role at CareQuest Innovation Partners, where we have curated a set of capabilities that allow us to think about the barriers to adoption of innovation, investment, and outcomes, and put together those resources and make them available to the innovators and solutions out there. Some of those capabilities include things like providing capital for early-stage companies who are looking to connect medical to dental care. Companies like Mouthwatch, the first virtual oral healthcare network that provides access to dentists across all 50 states. So that mother of two who lives in a dental desert and can't get to the dental office still has access to a virtual consult. Companies like Enable Dental, who provide portable at-home dental care for patients who are homebound. Companies like Incisive Technologies, who actually, if you go back, you'll see the Incisive Technologies company and what they do, because it's really disruptive. They have figured out a way to take diagnosing tooth decay outside of the dental office and put the equivalent of a blue rinse in your mouth. And when the blue rinse changes color, that is able to diagnose caries. For those companies who are a little bit more grown up and have a solution that is ready to go to market, like this company here, Vivardis, who have created a novel peptide that when it's applied to the tooth, it rebuilds, regenerates enamel. The talk about tissue regeneration is not a thing of the future when we look at oral health. Companies like Vivardis have been able to accomplish this. And what we've been able to do for them is create clinical proof points and business proof points by connecting them to health plans and dental plans and running longitudinal studies that observe the outcomes on the clinical side, but also the business side from applying those types of minimally invasive procedures. So next time you're at your dentist and your dentist observes a small black dot on your tooth, that first and second surface lesion, instead of them filling it and drilling it and giving you a filling, they might give you that Curodont paste that allows your tooth to rebuild and minimizes the need for fillings. We also do accelerator programs that allows companies that are not in oral health to come into the oral health space and innovate. There is no lack of shortage of ideas, and the problems that we see in the oral health are very similar to problems the best and brightest minds are solving in other industries. Last year, we ran the first of its kind integrated care accelerator program, founder-friendly, where no startup had to give up equity to be part of the program. SMILE is an abbreviation and an acronym for simple, minimally invasive, integrated, low barrier to access, and equitable solutions. SMILE solutions exist across multiple disciplines and fields. It's our role to put them in front of the clinicians and the patients and validate them so they can scale. I want to bring your attention to 3 of them who you could actually meet here at the iLab. OrisDx takes saliva-based diagnostics and makes it reality today. With their saliva-based solution, they could take a saliva sample, your dentist could take a saliva sample and screen for oral cancers early. And we know that the odds of overcoming that cancer and having a higher quality of life are much higher when you diagnose early. Waiver is a technology and a platform company that completely reimagines your experience by going to the dentist. They put in high-quality custom and licensed content delivered through augmented reality. Some of those glasses that we saw cutting-edge surgeons are using for surgeries and training, Waiver is putting in the dentist office so that patients with phobia and anxiety could make it to the dental office and participate. So next time, when you think about the dentist office, you start thinking about the new release of the video or the movie that you get to watch while you're in the dental chair. Sleep Architects is a platform that connects medical and dental teams so that the patient could get diagnosed and treated with the appropriate treatment plan in a coordinated and an integrated way. So I invite you to go in and say hi. I want to focus on a couple of things that we've seen in the last months, really, that show tremendous potential and acceleration of capital interest and innovation in the field. There are three trends that I want to bring your awareness to. Number one, medical dental integration is a reality, and it's urgently needed if we're going to combat the rising cost of care while still delivering quality of care to patients. What we're seeing is some of the largest companies, like in the dental space, like Pacific Dental, who are in over half the states in the US, are now adopting Epic as their EHR. We're seeing collaboration between NIH and different data exchange organizations to adopt similar standards so that data interoperability becomes a fact. Second trend that we're seeing is higher valuations and more activity in the startup ecosystem. Quip was the first company that recently raised funding with a $1 billion valuation, and they, again, are positioning themselves as a platform for wellness and integrated care. There's so much innovation in that space. And finally, I want to make sure that we are looking out for the opportunities to find the next level of breakthroughs that would connect care, the dentist, to your overall care team. And it doesn't have to be in the dental chair. It could be in a community clinic. It could be at your home or virtually. Regulators are at the table and paying attention to those trends. The company that I mentioned, Vivardis, with the enamel regenerating product, they weren't able to get reimbursement or to get in front of the dentist because there was no code that would reflect what the technology in this product could do. As of this past Thursday, we were able to work with the American Dental Association and a multitude of other organizations to pass a new CDT code that allows clinicians, dentists, to bill when applying that product, and insurance companies to decide whether or not they want to reimburse it. Last month, we worked with the American Medical Association to make it possible for primary care physicians to apply a silver diamond fluoride, which is a treatment especially used in kids to prevent cavities or arrest the development of tooth decay. Regulators are paying attention, and what we need is more of that collaboration across industry, regulators, investors. So I'm very happy to announce that our cohort of the second-year cohort of 2023, Smile Health Accelerator, actually is accepting applications starting today. I'm very excited to see the solutions and the innovations in this room, and I invite you to, if you're working on a startup or a solution that makes care more integrated, equitable, and accessible, I invite you to apply. And if you have heard this talk and you have questions and you can't wait to get in there, I really invite you to our Systemic Health Breakout tomorrow afternoon. With that, thank you.
Amazing work. I'm going to turn on the app with my toothbrush now and actually use the quantified brushing. Now that we can now connect some of the dots, what can start to happen in the dental office where people visit more often than their primary care office, not just checking blood pressure, but maybe other convergences? What might you see for that future?
I'm very excited about the potential of what the dental team could do for our overall health. If you think about it, on average, a visit with a primary care physician lasts about 15 minutes. A hygienist has on average half an hour to 45 minutes with that patient. What we want to do is the dentist to start engaging you in a conversation about your diabetes, about your sleep health, about your risks of overall health, and you want your primary care physician to be talking to you about your oral health. So that's the integrated view, and I believe we have all the resources to make it happen.
I had my oral microbiome tested, and it inspired me to go get a tooth cleaning. So
that's right.
Awesome.
There you go.
All right, thanks, Maria.
Thank you.
All right. Okay, we're at the session 4. We're switching gears a little bit, and now it's a bit more about not just understanding the technologies, but how do we get from now near to next, transforming technology, patient voice, empathy, impact, and beyond. And I'm so pleased to have back one of my favorite friends and co-conspirators, Lucien Englund, who was responsible for a lot of the changes in my life. I spoke at his TEDx last week back in 2011, ended up as a TED Talk. It changed my life in many ways. He's for many years brought a whole Dutch wave here. Who are the Dutchies here today? Woo! I think we have a whole crew from the Netherlands, and that's thanks to Lucien and team. Just really excited and grateful to have Lucien sharing what's new and next. He's the CEO and the Chief Inpatient Officer for Transform Health, coming from the Netherlands, Lucien Englund. There he is.
Thank you very much. How are we doing? Everything okay? Has ChatGPT mentioned already this time? A bit? Well, I think it should. So, first of all, thank you for being here. And help me in being a bit puzzled today about the things that happened with AV, to get my slides up first. It's always great to see that happening. Because the thing that I want to share with you, that I'm kind of puzzled with all the great stuff that we see happening. I was at the second FutureMed at NASA Ames at first already, and it's part of my oxygen. It always has been, and it always will be. Ever since that moment, we've seen all the developments and everything else that's going on. But my question would be, is it enough? Are we fixing the right problem? And I actually think we are not. We're facing the problem at the rear end, and we're fixing it over there where we should do it at the front end of it. And that has been also my mission for many years. In ambulance services at first, and then I transitioned to Radboud University Medical Center, now helping Deloitte, Vodafone, and Laurentius Medical Center to make a soft landing into the future. And I actually think that we have a plumber's problem. We try to fix things with kettles and umbrellas, while the actual thing that we should do, what would you do if you see something like this? Not fixing the hole, you try to reach out to the main tap. So why is it, when we look at healthcare, and we know what the drivers of health are, like been discussed already, your DNA code for 20% makes the driver of your health. The postcode in the Netherlands, a well-developed country, I think, there are some places that matter for 9 years of life expectancy under the average of the average Dutch citizen. Then we got your behavior and all things combined. So why is it that if only 6% of your health is being determined by healthcare interventions, that we still pour in 90% of our budget in that bucket? Because that's the reality. Ever since 2017, I've been using this slide to kind of predict, or to warn actually, that in 2035, we will have a doubling in healthcare demand, shortage of skilled personnel, burnout rates going through the roof, and patients knowing what they want. Healthcare system will implode. And that exactly is what happened during the peak of our pandemic. Code black. We had to make harsh choices. This was in a temporary fashion. If we don't do anything today, that will be a permanent phase in a couple of years from now. Because healthcare is facing this, what we like to call this perfect storm. From all kinds of sides. We're coming out of this pandemic right now with big choices to make, and it already was a system under pressure. Organizational under pressure, financial under pressure, emotional under pressure. We see what's happening with this crocodile mouth. Doubling in healthcare demand, declining numbers of people getting into healthcare, and like I said, by 2035, this will be the problem. So my assertion is that we need to carve out up to 30% of the current healthcare out of the healthcare system. So this is not budget-wise. This is taking a different approach, bringing healthcare to other places, and to look outside what's happening outside, and making sure that we learn from that. Because that's the thing that we look outside, like payments. We all do this by plastic or your phone, and very soon with your eyes. If we order stuff, we do it online, and groceries are bringing this up to your own fridge for $9 extra every month. And if we need to travel, we use technology. We use digital boarding cards. And maybe in due time, my wife and I will become grandparents, and I will talk to my grandchildren, brag about we had this little booklet that we needed for travel. And in the US, in a couple of places already, your driver's license and very soon also your passport is in the app. We're living a digital society already. So we need to make a choice right now, right here. Are we going to add digital to the things that we do? Or do we flip it around? Making everything on a digital platform at first, unless science proves us wrong, unless you as a professional say, this is not what we want, unless patients say, this is not what I want. And that's the interesting thing, because many in healthcare still think it's like building an app. Well, it's not. It's about user interface, how things work, how we explain stuff. And in the Netherlands, our own Ministry of Health has this new mantra, where they say, it's about yourself. You need to do it yourself, if possible. You need to do it at home, if possible. And you need to do it digital, if possible. And the interesting thing about technology is that in the old days, the physician would go to your home and all the technology would fit in his doctor's bag. And then we started to build huge places to fit all the technology. Meanwhile, all the technology is shrinking. All the stuff that we had at our desk now all of a sudden is in your phone, very soon in your glasses, and after that in your lenses. And if we trust Elon Musk, it's like in the back end of your head with Neuralink. That's the reality that we see. And this one's too good to share. Like a robot chasing a sperm cell, finding the egg. This is what we're able to do already. So why is it that we're not using these kind of things already in healthcare on the other side than fixing stuff? We're living this fourth industrial revolution. We all know that. We've been living that. We talk about Moore's Law. By the way, Moore's Law is kept alive in the Netherlands. ASML is a Dutch company treating Moore's Law and keeping Moore's Law alive. And one of the inventors of ChatGPT says the new version of Moore's Law is the doubling of intelligence in the universe. That's interesting. With technology, and I was proud to, from my friend Dave, to have the very first strip at the back end of my phone in Europe, start using that, and we see how that evolved very soon also and became mainstream. Interesting enough, we see these developments on a monthly basis already. And for instance, a company like Philips is now creating an ultrasound knob connecting to your smartphone, offering GPs the opportunity to do things in their own practice. Using digital humans like this one, I brought the technology from New Zealand and Australia to the Netherlands, where you could choose which kind of digital human, male, female, gender neutral, speaks 14 languages, ethnicity. We've implemented that as the world's first digital pharmacist in St. Martin's Clinic in the Netherlands. My friends are here already as well, by the way. Or what to think about these kind of technology fitting in your toilet, having this urine lab already present. So what do you think this technology is? Anybody has any clue? This is the world's first autonomously blood-drawing robot created in the Netherlands. Been tested in a couple of hospitals already. And the aim is to put it in retail clinics. And one last piece of technology, the first reusable tampons that not only measures volume, but also all kinds of biomarkers is also available already. So what this brings is a continuously stream of data that gives us also the opportunity to come more in the front end of it, like the early diagnostics, early warning, fixing stuff before it happens. And Daniel asked me how I'm doing, and well, I slept well. Not only today, but also the rest of the week and the rest of the month. And if you are interested in my pulse temperature, I can share that with you as well, or my gait, my EKG, of course, as well. Why is this important? This is a phone company out of Silicon Valley. And all of a sudden, this technology is now coming into this, what I like to call, consumer market. While at the other end, we now see clinical proven devices like this, the first clinical proven watch full scale, becoming available. So this is closing the gap between consumer and clinical in the end. And also augmented reality. My friend Raphael talked about this. You're able now to watch your soccer game on your smartphone while the match is being played on the grass. I don't get it, by the way. It's the same like at concerts, everybody's gazing at a screen while the musicians are on stage. But again, this gives me also the opportunity of thinking about what we've seen in Star Trek back in the days. And if you fiddle around with AI, you can see how this in the end plays out. To me, this clearly signals a difference in the era that we're running into. From using old data, including from scientific literature, now using recent data and coming up real-time data. And with it, the aspect of the data changes from static to predictalytics, right now, to prescriptalytics in the end. And like I said, I'm coming from the ambulance services in the early days, and I will meet the day that an ambulance will knock on my door at my home, and I would open up. I would see two former colleagues and say, hey guys, what's up? And one of those would say, well, we're fine. We're here for the cardiac arrest. And I would say, there's no cardiac arrest here. And one of them would say, Lucian, take a seat. In 2.3 minutes, it's going to happen. That's the thing that we're aiming for right now. So we will be present at the moment in time when somebody becomes sick and gets sick, as opposed to fixing things at the end. So we now see that the system is not sustainable anymore. We cannot cope with it. New technology is coming up, and the consumer is awakening. The consumer is also your patient. And why this matters is this. Anybody idea on clue what this is? No, it's not a wrongly figured Japanese flag. It's the only 1 hour that a patient with Parkinson's disease, our great friend Sauriga from Sweden, visits her neurologist. And the other 8,765 hours, she's on her own. And the thing she does is she goes into the supermarket and she goes to the drugstore and all that. So why are we not using massively those touch points already for the patients to be utilized in healthcare to be earlier in the process? And that's why we've created a program which I called Healthcare Meets Retail. Together with a great bunch of companies in the Netherlands, already 35 partners, we're now trying to create this, what we like to call this Copernican moment. Copernicus proved in the mid-1500s that the sun was not circling the earth, but it's the other way around. Still, the patient needs to circle the professional. And with all the technology, we have the opportunity to do it also in the other way around. Like we are doing that in our hospital in Roermond with the self-measurement kiosk, where the patient would jump on, we'll take his blood pressure, his oxygenation, his weight, and now still in the hospital, but very soon hopefully also in drugstores. Why not? In the Netherlands already the GP does not refer in many places directly anymore to the medical specialist, but the optometrician is doing that job. Those are the things that are changing, and maybe in due time you'll see this kind of technology in these retail places to run from that. So where this brings us, I think, is that with real-time data at one end, my personal nutrition plans, for instance, and the drivers of health will bring to me a different cash receipt with all the things that are beneficial for me being lowered in price, and the things that are bad for me will be this uptake for that. Sure enough, Daniel and I will run groceries for each other to kind of cope with that, as you can imagine, but still. And the thing is that due to the fact that we're always online already, and the pace is picking up, where airline industries took 70 years to reach 100 million people, Facebook done that in 4 years, and Instagram in 2 months. We also see how this has impacted our everyday life and in society. We've seen this happening in travel and media and music, and now healthcare is next. And I've learned early on from our business family that if somebody is talking about me at a table and I'm not sitting at that table, I'm on the menu. Healthcare's on the menu. This is a graph from my latest book, assembled with investments over $100 million from non-traditional healthcare players in healthcare. So this is happening, and some of you already have seen this, like Amazon now offering for $5 a month a subscription for the 40 most used generic drugs, all you can eat. I think this is worrisome. What to think about an analyst that says Apple is going to launch its own healthcare insurance program by 2024? Or TikTok buying 13 Chinese hospitals already. This is the reality. So let me wrap up with a question. What kind of company do you think, for 150 euros, which is roughly the same as $1 right now, would run a full health body scan based on 50 million health data points? What kind of company would that be, Zena?
Spotify.
Spotify, thank you very much, my friend. Sister from another mother. So that's the reality. The founder of Spotify has created this company, and when they've opened up in Stockholm, in 2 hours they have 5,000 admissions of clients coming in for that. So we're living in an interesting time. If this picture says something to you, it says something about your day and age, as of mine, by the way. But so the other interesting thing that's happening in Europe is the European health data space. And my friend and colleague, Herke Komers from the Ministry of Health, will talk about that, I think, Wednesday, where we have the opportunity and also mandatory that every citizen will have his own data. So this is going to happen right now, not only empowering the individuals, but also creating better diagnostics, better treatment, those kind of things. And in the end, also the standardization into it. So with that, I think also the patients included aspect is gaining momentum, where we also can use all that technology, because we often talk about that patient journey. But the reality is the majority of the patient journeys are journeys of a patient in an institution. Because there's also the journey of life, of course, in the end. So let's start innovating together with patients. The next era will be patients innovating themselves. And that will bring a whole new array of possibilities. Healthcare will become delocalized. It will be democratized. It will be digital. And in the end of the day, it also will be about big dollars, big companies. So help me closing that tap and going and reaching out to the front end of the problem, as opposed to fixing stuff at the rear end of that. With that, I would like to leave you also with some information if that's needed. And I would greatly like to introduce also one member of our Dutch WAVE group, Joyce de Ruiter. She is a great authority on the agility and resilience in these times of change. I won't spoil too much of it, but she will share a lot of the psychology of change and also her own personal insights. Please join me in welcoming Joyce. Joyce. Here you are.
What if you had to choose between becoming deaf or becoming blind? What would you choose? May I see the hands of the ones who think, I choose to become deaf? So you won't be able to hear your child's first words, not to participate in conversations, not to enjoy music, and not even to take in the silence of nature. Or do you say, no, that's too big a loss for me, I cannot miss that. In that case, I choose not to see anything anymore. You will miss your child's first steps. Won't see any reaction on people's faces. Will never drive a car or ride a bike. What a devilish dilemma, isn't it? But what if you cannot choose? What if you don't have a choice? What if you're going deaf and blind? At the age of 16, I was already confronted with that fact. When I was told, Joyce, you have Usher syndrome, which means that around the age of 40, you will be almost totally deaf and blind. I'm 38 years old now. That morning, my biggest question in life had been whether I was going to spend my clothing money on those tight jeans or that shiny dress. As a teenager, I was confronted far too early with an insight far too big. The insight that a normal existence of studying, climbing the career ladder, finding the love of your life, and witnessing your children grow up is actually not self-evident. It was the year 2000. The internet was still in its hit or miss phase, so there was little information. There were no role models I could lean on. And above all, there was no treatment. The Usher syndrome is a rare progressive disease. There are about 400,000 patients worldwide. And it is a combination of the eye disease, retinitis pigmentosa, from now on I call it RP, and hearing loss. There are about many types of Usher syndrome because of the many genetic mutations. I have the most common type, type 2A, which means that I was born hard of hearing. And I've been wearing hearing aids in both my ears my whole life. But even then, probably compared to you, I hear about 1/3 less. And the forecast is that in a few years from now, I will lose another 30%. Imagine how difficult it will be for me just to have a conversation. And that process of deterioration will continue until I can't hear anything anymore. But I'm also losing my sight. Since puberty, I suffer from night blindness to an incredible degree, and I'm also losing my sight in daylight. Today, when all light conditions are optimal, which is definitely not the case in here, I am looking to a tunnel of no more than 18 degrees. Compare it to looking to a round object as small as a toilet paper roll. Just put your hands in front of your eyes in the shape of a tube and look around you. You experience that you have to scan your surroundings, right? Well, the prognosis is that in a few years from now, it will be as if I look to an object as narrow as a straw. Just narrow down that tube of your hands to about straw size. Do you dare to cross the street now? Would you feel safe with just that white cane in your hand? And that process of that shrinking tube will continue until I can't see anything anymore. Today, 22 years after I got my diagnosis, there's still no treatment available. Because it's a rare disease, not much money is spent on scientific research, even though in the long run, it would save a lot of money if we do invest more in the cure. In 2012, a research conducted by Dr. Frick and his colleagues of the Johns Hopkins Bloomberg School for Public Health led to the conclusion that patients with RP consume substantially greater amount of health services than others with significant care costs, on average $7,317 more per patient per year. And that treatments that slow or halt or possibly restore RP-related vision loss may prove cost-effective for funders and for society. And that's only the eye disease part of Usher syndrome, not the hearing part. So if we know that the costs for care are so high, why are there so few investments in the cure? So I am very proud and honored to be the ambassador of the Usher Syndrome Foundation in the Netherlands. A group of patients has started a foundation to create more awareness and to raise donations to fund scientific Usher treatment research. And in that way, we feel that we can actually do something. And that gives us a feeling of being in control. Because when there is something seriously wrong with your health, it feels like you've lost control of your body and with that of your life. And I know control is an illusion. No one has full control about life. It's out of my hands whether or not my plane will crash on my way home, or my daughter's teacher will get sick tomorrow, or you will be willing to listen to my story. The thing we cannot control is control, but it's about the perception of control. And in regard to this perception of control, you as a health professional can make a remarkable impact. Let me take you back to the year 2001, the year that followed after I got my diagnosis. I had finally found out what I wanted to study. After a long search, after a long of considering different options, I had finally made my choice, and I was so happy. But just after that lucky day, I was in a white, uncomfortable room, all kinds of equipment around me for eye measurements and posters on the wall of the human eye. And I sat there in this big black leather patient chair, and I told my eye doctor that after the summer, I would enlist in the education of my dreams. Visual marketing. My eye doctor at that time was a man who was starting to get a bit older, and he had a white doctor's coat which he had buttoned up to the top. And he moved his chair towards me and looked me deep into my eyes, and he said, "Visual marketing? The name alone. You will become blind. If you really feel you need to do something, go learn a language. Maybe you can translate a book or something, but I'm afraid that's all you will be able to do in the future." But that's not all. I had another question for him. I asked him if it would be an option for me to obtain a driver's license, because at that moment my sight was still pretty okay during daytime, and as a kid I had struck a deal with my parents. If I never started smoking, they'd pay for my driving lessons as soon as I officially became an adult, because in the Netherlands that is the age where you're allowed to drive a car. But as if he hadn't crushed my dreams enough yet by ridiculing my choice of education, he answered this question just as rudely as he did the first. Driving a car with your eyesight? You'd be a danger on the road. No one will ever hand you a driver's license. Bam! He smashed all my hopes and all my dreams for the future. But did he really? Everyone is looking with the best intentions through their own lens of what would be realistic. This doctor projected his idea of reality about me on me, while he should have encouraged me to find my own reality. So, with a little help of my supportive environment, I decided to put this man's opinion aside and went to study visual marketing. And of course, I graduated. And a year after this, well, quite traumatizing conversation, I met a more empathetic type of ophthalmologist, and driving a car was discussed again, and according to her, I would still be able to learn to drive with my eyesight at that time during daylight. But she also asked me a very realistic question. Won't it be even more difficult for you to have to hand in your driver's license when your vision really gets too bad? I left that eye clinic with a completely different feeling. And while the fact remained that I was not going to get my driver's license, it was my decision now. I had a choice I could make. So, as a health professional, as a colleague, as a partner, as a friend, as a human being, you are, maybe, so much more often than you think, the one who determines someone's life. So please be a little careful. Because what that second doctor did was exactly what I needed at that moment. First of all, she gave me space to tell my story. Second, she truly acknowledged the injustice that had been done to me. So I felt seen, I felt heard. And third, she gave me control, or at least a feeling of control. And these three steps took her a few minutes of conversation, but it made an infinitive difference to me. Because for a long time, I thought that that first doctor had done something to me, that I had to prove he was wrong. But who did I really have to prove that to? Him or myself? Because as a result, I went beyond my physical limits for many years, and I even ended up in hospital with burnout. It was my third burnout, and I was only 30 years old. I was in the disease process for so long, and given the progressive nature of my illness, I was declared 100% unfit for work. I had to say goodbye to my job as a project and event manager that I loved so much, and got that perspective of being a couch potato in the future again. And I didn't want that. Closing the door to participating to the regular labor process might be the most difficult decision I ever had to make. Nevertheless, I also saw it as an opportunity to open the door to making my dream come true, to start my own company. Because I know I don't need to be able to see to have a vision. And I don't need to be able to hear to be heard. So no matter how bad my sight and my hearing are, I can always consume information, have an opinion about it, and keep sharing the stories, one way or the other. And now, I have the honor of being considered a role model by patients or parents from children who have been diagnosed with Usher syndrome, because I've unlocked my potential. I run my own business as a speaker about agility. I've written 2 books. I'm working on my 3rd. I train professional speakers and business leaders in their next level of speaking. I visit the coolest locations. I mean, NextMed Health in San Diego is really amazing and really a dream coming true. Thank you. I meet the most extraordinary people. And I get to inspire people with my story. I can do something good with the fact that I am dealing with Usher syndrome. And I am not done yet. Who knows what will happen next? And that I am granted these opportunities shows that whatever challenge I will have on my path in the future, I am in control and I can still contribute to society. But I would never have managed it without the help of my supportive environment. And you are part of a supportive environment too. For your patients, for the people around you. So open the cage. Show them role models. Give them the confidence that they are in control. Because with that, empower. Because that also makes healthcare more sustainable, more affordable, more accessible. So, if you can't cure, care. Thank you. Thank you.
Yeah, thank you.
Thank you.
Thank you. So first of all, I want to say thank you for your courage and for your conviction, because sharing our stories is kind of scary sometimes. So I really want to say thank you for that. And then the second thing that, well, there's no irony lost on me that your degree was in visual marketing. Like, that's pretty interesting. And the other part that you really pointed out is that words are tools of empowerment or oppression. So yours, it sounds like you're saying make sure that you're always choosing the words of empowerment.
Yes, absolutely.
Well, again, thank you so much for making the effort, because getting around is not easy, and coming from one part of the world to another part. And I wanted to make sure that you've got a guest with you, Viola. So I wanted to say thank you publicly to Viola for making sure that you're here. So anyway.
She's amazing.
She is. So thank you so much, and I am going to...
Thank you.
Got it? So how many people have jet lag? A little bit? Yeah. So the 4 o'clock afternoon time kind of rolls around and you're like, oh, look. So everybody stand up for just a second, and we've got some music. But partly what I want you to do is just like move around for just a second and say hello to the person next to you. That's right. Compliment them on their shoes. And I will tell you, this is the most dangerous thing somebody up on the stage can do, because then you lose complete control over the room. This clicker will go to Alistair's. Wait. Fantastic. So if I could get you guys all to sit down, because if we don't keep moving, then dinner is going to be really late and you're going to be super, super, super hungry. I will say that one of the most important success metrics of a conference is how loud the conversation is. So by that, I would say we're doing a really great job. Yeah. Okay, so let's dive back into this next section. How many here have ever heard of the social determinants of health? Yeah. So most of us really understand that the vast majority of our health, where that happens, it actually isn't inside of our healthcare systems or our clinics or working with healthcare providers. What determines how well we live, how long we live, oftentimes it's not our DNA, it is our zip code. Increasingly, over the last couple of years, I used to talk about technology creates what's possible. But what I've subsequently learned to know is that technology creates what's possible, but policy creates what is permissible. And increasingly, when we look at people's health outcomes, we start to understand that it's not the social determinants, but rather the political determinants of health. So a couple of years ago, I ran into somebody who was helping me to think a lot more about how you actually get healthier. And what I didn't know is the correlation and the understanding of our voting habits. And if we vote, who gets to vote, how you get introduced to learning how to vote. So the next person that we're bringing on, he has done some extraordinary work, not only as somebody who is influencing policy at the very highest levels. He recently served as assistant to the executive office. He was working with the office of the vice president with Vice President Kamala Harris. And then he's founded a couple of different organizations that really help us think about the connection between health and democracy. He's currently serving as the CEO of A Healthier Democracy. But what I also think, what he taught me an awful lot is that every single day we see the faces of failed policies that walk through our healthcare doors. And as an emergency physician, he sees them on a regular basis. So please help me welcome to the stage to talk more about the connection between health and democracy is Dr. Alistair Martin.
Thank you all very, very much. My name is Alistair Martin, and I'm an ER physician and CEO at A Healthier Democracy. I'm going to tell you a little bit about the work that we're doing at the intersection of healthcare and voting. But before I begin, I want to tell you a quick story. It was 2 a.m. on a Friday night, and I was at Boston Children's Hospital in the emergency room about 7 years ago. I had a young woman who came into the hospital who was in her early 20s. She came in with her 2 young children, both of whom were younger than the age of 3. She told me a story I'll never forget. She said, "Doctor, about 4 months ago, I left an abusive situation with the significant other, the father of my kids. It was dangerous for both my kids and myself, and so I moved us to Boston, to the only family that I had, which is an aunt who lives in the city." She said, "Doc, over the course of the last 4 months, things have been okay, but over the course of the last 2 days, because of her own mental health issues, she and I got into it, and she actually kicked me out and the kids out on the street. And yesterday, we spent the day in our van in the cold. Tonight, we were going to do the same thing, doctor. It was 2 degrees outside, and I looked back, and I saw my toddler, my young two-year-old, shivering in the back seat, heard his teeth chattering, and I knew there was no way I was going to do that to him again. So I came here because I didn't have anywhere else to go. Can you help me?" For the clinicians in the audience, you'll recognize this feeling of what the patient asks of you and what you know the healthcare system can deliver, that discrepancy. And it hurts in those moments. And I remember telling her, of course, I didn't say any of that to her. I said, "Of course we're going to help you, don't worry about it." And so I stepped out of the room and did what any self-respecting ER physician would do. I called social work. And I got on the phone, I said to the social worker, listen, we got this young woman, she's in her 20s, she's got her 2 kids. It's 2 degrees outside, and I'm not going to discharge her. And the shelters don't seem safe for her 2 children. What can we do? Social worker says, no problem, we'll take care of it. We've got a state-based program that we can actually get her in, transitional program, if she's a Massachusetts resident. So she needs some proof of residence, like a check stub or a phone bill, and if she has that, then we can get her into this transitional housing program. I said, no problem. Go back to the patient. I said, we can definitely help you. Do you have a check stub or a phone bill? The patient says to me, no, doc, as I just told you, 4 months ago I moved to this state and I don't have any of that stuff. I said, no problem. Don't worry about it. I take a step out of the room. I call the social worker. She doesn't have any of that stuff. She doesn't have a check stub or a phone bill. What can we do? The social worker says, well, look, there's nothing we can do. I said, there's got to be something. He says, okay, well, there's one thing that we can do. We can register her to vote. Her voter registration would count as proof of residence in the state of Massachusetts. So 2 things happened to me, NextMed. The first thing at this time was I immediately, on the phone, said, is this legal? The second thing was I left my education at Harvard Medical School as a medical student for 2 years, and I went to go to the Harvard Kennedy School to learn government and ostensibly to learn about public policy, and I had never learned that voter registration was legal in healthcare settings. And of course, the social worker said, yeah, it absolutely is legal. The National Voter Registration Act of 1993 legalizes and encourages hospitals to do voter registration. So Harvard, if you're listening, I want my money back. So I go back to the patient's room and I say to her, look, we can definitely help you. I have a sort of an unusual question for you, though. Do you want to register to vote? And what she told me, I'll never forget. I didn't know I could. No one has ever asked me that before. We got her registered to vote. We did get her into transitional housing. But the gears began turning for me, NextMed. How many of the patients that I had seen at that time were in a similar predicament, who felt on the outskirts of our democracy? She wasn't alone. In this country, there are 60 million people who are not registered to vote, but who are eligible. That's the entire population of the country of Spain. And when you ask people, why are you not registered to vote? The vast majority say, no one has ever asked. And so you see, we have an opportunity here. We have a demographic overlap. Those who are unregistered but eligible voters, and those who, quite frankly, are screwed by the healthcare system, the most marginalized. Okay? They tend to be younger, they tend to be lower income, and they tend to be people of color. These are people who come to my ER not because they have an emergency, but because they need a work note so they can get back to work, or so that they can get a prescription because they can't get a primary care doctor. Isn't this an opportunity to potentially use the healthcare system to invite these folks into the democracy that we all work to create, and to do so with trusted messengers like doctors, nurses, et cetera? So what's the so what of this? Why does this matter? This matters because when people don't vote, they're labeled as unlikely voters, and campaigns don't make contact. The candidates that are running for those offices, like senator or congressman or mayor, they don't listen to the perspectives of folks in those communities. Their perspectives, their concerns, their questions are not baked in to the policy platforms if and when those people become elected officials. And this has ramifications all across the healthcare system. Every city that we have looked at, we find the exact same pattern I'm showing you here. Let's look at East Harlem back in 2018. This very specific precinct had a 35% lower voter turnout rate than every other part of the city. Correspondingly, that same exact precinct, nearly 20-year life expectancy drop-off in the same exact district. You say, well, no, this might just be a New York City phenomenon. Let's look at Detroit. This little corner of southwest Detroit has 24 industrial sites. These are chemical plants. These are asphalt plants. These are oil refineries polluting the air and the streams in this part of Detroit. As a result, people who live in this part of Detroit live 7 years less than the rest of the country. They present to the ER with myocardial infarctions at higher rates and for asthma at higher rates. When we look at that corner of southwest Detroit, are we surprised to find that it has the lowest voter participation rate across all of Detroit and also across all of Michigan? My answer would be no, but let's tie it back. Those industrial sites had to go somewhere in Detroit, didn't they? Where do they decide to put those industrial sites? Where they know people are not. Okay? They're not going in the places where people are making their voices heard. Do you understand? And guess what? For the clinicians in the audience and the healthcare organizational leaders in this audience, we got to clean up the result of that. Okay? And it's not just cities and states. There's whole regions of the country. Look at this pattern. These are the stroke belt states. In these states, there's a higher preponderance of folks who have strokes and who die from stroke. They're the same exact states that got dinged in the 1965 Voting Rights Act. Why? Because these were the exact states that had a legacy of voter disenfranchisement. These are the exact same states that were not able to change any of their voting policies because ultimately the whole legacy of those states was to restrict access to the vote. They're the exact same state. You look at every single one of our measures that you look at health outcomes through, the same pattern exists where voting rates are low, so are health outcomes. Okay, so what do we do to reverse the cycle? We've got a downward spiral. How do we sort of flip the script, right? Create a positive virtuous cycle. We help people vote. We help people vote. Why? Because when people vote, they're labeled as likely voters. Campaigns make contact. They listen. They hear the perspectives. They include these perspectives into the policy platform. It's not rocket science. What we do with Vote ER is we have 3 different levers that we pull to help healthcare providers and healthcare systems register folks to vote. The first is what I'm wearing here. This is a Healthy Democracy Kit. So when I go to my shift on Thursday night, after our cacao ceremony, is that tonight or is that on Thursday? I'm not sure. These Healthy Democracy Kits, right, have a badge on the back of my ID badge, which allow patients to check their voter registration and register to vote or get a vote by mail ballot. These lanyards are what we call in behavioral science visual triggers. So patients will ask, hey doc, why does your lanyard say vote on it? And I'll say, well, it says vote on it because I want you to take 30 seconds to check your voter registration. We have 50,000 physicians, nurses, and social workers wearing these across the country. Next, we create posters, handouts, discharge paperwork, like you see here, which allow hospitals and clinics to register their patients to vote. Not only that, we allow all of the hospitals to track and see how many people they've registered to vote. So we can have Mass General compete against Johns Hopkins, and UCSF compete against UPenn, and it gets feisty. Lastly, we work with community health centers to register people to vote via text message, as you see here. We've sent millions of text messages and helped lots of patients register to vote via this program. Let's go over to Ohio. This is Dr. Stager, who's a pediatrician in Ohio, and she uses our scripts in her social history. She asks her patients, do you smoke? Do you drink? Are you registered to vote? As simple as that. 50,000 physicians like pediatricians, clinicians like nurses, social workers, residents are using these kits all across the country. Let's go to North Carolina. This is Dr. Smith. She has a private practice, and in her private practice, she uses our posters, our discharge paperwork, our handouts to help patients who are in her waiting room register to vote. There are 700 hospitals and clinics like Dr. Smith's across the country. You guys heard about Dr. Stager. Let me tell you about one of her patients. This is Lauren. She's 19. She was 19 at the time. And Dr. Stager helped her register to vote for the first time. Now, that's a cool story, and we sort of could like congratulate ourselves and pat ourselves on the back there. But what happened next is even cooler. Lauren went home and helped her sisters and her parents register to vote for the first time. And as a family, they voted for the first time. This is the power of just one clinician. This is the power of just one clinician and how the effect not only can shift from the individual, but to family systems getting communities out to vote. And so in summary, we've helped 80,000 folks across the country with vote by mail ballots, voter registration. We've helped 50,000 clinicians across the country get these kits to help their patients register to vote, hundreds of hospitals, and lots of associations and organizational partners across the country. But did these people actually vote? Did folks actually go out and vote on Election Day? The data has been astounding. The turnout rate of the folks that we helped to vote was 85%. That's nearly 20 percentage points higher than the average voter. There's something going on here. There's something about when your doctor talks to you about registration, or when the facility that takes care of you talks to you about voter registration. It's memorable. there's something about it that makes you more likely to actually vote when it comes to election day. But here's the part that I find most interesting. The effect was most pronounced on low propensity voters. These are people who have never voted before, or these are people who have voted very infrequently. There's something about this intervention for that group in particular that really gets them out. But it's not just about mobilizing individual clinicians and individual patients. We've also got to work with systems and organizations and build coalitions to do this work at the grass tops level. Back in August of 2020, we launched the first ever Civic Health Month, which is a national celebration of healthcare-based voter registration during the month of August. This coalition has been hard at work. The coalition together has put pressure on and worked with groups like the American Medical Association to pass and proclaim voting as a social determinant of health. Why is that important? That's important because hospitals and medical schools now, if they're trying to address the social determinants of health, well, the question becomes, what are you doing to help people vote? We work with HHS and VA to make sure that they have implements best practices, and they have an understanding of how to use some of what we've learned in the over 17,000 federally qualified health clinics to do voter registration across the country. And we've also worked, as you just heard about Civic Health Month, we've also worked with states all across the country to get governors to proclaim Civic Health Month. This is back in Massachusetts, and we're working with states all across the country to do the same exact thing. So what's next? For those of you who are not checking your calendar, the 2024 presidential election is what's next. There's a number of opportunities to get involved. Patients, clinicians, you can help your patients register to vote. You can go to voter.org/kit. You can get one of these kits. These are free. You're going to have a kit that will help you check your own voter registration, but not only that, you'll get a way of tracking your own impact and seeing how many patients you've registered to vote. Healthcare organizations like hospitals, startups, established organizations, you all can help your employees register to vote and also help patients, those that you serve, register as well. You can join us as a Civic Health Month partner in 2023 and help us do this work across the country. And then lastly, clinicians, if you're interested, if this resonates with you, come to our Civic Health Conference. It's on March 31st, 1 o'clock. We'll see you there. It's virtual. Lastly, we got to make sure that the clinicians, the physicians in the room looking at you, you are registered. Why? Because study after study has shown that we do not vote. This study in 2004 demonstrated that physicians vote at 10 percentage points lower than the general population. You don't want to know how much lawyers vote. They were like 22% higher than the general population. So you might be thinking, well, a lot has happened since 2004. This is probably no longer accurate. Unfortunately, not only is it still accurate, it's worse. This study was done just 2 years ago, which found that physicians voted at 14% lower rates than the general population. So we've got to clean up our own act. I started with a story, I'll end with a story. Before I left for DC, I was taking care of a patient who was in her early 20s, this Latina woman who was in with shortness of breath and a cough. It was very clear she had an asthma attack. We gave her some albuterol, some steroids, got her feeling better. And I had a little time that day, so I went back and discharged her myself. She saw my lanyard. She said, "Doc, why are you wearing that lanyard? Why does it say vote on it?" And I said to her, well, it says vote on it because it's very important that you take some time to check to make sure that you're registered to vote. I don't care who you vote for, but we have a big election coming up, the Boston mayoral race. And she said, "Doc, voting is not going to help me." I sat down and had a conversation. I said, "You see how you're here with asthma, right?" She said, "Yeah." I said, "You have asthma because the community that you live in has toxic smog and pollution. You live near an airport that has polluted the air and driven up the rates of asthma in your community. And when you come in here, of course I'm going to help you with your asthma. I'm going to give you a prescription for albuterol or steroids. But I can't take the smog out of the air. I can't remove the smog and the air pollutants that you breathe. You can do that by voting. You can do that by making your voice heard." We were able to register her to vote for the first time, and she was able to make her voice heard in that election. What I'm here to tell you all is that healthcare workers can help create a healthier democracy. We cannot do it alone, but without us, it cannot be done. Thank you all.
I am such a fan. Mine isn't tracked because I got I had one of the very first early ones.
The OG badge.
Yeah, but I will tell you, so this has been so profoundly impactful for me. I have become a voter registrar. So not only do I help people get registered to vote, like introducing them to it, but I'm actually now one of the registrars. And you're talking about, so many times people ask clinicians, like, we're so pressed for time. This is a great way to involve all of our students. It is a great way from the standpoint of, we would like to not have waiting rooms. We would not, but we do. We do, and this is a really perfect time. And what I have found in my own work is that it's super easy to put into the script. When was your last vaccine? How much do you consume of alcohol every single day? Are your guns safely stored? Have you registered to vote? It is like a no-brainer.
That's right.
When we first had our conversation, the piece of information that really galvanized me was the number of people who said they'd never been asked to vote. And what I realized is that I come from a place of privilege.
Right.
I mean,
Right.
I couldn't wait for the day that I got my driver's license. And there was a really big moment of having that driver's license, getting ready to counting the days, like, now I've got a driver's license, I can register to vote. I didn't realize what a place of privilege that is.
Right.
So your work is extraordinary. I'm so glad that you brought your executive director. Aliyah Bhatia is here. Do not leave without making sure that you check your own registration. Come up and scan that, but get one of these. As far as next steps, Civic Health Month, you talked a lot about medical schools. Nurses outnumber you.
Yes. 7-1.
Yeah, I was going to say there are 4 million of us.
Right.
They're just so in that ask as far as engaging clinicians, everybody. It's interesting that most people in this country are somehow or another related to a nurse. So there is a nurse in your life that you know really well. Check with them and make sure that they are active in helping to bring more people to voting. So with that, I think we need to go on.
Thank you so much.
Yeah. So thanks, guys.
Yes! He's doing amazing work. Hi, everyone. I am Robert Strong. Sit down, everyone. Sit down. A standing ovation. You're out of control. I'm your CMO, Chief Magic Officer. Daniel calls me your resident magician, which makes my parents very proud because they tell their friends that I'm in San Diego doing my residency. It's an honor to be here today. I am a magician, and magic is undefinable. You might know Arthur Clarke's definition: any sufficiently advanced technology is indistinguishable from magic. A little less famous one is Teller from Penn and Teller. Magic is sometimes somebody spending more time and energy on something than is reasonably expected, which is exactly what innovators like you do. My definition of magic is things just working so well and better than you expected, it just feels like magic. And since you're all working on digital health and predictive health, I have a little visual here of predictive health, but I'm going to use a deck of cards and get a random volunteer. A cloth frisbee, I'm going to throw it out there. Don't dodge it, catch it. We'll get a random volunteer. Land it right with that person. Hello, volunteer. Stay there, and you can hand it to somebody else. That's good. Sir, would you stand up right where you are with that cloth frisbee? Would you hold that frisbee? Don't throw it, just hold it. What is your name? Mario. That is correct. Mario, everyone. Mario, what do you do for a living, Mario? A physician. What's your specialty, Mario?
I'm licensed in general practice and use hospital medicine and mental health.
That's a lot of great stuff. Thank you, Mario. Now, this was a random pick. We've not ever met before. Mario, we're going to get a little video assist, and we're going to bring this up on the screen so everyone can see. This is a deck of cards which come in two colors, red and black. Hearts and diamonds are red. Clubs and spades are black. Mario, we were talking about predictive health, and this is what it would be like if we had predictive health using AI. Mario, what color is the card behind the Joker, red or black? This is a Joker. Behind the Joker is the next card, red or black, Mario? Red. That is correct. I'll show you. It is indeed a red card. Everybody, please hold your applause. Hold your applause. Hold your applause. Mario, pass the frisbee one direction or the other direction. Stay seated. What color is the next card? Black. That is correct. The next card is indeed black. Hand the frisbee. What color is the next card?
Black.
Do you want to change your mind to red?
Red.
No. Your choice. Which one, red or black?
Let's stick with black.
You got it, because the next card is indeed black. Hand the Frisbee. What color is the next card? You're going to go with black also. Correct. It is a black card. Let's do 5 more. Hand the Frisbee. Oh, a new direction. That changes everything. What color is the next card? Red or black? Red. That is correct. The next card is red. Let's do 4 more. Hand the Frisbee in any direction. What color? That is indeed red. What about the next person? What color? Red. Yes, that is red. 1 more. I heard black. We'll go with black. There it is, a black card, everyone. Oh, thank you, everyone. Now, I created something magical as my closing of this set, but I'll be doing some other things here at NextMed. What this is called is NextMed Jeopardy. It's magical, and you just can't lose. Who's got the Frisbee? Throw the Frisbee. We'll get a random volunteer. Throw it towards the other side of the room. Hello, catch it. Oh, I love the enthusiasm. Help, we need a doctor. Is there a doctor in the house? Yes, a few. Okay, you got it. Who's got the Frisbee? What's your name? Alan. Alan, would you stand up, please? What do you do for a living, Alan? J&J. Yes, they're a big company. Thank you for sponsoring, yes? Oh, we wish. I'm sorry. Could you just give a little money next time? Just a little money, okay? I know there's like a pandemic, and thank you for your future sponsorship. So the way NextMed Jeopardy works is there's 5 answers, there's 5 questions. And then I've got an extra 15 to make it impossible/magical. I'm going to add these over here. I'm going to give these a little shuffle, and your name again was? Alan. Alan, tell me when to stop. It's just like a big J&J company. They take their time. They don't move fast on sponsorship. We know that. Okay, where would you like it? 1, 2, 3, 4, 5? 3. I think you got the hang of it. Let's do it 4 more times a little faster. Where would you like it? 1. Let's do it again. 2 more times, please. We'll go this one. Where would you like it? 5. Last one. Excellent. Toss the Frisbee. We'll get another volunteer. Look at that toss. Wow, free. What's your name? Chris. What do you do, Chris? Health Tech Innovator. Have you met J&J here? You've worked with J&J. Good, yeah. I would like to switch some of the questions. Give me 2 to switch. 2 and 4. Well played. Is there any reason? They're even. Okay, another OCD person. I'm so OCD that I alphabetized them. CDO. You can toss the Frisbee up here? Yeah, on the count of 3. 1, 2, 3. Well done. And we'll leave it there for later. Okay, now the moment of truth. If all the 5 answers match the 5 questions, everybody here gets a gift. Answer number 1. We do the answer first because it's like Jeopardy. The answer, everyone, is ChatGPT. The answer is ChatGPT on NextMed Jeopardy. But the question, everyone, what will be the #1 cause of illiteracy in higher education? That is correct. We're off to a fantastic start. Answer number 2. Ooh, Silicon Valley Bank. The question is, what 3 words now gives everyone indigestion? That is correct. Silicon Valley Bank. Too soon, isn't it? Too soon. It's only Monday. Whew, everybody's sleeping now, finally. Okay, answer number 3. Blockchain, cryptocurrency, and metaverse. Metaverse. The question, everyone. Name 3 words to use on flights to ensure people leave you alone. That is correct. I work in metaverse. Answer number 4. Doctors who use AI is the answer. Doctors who use AI. But the question, everyone, what will AI replace doctors with? Doctors who use AI, correct? Last one, everyone. Answer first. The answer is George Santos. George Santos. And the question, everyone, who is the founder of NextMed? Correct! We did it! And since you all are the innovators, everybody gets a gift in the mail. I will send everybody here 500 free hours on AOL, the future of IM. I hope you enjoyed. My name's David Blaine. I'm sorry, Robert Strong. See you later, everyone. Thank you.
George Santos, everybody. All right, thank you. Robert Strong, our amazing comedy musician, our resident magician. Check him out. He'll be back for more. And tonight, before our chocolate sacred cacao ceremony, we'll be doing some fun mixing it up. And tomorrow night, learn some magic and maybe some neuroscience. So I think what we're learning through magic and through Alistair and others is that there's a power of story, whether it's around voting or it's around magic, or it's around telling a story about your new startup or an unmet need and solving for it. And we're really lucky to have back one of my favorite people, Dave Zabosky, who is the co-founder and chief creative officer of Electro, but also a former senior animator with Disney. He's been doing some amazing drawings of our sessions, and he'll be leading some art workshops as well. So let's leave it to Dave to tell a bit of a story about the power of story. Dave.
All right. All right. Thank you so much, Daniel. I am super delighted to be here. Let's talk story. We're going to talk about the power of story, but I'm going to tell you the tale that's the greatest tale ever told. I'm going to talk about the story of story. And it goes a little something like this. Imagine a world. All right, no, imagine I actually used that voice for this whole talk. I don't think so. All right, let me start over. Imagine a world floating in infinite space. A pale blue dot located on the lonely western edge of a spiral of stars so numerous that it makes the dark night sky look milky with their collective shine. A galaxy that has been, it's come into existence maybe 14 billion years ago. Then about 8 billion years ago was created, formed out of, energies known and unknown. Chaotic collective of rocks, planets, gaseous spheres, all obediently following a giant glowing orb that we call the sun. Then about 2.5 billion years ago, still a mind-boggling number, too vast for us to really wrap our minds around, life emerged on this blue-green gem floating in the inky blackness. And when life happened, when it took purchase, man, it took off. In about the 2.5 billion years that we've had life on this planet, there have been something like 100 million species. 100 million variations of life that are vying for this rarefied air. 100 million species that are swimming in the cool currents of seas known and unknown, feeling the rain fall from the sky. Now, right now, we think that there's about 10 million species on this planet. 10 million species is a mind-boggling display of biodiversity. But what it also means is that 90% of all life that's ever lived on this planet has gone extinct. Of 100 million species over 2.5 billion years, there's only one. There's only one species that has been able to take an experience, transmute that experience into some kind of knowledge, and then that knowledge over time becomes wisdom, and that wisdom begets culture. Now, sure, there are whale songs, and there are bird songs, and there's plenty of hoots and hollers coming out of the darkness. But really, there's only one species that knows the magic trick to life. There's only one species that tells stories, and that's us. And I would say that it is our great differentiator. It's our great gift. More than the large brain to body weight ratio, more than our massive prefrontal cortex, more than even these things are opposable thumbs, the greatest tool that we have is that we are storytellers. Now, I wonder what story you're here to tell. How do you tell a better story? My company, Lytro, we've leveraged over 450 of the world's greatest creatives and storytellers to help companies that are the most beloved companies and most beloved brands tell their best stories. That we have found that the ability to tell a great story is directly related to a business's success. especially with the founder's story. You know, what's the founder's story? What's the patient journey story? How do you tell that best story? What's the brand story? When you can tell a powerful story, that story will align all of your stakeholders. It'll align all of your employees. It will align your customers as part of your marketing department. That they will go out and repeat that story. We've found that word of mouth is the most powerful sales tool that there is still to this day. And so those people become the storytellers that help extol your virtues in the world. Believe it or not, stories matter. Stories might even, I would argue, make matter. That the most powerful way to engender belief in the world is to tell a great story. Now, believing is how we make something real. It's how we turn a thought into a thing. And if you don't believe me, let's do a little thought exercise. Imagine you find yourself in a situation. I don't know where we got the model for this drawing, but all right, so you find yourself in a situation. Let's just say the situation is you're being chased by a ravenous bear. This is a story that comes from the philosopher Stephen West. So you're being chased by this ravenous bear. Now, chances are you probably can't outrun the bear, all right? Now, ahead of you, there's a chasm. If you can leap over this chasm, then you can escape the bear. Now, if you believe it's possible, then you will make the leap. If you don't believe it's possible, you won't even try. So if you don't try, well, that might be a bad day for you, right? Of course, it wouldn't be a terrible day for the bear, but it'd be a bad day for you, right? Now, if you do make the leap, if you have belief, and that belief is even slightly present in you, and you take that jump, and a successful outcome happens after that jump, it was only possible because belief was present. And so it is believing that makes something real. It's believing that made it possible. Every made thing in this room, every made thing in your life is there because somebody believed that it was possible and somebody told a story about it. So what do you believe is possible? What stories are you telling? How well are you telling those stories about the things that you're creating, about how you're turning your thoughts into things? You know, I used to think, well, seeing is believing. And I was, you know, such a pithy statement that I could hold on to that. But really, maybe the truth is, and now that I know the power of story, maybe the truth really is believing is seeing. Now, stories evolve, and even that story is an evolution of the seeing is believing to believing is seeing. Stories evolve, and they reflect the consciousness of our time. All stories and all art is really a reflection of the consciousness of our time. And what's really exciting to me is that this evolution is happening right now. Like, we're in it in real time right now. You can feel stories evolving. Joanna Macy, the philosopher, talks about this idea of a great turning. She says that you can see it throughout history, great turnings where there's an evolution in the consciousness and how it's expressed to the world. And she says that you recognize a great turning by three elements. The first element, I'm going to go back here. The first element is what she calls the great unraveling. Now, we've had a great unraveling. Like, we've got, you know, sort of worldwide political upheaval. There's a war going on. There's one other thing. I can't remember. What is it? Oh, yeah, a pandemic, right? So we've had an unraveling. She says the second piece of a great turning is this vehement desire to return to the status quo, to re-ravel all of that unraveling, to go back when things were better, you know, to bring that stuff back again. But we know you can't stop the wheel from turning, and that leads us to that third element of a great turning, and that is the emergence of a new story. And so the evolution that I'm feeling is this evolution from this hero's journey that we've all been on to what's next. And the new story, that new story is this idea that the hero's journey that we've had in our zeitgeist for more than 50 years, starting with the Lone Ranger and then Superman and then Batman, all these singular heroes that we've had. The ideas that Joseph Campbell really so beautifully consolidated in his treatise on the hero's journey, and that was really perfectly delivered with George Lucas's Star Wars. But you want to know that inside of each one of those heroes' journeys, inside of each one of those stories, are seeds for its own evolution. And so you can see that when we've expanded those universes, when those stories have continued, we see that there are other heroes. And those other heroes have brought a constellation of other heroes around them. And that it's no longer a singular journey for a hero. That it's what Barbara Marx Hubbard called points of coherence, around which these constellation of heroes collaborate and collect. Joanna Macy calls this the kindred quest. But this is just a story, right? All right, so I'm going to step over here, and I'm going to invite us to look at this giant mirror ball of consciousness of our time and that we're dancing under, and see if there's another thing that we can look at to reinforce this idea of the evolution of the hero's journey. And that is that in 1977, the very same year that Star Wars premiered, Ilya Prigozhin won the Nobel Prize for what he called dissipative structures. Now, dissipative structures, very simply, are organic structures, organic systems that when energy is added to the system, they stabilize. They have a steady state. When energy rises or falls, they break into what seems like chaos and then reorganize in another steady state. You're probably familiar with this more colloquially. Yeah, we'll forget that one. You're probably more familiar with this in the study of cymatics. Cymatics is that where you put a sand on a plate and you vibrate the plate. And then that vibration creates a pattern, and then that pattern breaks into a kind of chaos and then reorganizes at higher states of organization, complexity, maybe even beauty. So maybe it's not chaos in between. Maybe this is the evolution of story. We've all seen this cymatics and seen it in two dimensions. But maybe what's really happening is it's not breaking into chaos. Maybe there is this hero's journey that's happening. Maybe we are those particles of sand. Maybe we are the organic matter that's adding energy to it. And that energy is going from a point of coherence to another point of coherence in our own hero's journey. And we're gathering our kin along the way. Maybe this very room is a point of coherence. You know, we've all had our hero's journey. We've all had a chance to sit at the feet of a mentor, a sage, a guru, and we've all gone out sword in hand and vanquished that demon from whose hoard we've gathered the elixir. You know, and according to that sort of hero's journey, we come back to our garden. But what we know is that we can't now come back to a garden and just have it be a singular garden. That we now have this emergent story of the kindred quest. That we have to have it be a collective garden. That it's no longer just us anymore. And this is my invitation to you. My invitation to you this week is to look for your kin. To look for them from this stage and from that beautiful beating heart that beats in you right now on this planet here today, that you are 1 in 100 million telling the story of our time with your beautiful works. That your fellowship is in this room and it's in this space. And they might even be sitting right next to you. So my invitation for you this week is to look for them. And here's my last provocation. My last provocation is that when we tell the story of our time, what if it went well? We are rare, alone, and privileged on what my friend Tulku Rinpoche calls this wish-fulfilling jewel of a planet. That tales of woe are easy. Post-apocalyptic stories are a dime a dozen. They're low-hanging fruit. If you want to really flex your 1 in 100 million gift, your 1 in 100 million species gift, tell the hard stories. Tell the stories of the things that you believe, that you know how to create. Tell those stories that are about our collective garden, that make this world a better place. The stories of us rising together. That's our kindred quest, that we rise together. And that's my story, and I'm sticking to it. Thank you very much, everybody.
Thank you, Dave. You'll be seeing some of his art and learning to do some art from him at some of the morning workshops and beyond. So thanks for sharing your story and the kindred quest. Onwards.
Pleasure. All right.
Thanks, Dave. All right. So part of the story, I think, of healthcare is that we're starting to connect the dots in new ways. We've already heard a lot of different technologies so far, even today, to put them to work in cohesive settings and in platforms. And we're really lucky to have with us two leaders from Deloitte, one of our wonderful partners, to talk a bit about the power of platforms and how they're sort of reimagining and reassembling care. So welcome Boris Kankevitz and Simon Gisby from Deloitte. Thanks.
So earlier on, Lucian had a really interesting example. An ambulance turns up, knocks on your door, and you go, "Why are you here?" And the response was, "Because in 2.5 minutes you'll have a heart attack." Now imagine if we go back, and not 2.5 minutes, but 12 hours before you get a nudge, text, call someone and says, "Hey Simon, I think you should probably come and see me. I'm your cardiologist. Because we think in 12 hours' time, you might have a cardiac event." Or even better, they come to my house. Now, we believe that 25% of people in hospital beds today in the US can be taken care of at home. And we all know that everyone prefers to be taken care of at home. But that's really difficult to do. And part of the conversation that Boris and I are going to have is how you start building that ecosystem that takes all these incredible point solutions that we've heard about today and knit them together to deliver that kind of business model. Because if you think about, what do I need to take care of someone at home? I need consumer products. One on the market today, right? We've heard about the smart mattress. We all know about Alexa is now HIPAA compliant. We've got the weight, the scales, and of course the one everyone loves is the smart toilet. And we've got wearables and all that kind of stuff. But how do we connect it into the home? Who's going to do that last mile logistics? Well, there are companies out there that do that really well. Right? It's called the Geek Squad. So now all of a sudden, we're starting to say, hey, maybe as we redefine and reinvent this industry, we have got to start playing with people we don't traditionally play with. And we've got to think about how to create that platform to bring all these disparate technologies and services and solutions together. We launched the Future of Health at this conference 5 years ago. And we made that statement. And it was greeted with a healthy degree of skepticism. Today, that statement, if you read it, everyone looks at it and goes, well, of course, there's going to be an educated consumer. Of course, we're going to have price transparency. Of course, we're going to have radically interoperable data systems. No one thought that 5 years ago, by the way, right? And yes, we're going to move from sick care to healthcare to wellness. And then the pandemic hit, and all that started coming true. And so, when we think about where our industry is going, we're still happily entrenched somewhere in wave 0 and wave 1. Right? You look at that legacy healthcare ecosystem, all those 5 disparate actors, and then outside is the consumer. We're not really engaged. And those 5 disparate actors aren't really focused on us, let's be candid. Digital health exploded. I think the number is $42 billion was invested in digital health and started this massive industry fragmentation, which we'll talk about a little bit later on, and started doing some of the hyper-specialization that we need in this industry. We believe we're somewhere between wave 1 and wave 2. We're starting to disrupt the incumbents, disrupt the status quo. We've seen other players come into the industry. And now they're starting to reassemble a different industry focused on the consumer, focused on making that migration from sick care to healthcare to well care, focused on the realization that if you are a certain age cohort, you have 1 comorbidity, there's a very strong chance you have 2, and if you've got 2, you've almost guaranteed to get a 3rd. We've been treating the 1, we haven't been treating the 3rd. We've been treating the ED at visit. We haven't been treating loneliness. Right? Simple causation. Loneliness leads to depression. Depression leads to lack of medication adherence. Lack of medication adherence leads to an ED visit. We know this. As an industry, we've treated the ED visit. As we get to industry reassembly, we're going to start treating loneliness, right? 5, 6 years ago, when we had a conference around sick care, how often was mental health discussed? Rarely, right? 5, 6, 7 years ago. Now it's front and center, right? We realize this. So that's what we're focused on. You can see wave 3, eventually, the age of biology, the incredible things happening in cell and gene therapy, and that's really going to migrate to preventative care. So what is a platform? A platform brings all these different participants, all these different wonderful point solutions, different players, different industries together to create an ecosystem which is focused on us, the unique needs of me compared to you, meeting my healthcare needs where I need to be met. One little fun fact, I think it's a fun fact. During COVID, we turned the physician into a gig worker. Think about that simple change. I could now engage with a primary care doc on my schedule in another location. And I could have the meds delivered wherever I wanted. I'd taken that relationship I typically have with my physician and turned them into a gig worker. That's a radical transformation in the industry. Just one little example that suddenly happened, right? But what it's going to mean is co-create goods and services. New goods, new services, social determinants, food as medicine, right? Super important. Wider customer reach, expanding access to care, tackling those huge issues that got exposed over the last 3 years about the disparity in healthcare, health equity, access to care. And we're going to do this by creating these platforms.
So as Simon described, we believe that platforms is going to be the business model to take us from the wave of fragmentation here to the wave of reassembly. And platform is often a buzzword, right? Let's deconstruct actually what it means. And I think Platform Revolution, the book, actually has a really elegant model for describing this. It classifies 2 types of businesses. There's the pipeline business and the platform business. The majority of businesses are pipeline businesses, in which case a producer goes ahead and manufactures a product, logistics pushes it out, marketing promotes it, and the consumer ultimately purchases it. They compete on costs, breadth, quality. When they want to grow, vertical integration and M&A seems to be a very common avenue, right? And they compete. You know, their advantage is normally economies of scale, maybe some IP. Now, a platform business, today's most iconic companies are platform businesses, and they're actually a radical departure from this model. They say, I don't need to own everything. I need to own the infrastructure and delegate production of an asset to the ecosystem. They find an underutilized asset, whether it's broadcast availability for Netflix or a ride in the form of Uber, and they say, I'll go ahead and delegate production of this to an ecosystem of drivers. I don't need to own it. They compete on network effects. They grow by incentivizing different partners to join in their ecosystem. And they differentiate by a superior experience. And we ran a lot of analysis because we believe these platform dynamics are prominent in health. And our analysis suggests that platform businesses will capture over 50% of all health spending in the next 2 decades. So now let's kind of bring it together here and ask ourselves the question, okay, how does this work in health, right? And we believe that for a platform to emerge in health, a dominant platform to convene the ecosystem of point solutions and innovative models that Simon described, it's going to require a platform mindset. You know, when you think of a platform mindset, we think of Apple and their expertise in cross-selling between the devices and upselling software. But that platform mindset, I think, is permeating in health today, and it means, you know, navigating patients, members, consumers to different sites of care, whether it's virtual, physical, or in the home, enabling providers with a set of tools and analytics to support the transition from fee-for-service to value-based care, advanced analytics to unlock learning effects on how to create these powerful connections between different parts of the ecosystem, and most importantly, not trying to own everything, but delegating key parts to the ecosystem. And we would contend, okay, who's going to be one of those dominant platforms? We think there's something to be said about the payviders. These are traditional insurance companies who have taken their earnings and invested it in unregulated parts of the value chain, whether it's care delivery, analytics, or pharmacy, right? Traditionally, they've been maybe constrained by technology, but now they're building a new chassis to go ahead and be a platform. There's, of course, the major consumer tech companies who are so expert at working with an ecosystem, who provide a superior experience and have a high NPS, but traditionally they haven't had that influence over the healthcare ecosystem, but they're certainly making acquisitions and partnerships now. And of course there's the retailers who have a captive customer base and a massive footprint, right? And at a certain point, one has to ask, okay, at what point do they connect all these disparate assets together and create learnings between them? And I think it's happening right now, possibly signals of this in primary care. And we've seen M&A and partnerships within primary care, particularly amongst retailers here.
And just before Boris moves on, what isn't on that slide about the disruptors? Health systems, medtech, pharma. Right? Point solution companies or providing a point solution in care. They are not driving this transformation. Please.
We would argue that what's happening in primary care right now is really interesting. You know, what platforms typically do is they rewire a value chain. They unbundle and rebundle it in new ways. This is the age of reassembly. And we believe that what's happening in primary care is taking lessons from prior industries. If we think back to television before streaming, there was a few dominant cable providers competing with a few dominant studios over a prized profit pool. Then streaming came in, leveraged the internet, modularized broadcast availability, and provided a diversity of content to different sub-communities out there. And now what's really interesting is you've got different streaming companies out there competing against each other and trying to rebundle some of this pie to provide more value for the consumer. Now, primary care, I think, is going through a similar analog here. Now, primary care doesn't entirely work today effectively, right? A lot of consumers are dissatisfied. Majority of millennials don't have a primary care physician. Only 75% of Medicare beneficiaries even do. Long wait times to go ahead and get an appointment. And we saw new care models in the wave of fragmentation that Simon had described earlier emerge, and they were really interesting. They were unbundling the primary care model in new ways. They were developing new care models focused on distinct sub-communities like Netflix, whether it was Asian Americans in an urban setting, whether it was millennials that needed virtual primary care. And they were thinking about what is the different services, what is the different modalities to meet the needs of the consumers. And so you had new care models that emerged providing care in the home to senior populations in an urban setting. You had new modalities for different communities out there, whether it was LGBTQ or African American. There was all this great experimentation, but then there's natural questions that one must ask after that, right? What is the boundary maybe between primary care and specialty care? Because I think what a lot of these experimenters and innovators identified was that it's more porous than one might suggest. And so what we're also seeing in the last couple of years was $40 billion in venture capital dollars flowing into all of these different conditions, creating virtual first specialty care companies across all of these different diseases. And we know that it's super complex to manage these diseases. We know that there's all these, that one needs to identify how this interrelates to treat a polychronic patient. And so we believe that there's an opportunity here for a platform business to emerge, to go ahead and aggregate a lot of these different virtual first specialty care companies to append it upon their existing platforms in primary care. And this might recontour some of the way we think about primary care and specialty care. And the question is, would it come from some of the actors that we identified as emerging as platforms? Would it come from the payviders, from the consumer tech companies, from the retailers?
And those platforms that get aggregated are going to start pulling together the unique solutions that I need to manage and treat my own health, which is different from the rest of you, right? Because at the moment, we're very much in a one-size-fits-all kind of response to healthcare needs. So there may be a particular condition I'm facing. It could be a physical condition, mental condition, social condition that allows me to access on this platform the solutions that I need. But see, these are some of the major questions. What does it mean when disruptor controls their consumer engagement? Well, the person that controls the engagement can start directing traffic, can start influencing and educating me about choices. How do health systems respond? Very heavily location focused. The economics of this. Do we drive to a model where we start sharing the outcomes? How do you have a payment model that pays for keeping people well, not treating people's sickness? How do these aggregators come in? Are they serious? How are they doing this? You notice the consumer tech companies don't refer to patients. They refer to consumers. They're relentlessly focused on their consumer experience. And then the last one, which I think is really fascinating, is how do you balance that personalization? Right? Because personalization doesn't typically lend itself to scale and economies of scale. So that's one we're thinking through. But that one I think is very interesting, because to really do that, we have to start sharing data. I know there's been a lot of conversations, a lot of presentations about AI and data and the use of data and the noise of data, and are people willing to share such intimate healthcare data? So I have a question. I always ask a question to the audience because I'm truly fascinated if someone knows the answer, because I don't. Who has TSA PreCheck? Who has Clear? Who did the eye retina scan for Clear? Now, people smarter than myself have told me that the eye retina is the single most unique identifier in the human body. Is that right? People are nodding. Yeah? So there's a show of hands over here of people who gave their eye retina to Clear. Do you know who owns Clear? Anyone know who owns Clear? $50, 5 minutes, LaGuardia Airport, Terminal D. And we are willing to give our single most unique identifier to a company we don't know who owns them. We don't know what they're going to do with the data, because we don't want to take our shoes off. And people are trying to convince me that we're not willing to share healthcare data if we can demonstrate it has a demonstrable positive outcome on our healthcare conditions. If we can prove that the sharing medical data will lead to better personal outcomes, I think the clear example, at least to me, demonstrates that people will happily share the data. Thank you for your time.
Thank you.
Really appreciate it.
Thanks, guys.
Thank you.
Thanks, Boris. Anything to get through TSA faster, I'm willing to give the data anytime, anywhere. So we've learned a lot, but one of the challenges at NextMed Health is how do we get to our next? And a real brief interlude from my friend Andrea Cates, who's helped over 13,000 teams go from inception to what's their next. Andrea Cates, share a little bit about lessons learned and where we're going next.
10 years ago, I lost a bet. I was working with companies to commercialize technology, and I thought I knew exactly who to bet on. So I bet on great ideas, great inspiration, great organizations, and it turns out 13,000 teams later, I lost every penny of that bet, because I thought that what was really important was the ideas, the inspiration. But it turns out the most important way not to lose a bet is to make sure that we end this week together with game-changing action that we believe we can move forward when we get back to our organizations, our communities, our teams on Monday morning. And so on Thursday, I'll be sharing the secrets, drum roll, of what it really takes to have impact, to use the inspiration, the amplification, and to really get to action. In 2013, when I lost that bet, I had just developed Find Your Next, which was the business genome trying to be applied to innovation. And I worked with the I-Corps program, and I was the CEO of a software company, the SaaS company, that was the backbone to all of these teams trying to commercialize. And boy, was I wrong. And when we studied the data, it turns out that it doesn't matter if we find something if we never get there. And as I said on Thursday, this is a preview, I'll be sharing the steps. And hopefully, between now and then, the challenge I'm putting out to everyone is as we interact, as we do the cacao tonight, as we dance silent disco, as we have breakfast together, as we have conversations, how can we allow ourselves to envision, expand, build, whether it's prototypes or building things together, co-creating, engage with others in an ecosystem or one-on-one, and actually activate. And on Thursday, I'll go through this framework. And in the meantime, I welcome all of us to really feel inspired, to feel that our community can amplify our ideas. I'm always braver when I have conversations in this setting. I have loved it for years, and every idea I have had has been amplified many times through this community. So I invite us to do that over the next few days. And then finally, there is no try, only do. And I hope that we, between now and Thursday, can develop some awesome burning questions. We'll be using that on Thursday. I'm hoping that we can have discussions about the ways we can amplify through ecosystems either of profit, ecosystems of platform, or hopefully ecosystems of purpose, where we can do what some of my clients last year did and, figured out home health. How long has that been on the radar? And I also think that the most value we can have is to help each other take concrete steps toward game-changing action. And I hope together we can have great experiences, great conversations, and feel emboldened and empowered so that on Thursday, we actually commit to something. And that was what would have won the bet, is figuring out the DNA of commitment. Because people have too many orphaned projects in large pharma companies where, you get partway through, you lose support. Or you get partway through working with a startup. And then I live in Silicon Valley, it's been a rough couple of days for us, right? So what will it take for us to end our time together with true commitment? So when we go back to our teams, we inspire everyone to engage in game-changing action. So that's a preview, it's a spark note, it's a summary, and it's an invitation to have conversations so that on Thursday we can get down to business and make our Monday morning ideas. See you Thursday.
Thanks, Andrea. Getting us to next concrete steps, that's key. So we're ending the home stretch for our very short first day. Thank you for staying present. We're kind of going to, our anchor summary of what's coming next. And that's this era of new era of precision well-being, improving not just lifespan, but health span, and leveraging our new omics from genome to phenome to take us to the next level. And to kind of get us started in this next phase is an old friend, Jamie Metzel. We were freshmen together at Brown. He's an amazing polymath thinker, the author of Hacking Darwin, a member of the WHO Expert Advisory Committee, who was testifying in front of Congress last week. founder of One Shared World. He's going to share a little bit about the promise and peril of human genome editing as we enter this next era. Jamie Metzel. And our chocolate shaman, shaman.
I have a side hustle in genetics. So thank you, everybody. Really thrilled to be back with you. I've been on faculty for NextMed since 2016, and I've learned a lot from Daniel in the 25 years that he and I have been friends. And one thing is to think big thoughts about the future, and the other is to speak really fast with a bunch of slides. So I'm going to jump right into it. Oops, hold on, I'm going to go backwards. So that was a little teaser about what's coming. So on this stage, in past years, I've spoken a lot about the future of genetic engineering and specifically human genetic engineering, which is what my book, Hacking Darwin, was about. And in those talks, I said, what I believe is that we are entering a new era where our one species among all the species that has ever lived suddenly has the increasing ability to read, write, and hack the code of life. And that, as I said, was going to have profound implications for the future of humans and the future of everything. And on this stage, I predicted that was coming soon, genome-edited babies. In that, and in my book, Hacking Darwin, I predicted that it would happen in China. And I had a list of the 5 genes that I thought were most likely to be manipulated that were in that book. And then, as many of you remember, November 28, 2018, this is He Jiankui, Chinese biophysicist, who at the second International Summit on Human Genome Editing announced, to the shock of almost everybody in the room, that the world's first CRISPR babies had been born. It was a shock. Everybody knew that this was coming, but nobody knew, not many people knew, that it was going to come that soon. And I personally was extremely pissed off for one selfish reason and one cosmic reason. The selfish reason was that my book, the hard copy version of my book, Hacking Darwin, was already on its way to the printers. And in that book, again, I had said, this is happening, it's happening soon, it's going to happen in China, and I'd listed the genes, but even I didn't think it was going to happen in 2018. And so I called my publisher and I said, I've got bad news and good news. The bad news is we have to pull the book out of publication. The good news is we don't, for the hardback version, we don't need to make many edits. We just need to say that this thing that I've predicted had happened on this day, and then we can make changes in the next edition, which we did. But on a cosmic level, the reason why I was so upset is that this is a profound step for humanity. Our species and all species have evolved for a little under 4 billion years. And if we are going to take the step of beginning to manipulate our heritable genome, that's a pretty profound step, and it needs to be done carefully, cautiously, conservatively, and in consultation with each other. This is a step that humanity was taking, and I felt this was highly unethical, an unethical step. But the reason why that I had predicted, and I think many people in this room share this idea, that we were going to have all of these coming quickly, is connected to the name of this event, whether it's exponential or next. But this idea of change, all of the speakers have spoken about this idea of change, but I want to talk a little bit about what I mean by it and why I think this idea of accelerating change is so profound. Most of you are I'm sure, familiar with the alphas. 2016, AlphaGo beat Lee Sedol, the world's greatest player at the time in the game of Go. People thought it was going to be decades until a AI system could beat human at Go because of the complexity of that game. But what AlphaGo had done essentially was swallow up the digitized games of Go masters. So it was kind of unfair that Lee Sedol was playing against all of the human Go masters. They were concentrated through the lessons learned in this AlphaGo program. 2017, AlphaZero, which was only fed the rules of Go and played against itself, and it took 3 days of playing against itself to get to the point where it could beat AlphaGo. The next year, 2018, the same company, DeepMind, had its new program, AlphaFold, which was designed to try to solve one of the greatest problems in biology, which is predicting the shapes of proteins based on the strings of amino acids. And as everybody knows, the way a protein functions isn't just based on its sequence, it's based on its shape. And they came in 18th place in the protein folding competition in 2018, went back to the drawing board, 2020, re-entered the competition, and won so handedly that Nature said that the problem of predicting proteins had been solved, which is a huge step for biology. And so in the process of characterizing a single protein, if you're characterizing a protein in a lab using X-ray crystallography, which until then was kind of the state of the art, it takes about 3 to 5 years to characterize a single protein. Let's call it 3 years. Lots of PhD theses, lots of postdocs focus on doing that. And so if you just say there are about 230 million proteins known to science, if you did it the old-fashioned way to try to characterize them all, that's 690 million years. So the next year, 2021, DeepMind, through AlphaFold, released the predicted shapes of 350,000 proteins, including all of the proteins in the human body, and that was a very big deal. And then the next year, which was last year, released 220 million of those proteins. And so if you take the 220 million times the 3 years to characterize all of those proteins, that's 660 million years thrown back into the pot of human creativity. There are people who say, well, humans are going to be displaced. I don't think that's the case at all. We have always, at least for all of modern history, we have co-evolved with our tools. And when our tools do something, that frees us to do something else. But earlier, Alfred was talking about GitHub. And he showed the example of typing the computer code, and then GitHub was just suggesting the next line of code. And he said, well, it's 50% faster to write computer code. When we add up all of these things that we would have previously done, and we throw that time back into the pot of human creativity, and it's not just human creativity, but it's human creativity empowered by these incredible tools, it makes me extremely excited about what we humans, if we get it right, what we humans and our AI systems and other technologies have the potential, if we do it right, to do together. And all of this translates into pretty much every field of science. We're talking about genome editing here, the incredible story, the incredible progress. In 2009, zinc finger nuclease was like the big story for genome editing. 2011, there was the new method TALENs, and they thought, wow, TALENs is really incredible. In the journal Nature Medicine, called TALENs the method of the year in 2011. Don't ever get the method of the year award, because it means you're going to get screwed the next year, because 2012 was when Jennifer Doudna and Emmanuel Charpentier had their later Nobel Prize-winning paper outlining CRISPR. And then people thought, wow, people were all excited about CRISPR. And then 2016 base editing, 2019 prime editing. You get where this is going. Every one of these technologies that we think, wow, this is the coolest thing ever, it ends up that technology is Pong. The coolest thing, ChatGPT 3 is Pong. ChatGPT 4, it's coming. That's Pong too, because when Pong happened, I remember in my basement in Kansas City, it was the coolest thing ever. We weren't comparing Pong to ChatGPT 4. We were comparing Pong to Pong. So every technology is the top of some old pyramid, and it's the bottom of the next pyramid. This is just the same story. It's almost like Pac-Man. You see these little Pac-Mans going through these technologies, and really we could be talking about anything. We're talking about genome editing. We could be talking about really any field at the intersection of genetics, biotech, and AI. And so what we're seeing, and again, I'm using the Daniel Kraft model because he's only given me 15 minutes to talk about all of this, is we're moving up the food chain, and we're moving back and forth in the time chain for the things that we are editing and considering editing, starting with model organisms, but moving up, and now, of course, the human applications. And these are what I call the easy, hard things. Like the easy, hard things are kind of the no-brainer applications for humans. Certainly, the research applications of genetic technologies and genome editing, knocking out or knocking in different genes to figure out what they do. Then there's the somatic gene therapies, which are exploding. And the gene therapies, as you know, like all of these technologies, there's summers followed by winters, followed by summers and springs, and all of the seasons. So now we are in the spring where there is a huge chain of gene therapies that are being applied, starting with the more accessible parts of the body. It's estimated 13 new gene therapies will be approved this year. That number is going to tick up every year. There's 2,000 clinical trials. Around 200 of them are in phase 3. So we're going to be entering this era where more and more gene therapies are going to be applied to humans. I talked about the 2018 Second International Summit on Human Genome Editing. This is a picture from last week at the Third International Summit on Human Genome Editing, which was held in London. And the cloud of He Jiankui, the dark cloud of He Jiankui, hovered over that last meeting in Hong Kong. But the bright cloud of this woman, Victoria Gray, was what illuminated the experience last week. Here was her words on Victoria Gray. I'm a 37-year-old mother of 4 and a sickle cell survivor. During this hospital stay, when she was being treated with the old ways, with ketamine infusion in one arm and a dilaudid infusion in the next, but still no pain relief, I called all the doctors into the room and told them that I could no longer live like this. I went home and continued to pray and look to God for answers. And then she got this treatment with the gene therapy. And then she said, the life that I once felt like I was only existing in, I am now thriving in. I stand here before you today as proof that miracles still happen and that God and science can coexist. When we talk about these technologies and people get scared, people say, oh, maybe we should shut this whole thing down because we're entering this new phase and humans are assuming these godlike capabilities. But we need to remember that these are technologies that have unlimited potential to do good. Asterisk. We'll come back to that. So this is just a quick thing of gene therapies for human applications. We're kind of in the middle, but I was in Kyoto recently talking about universal donor cell therapies, which is basically an idea for taking the cost down by making the applications more shareable, personalized therapies. All of this is on this same exponential curve of technological advancement and human and other applications. So let me talk for a moment on the promises of heritable human genome editing. One is to eliminate some heritable diseases. Germline, heritable genome editing, is not the cure for everything. But what I think what we should want is to say there will be an optimal time to treat everything. And some things will be optimally and most effectively treated at the stage of pre-implanted embryo, or even prior to pre-implanted embryo at the sperm or egg stage. Something will be in fetal surgery, some things will happen after birth, and some things will happen later in life. This question of therapy versus enhancement, it's kind of an easy shorthand that is wrong, that people say, well, I'm comfortable with therapy, I'm not comfortable with enhancement. Therapy and enhancement are cultural constructs. They're part of the same continuum, and we're going to have to suffer. We're going to have to struggle with questions of what is okay and what is not okay. I've written the whole book, and I've spoken here many times in the past on assisted reproduction. But we're entering an age where fewer and fewer of us are going to reproduce through the physical act of sex. We will still be sexually reproducing species, but we are going to want to bring more science into the act, into the reproduction process in the beginning, so we can reduce the threat of harmful diseases, dangerous abnormalities. But over time, again, because there's no clear line between therapy and enhancement, we're going to have to struggle with what is okay and what is not okay. What are some of the enhancements that we will want? Disease resistance, increased health span, maybe athletic ability, cosmetic, climate resistance, living in space, which we're not optimized to do. And over time, if our species wants to survive, we know this planet is not going to survive, so we're going to have some different biologies in order to do so. I mentioned my book. Chris Mason has this wonderful book, The Next 500 Years. But very, very real dangers. I'll just talk about a couple. Complexity. What we're talking about is very complex systems, ecosystems that have evolved over nearly 4 billion years. However much we know very, very, very little. Diversity, we think of diversity in the context of our universities and workplaces, but diversity is the sole survival strategy of our species. When Darwin talks about random mutation and natural selection, diversity is that random mutation. And there are very big challenges. This is me testifying last week in the United States Congress on COVID origins, but I believe there is a through line between the CRISPR baby story and the COVID story, at least with my analysis of what I think is the most likely origin, and that is these godlike technologies and capabilities connected to national politics in places like China. And so if we don't recognize that there are very, very real threats, we're going to be in danger. So after the He Jiankui debacle, there were all kinds of conversations about fears and where is humanity going. Of course, fears lead to reports. There were lots of reports, including, and then there was this commission that I had the honor of serving on, created by Dr. Tedros after the announcement of the CRISPR babies. And we worked for 2 years, and very, very hard. We came up with these recommendations, and I encourage you to go to the website, but lots of the really well thought out recommendations. The problem is what to do with those recommendations. We could give them to the WHO, but the WHO itself doesn't have much power. We have a world where different countries have their own regulatory systems, where there's no structure in place to bring different countries together. And so we're all kind of on our own. And that connects to this broader issue that our science is global in our interconnected world, and the consequences and the benefits of science are global, but we don't have a system for managing that new reality of our world. The greatest challenge we face in our world today is that the big problems we face are global and common in nature, but we don't have a framework for addressing that entire category of problems. That's the idea for One Shared World, which is our global interdependence movement. And it's connected to what we're doing here. I mean, some of you may be working in just an individual physician's office or in universities, but everything is connected. We are all part of these interconnected ecosystems, and therefore we each have a role. And that's my core message, is wherever you fit in this ecosystem, you have a responsibility to do what you are doing as ethically and carefully, as mindfully as possible, but also to be contributing at every other level, on your professional level, on a regional level, on a national level, and on a global level. So again, I had to do a Daniel because I just have a little bit of time. This is it's called a conflictisement. And thank you very, very much, and I hope to see you all later tonight. All right.
So not only you are a futurist and One Shared World founder, you are also titled and licensed as a chocolate shaman. So one of the fun things we're going to be doing tonight around 9 o'clock.
It's a self-licensure.
Cacao shaman. And
that we all too can get a PhD on YouTube on?
If you can just show up and I will dub you an official cacao shaman.
Cacao has a lot of medical benefits, which we'll talk about later.
Yes.
So join us in the Cornet room at 9 for Jamie and some fun and games and the cacao ceremony. So don't miss that.
I was just going to say, the headline I heard, more reproduction, less sex. Like, this is not a good thing.
It's true.
Might be what's next.
All right,
All right,
so
thank you, Jane.
tonight, it's a little bit chilly outside, so make sure that you dress warmly in layers. But we are going to meet out on Windsor Lawn, out under the stars for dinner. And then after that, just like we mentioned, we're going to have this fabulous cacao ceremony, and we're going to start with a little bit of magic. So eat, wrap up, bundle, sit close to next to somebody to keep warm. And then tomorrow morning, activities. We've got the VR workout that's in the Innovation Lab. We're going to have juggling with Ari. Yeah, he's going to be here. And then also Dave Zabosky is going to be in the Kent room, which is right around where the production office is. And he's going to be doing drawing. I think he's got a live model coming in.
We'll have meditation with Swami. Breakfast starts at 7 a.m. in the Innovation Lab. We start sharply on time at 8:30 here.
In the ballroom.
And you'll be getting an email tonight or in the morning at 6 a.m.
Wait. Okay, next slide, please. Yes, so tomorrow, NextMed Scrubs. We are going to have a printing press that'll have all of the scrubs available. You get to pick from those different designs, and then they'll also put the highway to heel. It's out by the garden patio, so you can pick it up at 7:30 all the way to 7, but do not miss out on getting your scrubs. Next slide. Okay, you're going to be getting an app or an email that's going to invite you to download the
Bina.ai.
Yeah, Bina.ai. And you'll want to have that because we've got a fabulous presentation tomorrow that includes music, and if you don't have that app,
Don't blow the thunder.
just download the app and be ready to collectively share information about ourselves and understand who we are as a group.
All right.
I think I've covered it.
Awesome.
All right.
Thank you, Shauna.
Thanks.
All right, so we're going to close with a legend in health and biomedicine, someone who's been creating Next for many decades. Amongst his many accomplishments, he's basically the inventor of modern DNA sequencing, helped presage and set up the entire human genome effort. He's a member of all 3 academies of science, of engineering, and of medicine. He's a true legend. We're lucky to have him here several years ago. A true creator of the future and of the now and of the next. Really, really honored to have Leroy Hood, who's the co-founder of the Institute of Systems Biology and also the CEO of Phenome Health, take us on a journey from what genomics and phenomics can do for precision population health and wellness. Dr. Leroy Hood.
Well, let me tell you a story of how I became interested in wellness and prevention. In 1970, I was a newly minted professor at Caltech, interested in human biology, but kind of staggered by the complexity of it, and realized at the time there weren't good tools for dealing with data. And I think there were 2 things that were really important. Is one, the only way to really deal with complexity, at least at that time, was to generate enormous amounts of data in humans, and 2, there weren't good tools for doing it. And this set me on a path that included 4 paradigm changes that I'll talk about. The first was developing 6 instruments, including the automated DNA sequencer, that allowed one to read and write DNA in various ways. The automated sequencer got me invited to the first meeting ever on the human genome, and I got very engaged in that, and that led to all sorts of possibilities we'll talk about shortly. Third, I had been thinking for about 15 years about how to analyze complexity and started articulating basic principles of systems biology, and that led to the Institute for Systems Biology in 2000, and finally in 2014 and 15 started the first studies on precision population health with a focus on wellness. And that's kind of where the story starts. And we'll talk about how we've now moved to a point where we can really think about catalyzing a shift from our current disease care to wellness and prevention. So, why health? I mean, it's an obvious question. I think the fundamental idea is health is the basis for human creativity, normal development, learning, happiness, and a whole variety of things, and it's obviously very, very fundamental in health in the best sense of the word, I mean. I started thinking a couple of years ago about when did our concept of health really first start. And what was interesting is it started with the Greeks. There's no history before 2,500 years or so ago, but what the Greeks thought was involved with health was fates, the self-behavior, and the environment. And it turns out they were right spot on, especially if you change fates to the genome. And I would argue that the one thing that's happened in the subsequent 20-some centuries that has really changed how we can think about health and what it really is a data-driven approach to individuals. I'm going to try and convince you as to just why that is so. And finally, I would argue again that although I didn't realize it back in 1970, what is critical to a data-driven approach to health is using systems biology to come to understand all of that complexity. And of course, this systems approach to health, the key point is that blood is a window into wellness and disease because it bathes all organs, and those organs secrete molecules whose concentrations change, and if you can read those concentration changes, you can assess in all of the major organs of the human being how things are at a given point in time. And of course, those quantitative figures get changed into data, and the data then can be moved into biological networks that underlie the physiology and the disease process and so forth. What exactly is data-driven health? And I would argue for us, it's all about doing the complete genome sequence and the longitudinal phenome, and we'll chat about that in just a moment. And I'll give you 3 points of validation for data-driven health for body, for brain, and for gut. And let me say, I think brain is one of the most ignored aspects of health in contemporary medicine today, and we'll talk just very briefly about what we're going to do about that. So what we're going to talk about later is a very large project. I call it a second genome project, which is called the Human Phenome Initiative, where we propose to do 1 million people over a period of 10 years. And the human phenome, of course, is our appearance all the way across our lives. There are 1 million different phenomes, and they change radically. And what is the basis that encodes that radical change is the genome, your self-behavior, and your environment, just exactly what the Greeks said, more or less. And the assays we're using to do these, as I hinted earlier, are blood analytics, proteins, metabolites, clinical chemistries, are the gut microbiome, are various modes of digital health, both for body and for brain. And the proof of principle for this whole idea is a company I started with Nathan Price in 2015 called Aravale, that over a 4-year period collected 5,000 individuals, and we did phenome analyses twice a year during that period of time. So we had longitudinal data clouds for each individual, and they drove us to this science of wellness and prevention, and you'll come to understand that. Number 2, we're partnering now with a company called Posit, the brainstorm of Michael Merzenich, who can use digital assessments, some 40 of them, to assess 25 different cognitive features, but not only assess, if the cognitive features are deficient, he can actually reconstitute to a certain extent those cognitive features, even in 80-year-olds. And finally, the gut microbiome, the microbes present in your gut that have a profound impact on health. We've also looked at those from the Airveil 5000. And what I can tell you is the Airveil has led to almost 30 papers in the last 7 or 8 years that define various features of wellness and prevention. And I'm going to talk just about several of these. Okay. Your advance is not advancing well. The first of these is really important because what we were able to see in the 5,000 people was 167 cases where the individual transitioned from wellness to disease. We took 10 cases where the transition was to cancer, and we looked at bloods prior to the clinical diagnosis, and we looked at proteins that were off scale compared to the normal population set that existed at that time point. And what we were able to demonstrate for every single one of those 10 cases is there were abnormal proteins, enormously increased in concentration generally, that marked the earliest transition between 1 and 5 years before the actual diagnosis. So it means we have the ability to be able to detect early transitions and think about multimodal therapies we can use to reverse disease before they become clinically manifest and when they are at the simplest level of their exposition. Point number 2 was fascinating. With the first 100 people we analyzed, we were able to look at the 6 data types and determine statistical correlations between them, and we saw 3,500 such correlations, and these turned out to be a fuzzy hairball of statistical correlations. But if you used an algorithm that operationally cleaved the edges that had the lowest probabilities, they deconvoluted into 70 communities of those features that correlated beautifully with physiology and or with disease. And you can see some of the examples of ones that we had. And when we looked at one disease, one community correlation, that is for cholesterol, we saw that there are 12 analytes, and one of them, thyroxine, had a profoundly negative correlation. And it turned out that this proposed drug was actually at the time being tested by Lilly. And so what we next did was to take the same 100 patients and look at 5,000 proteins. We got 35,000 correlations. We got hundreds of communities, and virtually all of the original communities expanded enormously in the number of correlations. So this is an incredibly powerful new approach for drug discovery and so forth. The gut microbiome obviously is very important, and what we did here was to take 9,000 individuals starting at 60 years of age and going through 88 years or so of age and follow their gut microbiomes on a regular twice-a-year basis. And what we were able to show beautifully is for people that aged in a healthy manner, 2 things happened. One, they lost the core taxa that were present in the 20s and 30s. And 2, they developed uniquely individual microbiota. Each of them did differently. Whereas if you were unhealthy, you neither lost your core microbiota, nor did you evolve a uniquely diversifying gut microbiome. And in fact, what we were able to show beautifully in the cadre that was in the 80s, that the individuals that were unhealthy were 4 times as likely to die as those unhealthy. And this opens up the possibility of manipulating the gut microbiome to optimize a healthy aging in really interesting kinds of ways. There are really 2 kinds of wellness: traditional wellness that you've all heard about, many companies exist, and the data-driven wellness, which create actionable possibilities. That is, from statistical correlations come opportunities to do things that either improve wellness or avoid disease. And we can get them from the genome. And what I'll point out at the genome is there are of the order of 600 variants that correlate with various physical deficiencies, like the ability to tear ACLs very easily. And if you know you have those deficiencies, you can actually do exercises that will block them. And we can look at the phenome and get actionable possibilities, or we can integrate things together. But the really important point is that the data-driven scientific wellness, when fed back into traditional wellness, can give you unique trajectories that each person should follow with regard to diet, exercise, sleep, and stress management. So the 2 beautifully work together. The vision, actually, I think is a really important one because it asks the really fundamental question, what exactly is health? And then I'm going to show you about phenome health and the initiative I talked about. So the data-driven vision is essentially assessing and optimizing the health trajectory of each individual. And the health trajectory, of course, is what happens to you along your entire lifetime. There are 3 different transitions. Most of us start in wellness. We can undergo a transition to disease, which progresses, generally resolves, and takes us back to wellness. And we've actually shown in 2 mouse model systems where we can induce at will the disease, prion disease, a neurodegenerative one, and glioblastoma cancer, that from the point of induction, there is a beautiful exponential increase in disease-perturbed networks that are deficient, that grow increasingly in their complexity. And the other point I'm going to make is that for most chronic diseases like cancer or diabetes, you have multiple subtypes of these things, and that's the first thing you should define. And then once you've defined a subtype, you can define the nature of that particular subtype trajectory. So it's important to say we can deal with wellness, transitions, or disease in interesting ways. Most of you probably reach 20 to 30% of your potential wellness. And we can increase that enormously just with the hundreds of actionable possibilities we've already defined. One of the really important questions is, do you have the will to really push to do that? And where it's important is when you get old, okay? Because you'll be in much better shape then. With transitions, we can already begin to see, by using multimodal approaches to cancer and other transitions, we can begin to think about therapies. And what is really attractive is the idea with this kind of data-driven health that you could pick up most transitions to most chronic diseases and reverse them before you get the disease. And of course, with disease, you can define subtypes. You can define transitions within a subtype and use the classic precision of medicine and everything. So health really has these 3 features: wellness, transitions, and disease. And I would argue this is the greatest paradigm change ever if we can move to a wellness and prevention mode in the history of medicine. So what's next? It's this Human Phenome Initiative I started 2 years ago, Phenome Health, which is a nonprofit that is driving this human initiative, and will talk about its two features. In the short term, what we plan to do is take the 4 major chronic diseases, starting with diabetes, and doing intense data-driven analyses of each of them over extended periods of time. And I'm going to define that in a little more detail in just a few minutes. And in the longer term, we hope to have the Million Person Project funded by the government, just as we did the first Human Genome Project back in 1990, over a period of 10 years or so. Where are we in Phenome Health now? Well, we've generated a partner Guardian Research Network, which has access to 50 million patients. It's learned how to translate their electronic health records into both structured and unstructured data. So with their very complete electronic health records, they've been permissioned for clinical trials, so it'll be easy to get things started in that population. And what's important is the 150 hospitals that they represent are all community hospitals, and the patients are sticky. They stay their entire lifetime with a single institution, so we have electronic health records that go back to the beginning of whenever they started to make that. A second partner is BrainHQ. It's the digital assessment of brain cognition that's going to be a fundamental part of what we're doing. We hired a marvelous, very small company of software engineers that has built us a combinatorial platform that essentially carries out all of the procedures we need for these multi-omic analyses, and we're actually going to probably be using that in the context of partners that we're accumulating right now. We've had a 2-year interaction with Google, and there we see using search, cloud, digital health, which is the Fitbit, and hyperscale AI, which is essentially the ability to do combinatoric analyses at 6 or 8 orders of magnitude greater than what most academics have access to. It's an aspect of the current rage that's out there. ISB has taught us how to use knowledge graphs and how to use digital twins, and I'll say more about those in just a moment. And Scientific American actually has just published an 80-page issue on the new science of wellness. And this is a terrific teaching tool for physicians and for patients themselves. And we've raised the money to be able to do various things. So we're going to do blood analytics, and I won't run through all the different things we're going to do. But we figure we'll generate at least 1,000 times more data than we did with the initial individuals in the Airvale population. We're going to do the brain assays, we're going to do microbiome assays, and we have several metrics that we'll be using at every blood draw. We have a beautiful biological age metric that uses metabolites and makes recommendations about how to optimize not only globally how you age, but how major organs age as well. And we've just defined a metabolic BMI that is far better than the physical BMI that we'll be using to assess metabolic state and so forth. Self-tracking with Fitbit and possibly other devices. Electronic health records are a really important part of initial phase of clinical trials. And then the social determinants of health and self-reporting. And we're doing whole genome analysis for every single individual patient. What's next in the Human Phenome Initiative then? Well, again, it's this idea of a data-rich observational series of studies starting with type 2 diabetes and generating all the kinds of data that we talked about here that will lead to vast conclusions. And the essence of this approach is a threefold tack. We'll use, and we have finished with this almost, 10 million electronic health records that have 11% diagnosed diabetes, have about 30% prediabetes, and the rest are normal. And what we're doing with those is looking for clinical markers to define the subtypes of diabetes, which there are supposedly 4, and then to follow the transitions within the subtype we're most interested in, the one leading to chronic kidney disease, which costs the healthcare system enormous amounts of money. So we have markers now then that will allow us to pile the patients up, 250 at each of the hypothetical 4 transition points. And then we'll move to the second prospective trial where we'll do the very dense data analyses, including deep immune analyses where at each blood draw we analyze at the single cell level the transcriptomes, cell surface proteins, and secreted proteins. And it gives us an integrated state and comparison of adaptive and innate immunity beautifully, which has never been done in a clinical trial before like this. And once we learn about subtypes and transitions and so forth, then we can think about trials that are interventional, optimizing the biomarkers for key transition points and drug targets and the like. So, let me talk briefly about hyperscale AI and the individual patient data analyses. So just to put things in context, we're going to be using 2 knowledge graphs, one from Google, which has 50 billion nodes and 850 billion edges. And of course, the nodes are things like genes and proteins and gene and diseases and so forth. And Spoke, which is something that came out of UCSF that is much, much smaller, but it's enormously more detailed in its delineation of features and everything like that. And to show you the kind of data that we have to worry about, from the first time point we take a patient in the diabetes trial, the genome will be 120 gigabases. The phenome is very small. The microbiome, 100 gigabases. Digital health is as large as you want to make it, basically, and single cell analysis is hundreds of gigabases. So we need the platform that we created to be able to deal, obviously, with this kind of data. So beyond big data, how do we unite that with big knowledge in hyperscale AI? Well, that represents the individual patient data that we'll be generating, and the traditional approaches that we used were classic statistical analysis, which allowed us to do the correlations that led us back to the literature that gave us the actionable possibilities. But what we plan to do is the 2 types of knowledge graphs that I've defined there, and they will both be fed into a digital twin we're building for type 2 diabetes. So from the top down, the digital twin, we put in all of the mechanistic generally differential equations that have been developed together with the physiology of the disease. From the bottom up, we'll add all the omics and biochemistry and clinical chemistries we have on type 2 diabetes. And what is really key is we'll add all of the patients that we acquire, their data to the digital twin as quickly as we can. Now, what those things together do is set a context for the hyperscale AI so that it can operate in the right territory to make detections about the individual's own patterns and losses and abnormalities in a way that's not been possible before. And indeed, there are some that argue with the kind of comparisons that can be made and the level at which they can be made, there may be a possibility in the future you're not just going to end up getting statistical definition of correlations, but to lead directly to mechanistic and causal explanations. And of course, this is an enormous debate. But I think putting type 2 diabetes into this will absolutely transform how we deal with individual patients in the future. So let me just say the final thing I'll talk about is a systems approach to healthcare, which we thought about in the early 2000s, ended up arguing that it should be predictive, preventive, personalized, and participatory, or P4 medicine. And what is interesting about P4 medicine is the first 3 Ps are science, and I really think we know how to do the science. The 4th P is participatory, and that involves psychology and sociology and economics and education, and I think this is the challenge. How do you persuade the patient, the physician, the healthcare leader, the healthcare technologist? How do you persuade the regulators? How do you persuade the payers, the politicians, and all to buy into this kind of thing? I think there's frankly only one solution, and we're not really going to have time to talk about it in detail, but I think that the kind of medicine I've talked about here, prediction and prevention, is going to save trillions of dollars in money, and it's going to make prevention and wellness more profitable than disease. That sounds like a radical statement. We've done a whole series of things on the education. We've written a textbook on systems biology and systems medicine, and I hope medical schools will adopt it, although I have to say I'm really skeptical. I think medical schools are unbelievably conservative and unwilling to think about much of anything that's very new. And I can tell you, I went to Hopkins, my alma mater, 3 different times trying this, and I gave up finally. We initiated with a group of 8 wonderful educators I created at the Institute for Systems Biology based on this textbook. A year-long 20-module course on systems and P4 medicine for high school students. And I'll guarantee you, if they come out of that course, they'll know more than 95% of the doctors will about medicine in the future. And we're actually going to adopt that course for weekend teaching of physicians. And I hope it won't be too difficult for the physicians. Wrote a popular book with Nathan Price during COVID times called The Age of Scientific Wellness, which talks about all the things that I've done here, and that's going to be available from Harvard University Press in April. I've written a bunch of op-ed pieces for the Times, and we're doing a 90-minute documentary on wellness over the last 5,000 years called The Phenome Age, A Quest for Wellness. And it's done by a terrific Italian director who is a real artist. And then I mentioned the partnership with Scientific American, funded actually by Google, on this new issue of the new science of wellness, which is a great place to start if you want to learn about all of this. So what exactly is next then? This million-person project is what I really hope to get going in the next few years. And if we have 1 million people over 10 years, we'll be able to answer, I think, all 5 of the fundamental challenges healthcare faces today: poor quality, aging population, explosion of chronic diseases, racial inequities, and finally the escalating costs. I think all of those will have a solution beautifully in the Human Phenome Initiative. Thank you.
Thank you. Wait.
You want to ask a question?
One quick question. We're about to go to dinner, but one quick question. Don't leave quite yet. If you were to give this amazing audience here online one sort of mission to get to Next, you've been a great instigator from P4 Medicine, systems biology. Any scintillated synthesis of how to get to Next that you've taken away from your experience?
I think in the end, the key to everything has been systems thinking. Mm-hmm. It's the key to the science. It's the key to the education. It's the key to the organization. Every way you look, you see systems thinking and systems approaches are going to be the solution. So my advice is to apply this freely to everything, and things begin to fit together and converge in very beautiful ways that way.
And I think that's the theme of this community. It's convergence to system thinking. It's no one technology. It's bringing it all together. Before you go, since you've been such a disruptor, and we have the special Medical Entrepreneurship and Disruption Award, the MEDI, we have a special MEDI Award for you as key disruptor for our age. Leroy Hood, let's give it up.
Oh, thank you.
Thanks so much. MEDI Award.
Thank you. Great.
Off to dinner, and then to the Sacred Cacao Ceremony. Thank you, Leroy Hood. Thanks for playing hard all day. We'll see you early, 8:30 morning. Innovation Lab at 7, Cacao Ceremony at 9. Let's rock it from here. Thanks.
Good.
All right.
Welcome back to the live stream, everyone. Day one of NextMed Health is a wrap, and I am joined here by Daniel Kraft, the one and only, the curator of the event. And it's been a day full of incredible speakers, incredible discussions, conversations, things that you couldn't see. We're here in the Innovation Hall, lots of great technologies, but really we want to provide a nice sort of wrap to the day. So I'm going to find out from Daniel what he thought was his highlight of the day.
It's hard to have one highlight for the day. Number one, the fact that we actually got the day going, thanks to you and the whole team and our crew and production and the participants and those of you online for joining. I mean, it's quite an effort to get to next, and now we've reached NextMed Health. And what was a highlight for me today was, again, how quick things are moving. I always talk about exponential technology and change, but to see what's happening in our opening sessions, we talked a lot about AI, ChatGPT, generative health, democratized data, and to see that really hitting healthcare in new ways and potentials which are still almost untapped is exciting. So it's great to have that sort of as an opening technology block. So we always start NextMed Health with, like, what's the leading technologies from AI elements to what's happening in synthetic biology, Andrew Hessel, because not only can we can read DNA, we can start to write it. We had Baroness Nicola Blackwood, the chair of Genomics England, and Chris Wigley, talking about genomics and what they're doing at scale with millions of Brits and now connecting the dots. So today was about starting to dive a bit deep on the technology and start to connect the dots, which will feed into the next days of NextMed Health.
Yeah, it was like drinking water from a fire hose. I mean, there was just so much thrown at you. And quite frankly, it's funny because the things that we're seeing today, I feel like if you date back 10 years ago, that was the next. And now we're seeing it in today's environment. And so it's really amazing to see some of these innovations advance and what we can expect over the course of the next 10 years or so. So what do we have set for the next couple of days?
Well, just on that point, so NextMed Health right now is 10 years after our first event here. It's then called FutureMed 10 years ago. And a lot of what was early then is now established. Dave Albert with his early AliveCore is now selling like hotcakes, and you can do your home EKG. We had companies like Echo, the stethoscope, now out at scale. The genome then was $10,000. Now it's $100. The idea of using AI for real was nascent. Now we're seeing it now applied in all sorts of settings. So we've seen a lot of things predicted become real, and I think it's going to be exciting if we look a decade now at this tape. What will have been predicted might be coming faster than we think. So what's coming next in the next couple of days? Tomorrow morning we have an amazing opening sort of keynote session with Ron Ballister out of Israel. He's the head of Khalid's innovation group. Khalid is sort of the largest healthcare system in Israel, has amazing sets of data. They've helped drive a lot of the insights into the COVID vaccines and public health and beyond. I'm paired him up with Mike Snyder, the chairman of Genetics at Stanford, kind of the most quantified guy on the planet. He's done a lot of work on taking multi-omics, wearable data, and making that really insightful and actionable. That's our morning start piece. We'll go into digital health with Preet Sivatanka, Dave Albert, Jen Goldsack from Digital Medicine Society. We'll go into systems and healthcare, things with Rasu Shrestha from Atrium, and with John Madison and Chris Longhurst from UCSD. So how's that impacting big hospitals and healthcare systems? That's a bit of just the morning coming tomorrow.
It's like seeing Daniel Kraft's slide deck come alive in real life to see some of these innovations. We have here something really interesting. So Click Health shared something about life-saving radio, which is an incredible concept about how music in the operating room can impact outcomes of surgery. So can you touch on that a little bit?
I think we're all familiar with the idea of flow state. Sometimes music can help us get into a focus, whether we're typing or we're doing any sort of activity, and that goes to the surgeon or the clinician. And so Click drove this amazing project we were lucky to collaborate on called Highway to Heal. They looked at a study that showed that in the operating room, surgeons listening specifically to AC/DC had better precision and some better outcomes. And so produced this incredible Highway to Heal album, kind of a riff on a parody of Highway to Hell, with an amazing album recorded by the most amazing cover band, essentially. And they've got songs like You Sewed Me All Night Long, Back is Cracked, Surgery's Done Dirt Cheap, Shoot to Drill, Hell Swell. So kind of a fun idea, but we actually tried it with some of our surgical faculty. They loved it. This idea that this sort of AI healthcare radio that's going to be personalized, tuned to your particular surgeon. Maybe always AC/DC. I'm a Beatles fan personally.
It was Guns N' Roses for me.
Yeah, and the fact that we'll be able to use music to help clinical outcomes. So I think the idea and pioneered in the first album is a fun, engaging way to think about how can music help heal, how can it help starting with surgeons, but I think all clinicians and all patients can be enhanced using the right flow and music.
Well, it was an extremely exciting day. Thank you all for joining us, for those who watched in, and please share the link across with your colleagues and friends for tomorrow. We kick off tomorrow morning, live stream. It'll be Shauna and I again at 8 a.m. Pacific Standard Time. So please do join in. We've got programming throughout the day. Daniel's going to be dropping in every now and then as well, and we might bring in some speakers. Again, we're tracking on Twitter, so please drop in your message. Anything for us, if you have questions, we're going to follow some of those tweets and maybe share some of them out during some of the breaks tomorrow. We want to make this as interactive and as engaging as possible. So please join in on the conversation, and we'll see you tomorrow.
Great. Thanks for your help.
Thank you.
On to the future.